Python is one of the most popular programming languages. It is used in AI, automation, machine learning, web development, backend services, and a bunch more. In this course, you will learn everything you need to get started with Python. I'm going to talk about all the core concepts in Python, and then we are going to build 4 projects together. Hi, my name is Ridwan and the creator of this Python course. If you wouldn't mind, like, comment, and subscribe. Thanks. Hello friends, and welcome to the Learn Python series. The very first step we need to do is to have Python installed on our machine. To check if Python is installed on Windows, we need to open up the PowerShell app. On the PowerShell app, we need to type the Python command. So if nothing is returned from the command, that simply means that Python is not yet installed on the machine. To have Python installation, we need to visit the python.org website, where we would be able to see the download tab. On the download tab, we can see that the latest version of Python, as at the time of recording this video, is Python 3.11.4. This may vary depending on the time you are watching this video. Download the latest version of Python by clicking this button. I am not going to download again because I've already done that. Once you are done with the download, you can find the installer on the downloads folder. So on the downloads folder, we need to start the process of installation. Run as administrator. Also remember to add this path, then click on install now. The installation is successful. To confirm that everything is working fine, we need to open up the PowerShell app again. Let's type Python. We can start writing some basic code. Print. This completes the installation process on Windows machine. On Ubuntu distribution, there is a good chance that Python is pre-installed. However, it may not be the latest version available. Let's open up the terminal to see the version pre-installed. We simply type Python. This shows that the version pre-installed is Python 3.10.0, and the Ubuntu version, we can check it. When you type Python and press the enter key on the keyboard, the interactive Python shell is launched. This is where you can execute Python code and see the results immediately. For instance, I can say 1 + 1 print hello world. To exit out of a Python shell, we simply type exit. If you found this video helpful, please consider liking, commenting, and subscribing to the channel. Until the next video, goodbye. Hi friends, and welcome. In this lesson, we are going to explore what identifiers and variables are in Python. In the previous lesson, we installed Python on both Windows and Ubuntu machine. Additionally, we wrote few lines of code on the Python shell. Writing code on the Python shell works fine for simple tasks, but it becomes difficult to manage as the lines of code get larger. As a result of this, we need to install an editor to write code more efficiently. Think of an editor as a Microsoft Word for code. Just as Microsoft Word is used for writing Word documents like letters, a code editor is used for writing code. For the purpose of this tutorial, I'm going to use a code editor called VS Code. Feel free to download any other code editor of your choice. If you are using Windows or macOS, open up the browser and search download VS Code. Click on the first link, which is the official website of Visual Studio Code. For Windows, click on the download icon. By now we have it started. In the downloads folder, we need to click on the installer. Right click, run as administrator. We need to accept the agreement. Next. Also, I would like to create an icon. Click on next. Right now, we have successfully installed VS Code. Click on finish. This is going to launch the VS Code. Clicking on this icon shows the files and folders we have in the working directory. I'm going to create a folder which is going to contain all my work files. On the desktop, I'm going to create a new folder called Learn Python. Then let's move back to the VS Code. On the VS Code, click on Open Folder. Then choose Desktop. Then I'm going to choose the folder I just created. Select folder. By now, we have the Learn Python folder as the working directory. This icon here shows how to create a new file, while the next one shows how to create a new folder. For now, I'm going to create a file. Click on this icon to create a new file. Enter the name of the file, variable.py. Remember, we are dealing with Python, so every file we are creating, that is Python files, they must end with .py. By now, we have this file created. Save it by pressing Ctrl S. To run this Python code, we need to click on this icon. Click New Terminal. On the terminal, we need to type Python, then the name of the file we just created, which is variable.py. Then press Enter on the keyboard. We have the result from the code printed on the terminal. This is how we can write hundreds of lines of code in a file and run it. On a Ubuntu machine, one possible way of installing VS Code is to visit the Ubuntu software. Click on this menu icon, then search Ubuntu. Click on the Ubuntu software. On the Ubuntu software, search VS Code. Click on the VS Code. Because I have it installed, I can see this trash icon. Otherwise, it should be installed now. Once you are done with the installation, you can search the software from here. This shows Visual Studio Code. Alright, so we have it here. In the real world, one of the ways we are able to identify objects or items is because they have names. For example, we refer to a specific object as a car and another object as a table. This same principle applies to programming. We need a way to be able to identify items or objects we need to refer to. Identifiers are names given to objects in programming. For now, do not bother to know the particular objects we have in programming. When it comes to naming objects in programming, it is important to keep in mind certain rules and regulations. The first rule is that the name you assign to an object must not be a keyword. Keywords are reserved names that hold special meanings within the language. This image shows the restricted names: false, none, true, async, await, break, and so on. None of these names can be used within the Python programming language. We can access the keywords in the installed version of Python by writing the following two lines of code. Import keyword. Save the file and click the play button to run the code. This shows all the keywords available. Another rule is that an identifier, which is the name of an object, must not start with a digit. This means we are not allowed to use names like age name, 1 age, 0 car name. These names are prohibited because they begin with a digit or number. Special symbols like the $sign and hash are not allowed to be included in the name of an object. This set of names cannot be used at house. The position of the special symbol does not matter. There is no restriction on the length of identifier. Name like your address is a valid identifier. The length of the identifier can be as long as needed, as long as it follows other naming rules. White spaces are not allowed. For instance, contact number. Although each of the name, contact, and number follows the naming rules, but because of this space, it makes it an invalid name. The last rule on the list is that a name can start with any letter from A to Z, or a name can start with an underscore. It also means that all these are valid names. A is a valid name or lowercase, Z is a valid name and lowercase. Also, we are allowed to add more letters. H. Adding numbers is also a valid option. Remember that descriptive names are better than short names. Another point to note is that identifiers are case sensitive. That means a name H is not the same as age because of this case. This is uppercase while this is lowercase. Based on the rules we've mentioned, we can list some valid names and invalid names. Age is a valid name. Name _1 is also a valid name. The digit we have is not at the start. Cat3 is also a valid name. This is also a valid name. We have underscore in between the names. Invalid names. Age name This starts with a digit. This name has a special character, class. This is a reserved keyword in Python, and also my-name. This contains a special character. This image shows the rules and regulations for Python identifiers, which are also known as the names of objects in Python. The same way we have real-life objects such as a table, a variable is one of the objects that exist in Python programming. Variable simply means anything that can change at some point. For example, my name, my phone number, and my school are all variables because they can change. The age changed from 20 to 21, and the level changed from 6 to 7. Every variable has a name or identifier. In this case, the name of the variable is age, and the value is 20. All the rules and regulations we mentioned while explaining identifiers apply. Variable names such as $price, 1 hour, and import are not allowed. $price, this has a special character. A variable cannot start with a digit or number. Import, this is a reserved keyword in Python. To represent what we have mentioned in Python, we need to write age equals 10. When we write age equals 10, the age on the left hand side is the name of the variable, also known as the identifier, while the value 10 is being assigned to the variable. This sign looks like equals sign from mathematics, but it has a different meaning in Python. The equal sign is used to assign values to variables. Let's create some variables in our code. The name of the variable or identifier is on the left hand side, while the value we want to assign to the variable is on the right hand side. Once we have declared a variable, we can access its value by referencing the name of the variable. Let's use the print statement to print the output to the terminal. Click on the play icon to run the code. As you can see, we are able to reference the variable using the name of the variable. This means we can always access the value stored in a variable by using its variable name. Let's pretend to use an invalid name, such as a keyword. We have an error because we are using a keyword as the variable name. The keyword is expected to be used in a particular way. Naming styles refer to the standards followed when naming objects. In Python, one common naming style is snake case. In snake case, variable names are expected to start with a lower case. If the name consists of multiple words, they are separated by underscores. For example, an identifier, or which is the name of a variable, can be first underscore name. So this is the convention used in the Python community. If I need to write username, I will simply write user underscore name. In camel case, the first letter of the variable name starts with a lowercase and the first letter of subsequent words is capitalized. In this case, the first letter will start with a lowercase while any other words would be uppercase. First name, username. In Pascal case, the first letter of every word in the variable name starts with a capital letter. When you create a variable, a memory location on the computer is used to store the value. The computer memory is like a cupboard with separate sections to store different items. When you create a variable in a programming language, a specific portion of memory is allocated to store its value. We can check the location of the memory address of an object such as a variable using the id function. The id is expected to be unique and constant for an object during its lifetime. Print id of age, print id level. Each number is unique and also referred to as the memory address of the object. In this lesson, we will be explaining the meaning and usage of comments in Python. Comments are sections of your code that are ignored when you run a program. Any commented line of code won't be executed. Let's assume we have 5 lines of code from line 1 to line 5. As a developer, you can instruct Python to skip line 4 of the code. That means when the program is running from line 1, it will execute the code from line 1 to line 3. Anything written on line 4 will be ignored and the execution of the code will continue on line 5. But the question is, why would you want to do that? The first reason is when you want to add a note that explains what the code does or why something is done in a certain way. This is beneficial for you as well as other developers who are working on the code. Another reason might be to disable a certain part of the code when testing the program. To add a comment to line 4, you can use any line from line 3 upward, or simply use the space in front of line 4. In Python, any line that starts with the hash character is considered a comment. The hash symbol indicates that the rest of the line is ignored by the Python interpreter. That means if we need to add a note to what line 4 is doing, we can use any line from line 1 to line 3, but each of those lines must start with the hash character. Or we simply use the space in front of line 4 to add a note or a comment to what line 4 is doing. Open VS Code or any other code editor of your choice. Create a new file. In my case, the name of the file is comment_03.py. Let's declare some variables. Name equals Ali, age equals 10, level equals 6, mobile equals 1, 2, 3, 4, 5, print name, print age. The variable name, also known as the identifier, is name, and the value assigned to it is Ali. If you are unsure about what a variable is, please check the previous video for clarification. When we run this program, every line of code from 1 to 6 should be executed. Let's try running the code. The output we have on the terminal is Ali and 10. Line 5 prints out the value assigned to a variable called name. If we need to add a comment or a note for line 4, that is, we want to add some information about what line 4 is doing, there are two ways to do this. We can either use one or more lines above line 4 to write the comment, or we simply use the space in front of line 4 to add the comments. Collect last. The comment we have for mobile can be on top. Every line of code starting with a hash symbol will be ignored by Python. We can also use another line above. Any comment starting on a new line is called block comment. This is one way of adding comment. Another way of writing comments is inline, which means the comment would be in front of the code. Let's try one more example. Point. Anything put between single or double quotes is a specific type of data we will explore in subsequent lessons. One way to comment out line 9 is by using this. This is how we can disable a certain part of the code. It is important to note that there are bad comments. For instance, adding this kind of comment, this is a user name. This is a bad comment because the name of the variable, which is name, is already conveying what is happening. Let's say mobile numbers are expected to be 9 digits, but we are only collecting the last 5 digits from the number provided by the user. Let's remove these bad comments from our code. Some programming languages like JavaScript allow you to comment 1 or 2 lines together. As at the time of recording this video, the only way you can comment multiple lines of code in Python is to put hash in front of each line. Most code editors provide a way to do multi-line comment. In VS Code, after highlighting the areas I want to comment out, hold down the Ctrl key and then press the /. I'm able to automatically comment and uncomment this part of the code. Before we end this lesson, I want you to visit the pep8.org website. This site provides the style guide for Python code. Scroll to the comment section. The first paragraph is saying there shouldn't be any contradiction between the comment and the actual code. Let's say, for instance, the comment is saying a particular approach must be used, while the actual code is using another approach. In this case, it is better to have no comments. The other paragraphs contain valuable information that you wouldn't want to miss. Hi everyone, in this lesson we are going to explain the concept of data types in Python and specifically focus on the string data type. Data types specify the kind of value that can be stored inside a variable. Age is usually represented as a whole number, while name is a textual data. The type of value assigned to age differs from the one assigned to name. A whole number is different from a text. This distinction is what data types refer to. It specifies the kind of value a variable holds. For instance, Height could be in decimal form, whereas whether someone is a college graduate is answered with a yes or no. The kind of value we assign to a variable depends on our purpose for that variable. For example, the value of 5 would not be an appropriate answer to determine whether someone has graduated or not. In Python, we have different data types: string, numbers, Boolean, list, tuple, dictionary, sets. Strings are sets of characters represented in the quotation marks. They are used to represent text. Whenever you need to work with textual data such as name, address, message, laptop brands, and so on, the appropriate data type to use is a string. This is because strings are designed to handle and represent text data. In Python, anything enclosed within either single or double quotes is considered a string. You can create a string by surrounding some text with quotation marks. The quotes surrounding a string are called delimiters because they tell Python where a string begins and where it ends. In VS Code, let's create a variable with a string value. First, underscore name equals Alex. The name of the variable, also known as the identifier, is first name, and the value assigned to it is Alex. Alex is a string because it is enclosed within quotation marks. The first quotation mark signifies the start of the string, while the second quotation mark marks its end. This is the same thing as writing first name equals Alex. Another important point to remember when declaring a string is to ensure consistency with the quotation marks used. This means that if you start the string with single quotation mark, you should also end it with single quotation mark. Similarly, if you start with double quotation mark, you should end with double quotation mark. For instance, first name equals Alex. This is not going to work because the quotes which is starting the string is different from the one ending the string. Consistency in the use of quotation marks is crucial to avoid syntax errors in your code. So let's try to print out the value of first name. This throws a syntax error because there is no consistency in the quotation marks used. Let's try another example. Welcome underscore message equals hi. What's your name? We have three quotes. The first quote signifies the start of the string. What do you think is going to happen with this line of code? We have three quotes. Python sees the first quote as the start of the string, then it moves until it sees another quote of the same type. So Python is going to treat this second quote as the end of the string. It won't be able to interpret the rest of the code. So this code is going to throw an error. Let's try to run it. As you can see, this is a syntax error. One way to fix this is to use double quotes. Welcome message equals hi your name. This fix is going to work because when the start of the string is a double quote in Python, it continues reading the characters until it encounters another double quote, which marks the end of the string. We can print out the welcome message. Congratulations. To determine the number of characters in a string, we can use the built-in function len, len, provided by Python. Name equals Alex. We can print out len of name. This result is going to print out the number of characters in name. Built-in functions are available by default in Python. The print function, which we have been using, is also a built-in function. A function performs a specific task. So let's print out the length or the number of characters in the variable called name. Let's add one more character to the name. This is how we can know the number of characters in a string using the len function. An escape character or escape sequence is a series of characters within a string that are interpreted as special characters. These special characters may be challenging or impossible to express directly, such as new line, tab, and other similar characters. A backslash character in a string indicates that one or more characters that follow it should be treated specially. This is referred to as escape sequence because the backslash causes the subsequent character to escape its usual meaning. Whenever a backslash is written in a string, anything that follows it has a special meaning. For instance, a single or double quote indicates the start or end of a string. However, when it is preceded by a backslash, it signifies that it should escape its usual meaning of being a delimiter and instead be treated as a normal character within the string. Whenever we see this in a string, it means a normal single quote, not a delimiter. A normal double quote, not also a delimiter. This represents a backslash, while this represents a new line. This represents horizontal tab, vertical tab, and a backspace. Let's declare a variable to explain escape characters. Name, print, name. To use an escape character, we need to insert a backslash, then a character with a special meaning, such as T. /T means a tab. Let's try that. So let's also try N, which means a new line. So these are the escape characters. This means whenever we have a backslash, anything that follows has special meaning. Let's try out another fix for what we have defined here in welcome message. This is welcome message. The way we were able to fix this before was to use double quote. Another fix for this while using single quote is to escape the meaning of these quotes. So to do that, we simply need to use a backslash. Whenever we use a backslash and a single or double quote follows it, they are not interpreted as delimiters. So let's print out the welcome message. Welcome message. Congratulations. We are able to make this work without using double quotes. That's one of the purposes of escape characters. To ignore all escape characters in a string, we have to make the string as a raw string using the letter R before the string. This means all the escape characters will be ignored. We can also use uppercase for that. Thank you for watching, and I hope you enjoyed this video. Please like, comment, and subscribe to grow the channel. Hello friends, and welcome to the 5th lesson in the Learn Python series. This course provides the core Python knowledge needed to help you build real-life applications. In this lesson, we will explore some operations that can be performed on the string data type. As mentioned in the previous lesson, strings are enclosed in quotation marks. String concatenation refers to the process of combining two or more strings together. To achieve this, we make use of the plus operator. Whether single or double quotes are used in Python does not really matter. Let's write some code in the editor. Let's declare some variables. I will be using my name first. Name equals last name. Full underscore name equals first name plus last name. The full name is a variable that holds the combination of first name and last name. Remember that we have declared both first underscore name and last underscore name as variables above. Whenever we reference them or mention them here, their values will be retrieved. This is equivalent to saying that full name is a concatenation of first underscore name and last underscore name. Let's use the built-in print function to print the value of full name to the terminal. Print. To improve the appearance of the full name, let's add a space between the two names. We can achieve this by modifying the concatenation expression. We just need to add some space as this. This is how we can combine multiple strings together and assign the value to another variable. When you use the multiplication operator with a string, it creates a new string by repeating the same string multiple times. Say for instance, the first name equals times 4. Print first name. By using the multiplication operator, it generates a new string by combining the initial string multiple times. To determine if a particular character is present in a string, we can utilize the in keyword in Python. It is important to note that in is a reserved keyword, as mentioned in lesson 2. Being a reserved keyword, it holds special meaning in Python and cannot be used as a variable name. Let's say for instance, first underscore name equals read one. Is underscore member equals r in first name. In this code, we are checking if the character r is present in the string first underscore name. This expression will evaluate to either true or false based on whether the character R is found within first underscore name. If the character R is present in first name, the result will be true. Otherwise, if the character R is not found in first underscore name, the result will be false. That simply means the result we get from this, we assign it to a variable called isMember. So let's try to print out the value of isMember. This is true because the character R is present in first name. One crucial aspect to understand in programming is that uppercase and lowercase characters are not equivalent. Since uppercase and lowercase characters are different, the result will depend on whether the lowercase r exists within first name. Let's say for instance we change this to lowercase r. The result should be false. Every character in a string has a position, which is referred to as an index. The index represents the numeric value assigned to each character in the string. In most programming languages, including Python, counting typically starts at 0. This means that the first character in a string has an index of 0, the second character has an index of 1, and so on. For instance, let's consider the string happy day. Each character or element within the string has a specific position, known as an index. In this case, the position of the letter H is 0, indicating that it is the first character in the string. As we move through the string, the subsequent characters have incremental index values. The last character in any string has an index of -1. This means the character before the last one has -2, and so on. Let's declare a variable message equals happy day. We can access the character at any given index by using square brackets and specifying the index value inside them. We also need to mention the variable name message. Let's print out this value. This is going to print the first element in the string, which is H. We can print out the second element as well. A. Negative index is also supported. To access the last element in a string, we can use -1. This is going to print the last element in a string because the last element always has -1 index. The one before the last element we have -2, and so on. If we need to access the element before the last element, we can simply make use of -2. If an index is not found, Python throws an index error. Let's try that one out. 0, 1, 2, 3, 4, 5, 6, 7, 8. That means if we use index of 9, which is not found, Python is going to throw an index error. But if we use 8, which is present in the string, we get a result. You can extract a portion of a string, also known as a substring, by specifying the range of characters you wish to extract from the original string. The index number plays a vital role in retrieving a substring from the main string. The syntax or code format for extracting a substring is square bracket, start position, double colon, upper band, and another square bracket. The start position indicates the index of the character where the extraction should begin. The upper band represents the index of the character just after the desired substring. The characters within this range, including the start position but excluding the upper band, will be extracted as a substring. In this case, the extraction starts from index 1 to index 3. The character at index 1 is M, while the character at index 4 is I. It moves from the starting position 1, 2, 3, but it excludes this upper band, which is 4. So the string we have here will be MAZ. If the upper band is omitted, it moves till the last character. For instance, in this case, the upper band is not specified. That means the substring will start from the index at 1, which is M, till the last character in this main string, which is L. So that's why we are able to have this Another case is when the starting position is not mentioned, that is, when the starting point is omitted. In this case, it starts from the first character till the upper bound. So that simply means the first character is A. It moves till the upper bound, which is 4, but not including the upper bound. That is why we are able to have a maze here. Let's say main string equals ABCDEFGH point main string. The start position is 0 while the upper bound is 3. The substring will contain character at index 0, 1, 2, but it is going to exclude the upper bound, which is 3. The substring would be ABC. If the start position is omitted, it starts from the first character. Let's try that one out. Print main string. Since the start position is omitted, it will start from the first character in the main string. That means A, 0, 1, 2. Let's comment out the first one. So we are able to retrieve the same results. Another case is when the upper bound is not given. It moves till the end of the string. For instance, print. This is going to start at index 2, which is 0, 1, 2. Since the upper bound is not given, it is going to move till the end of the main string. Let's try that one out. If the starting position and the upper bound are not given, all the characters in the original string will be retrieved. We are able to arrive at this result because whenever the start position is not given, it starts from the first character, and whenever the upper bound is not given, it ends at the last character. Just as we have been using positive index value, we can also make use of negative index value. Print main string -5. Remember that the last item in any string has an index of -1. We can locate the starting position here, which is -5, -1, -2, -3, 4, 5. The starting position here is -5, which is D, which means -5, -4, -3, -2. The string we need from here would then be -5 till -2, which is DEF. In this case, the lower bound is not given. That means it's going to start from the first character in the string till -2. The first character in the string is A. -2 will be -1, -2. That simply means it's going to take all characters from A to F. String immutability is a fundamental concept in programming. Once you have created a string, you cannot change the characters in it. Attempting to assign a new value to a specific character in a string will result in an error. This is because strings are immutable in Python, meaning they cannot be modified directly. Let's declare a variable name equals Alex. We can print out the character at index 0, which is A. Let's try to modify the character we have at index 0 equals to F. What you are trying to do here is to modify the character at index 0. Let's try to do that. As we can see, we have a type error which says string object does not support item assignments. This is because strings are immutable, meaning once you have created them, you cannot modify them directly. One way to go about this is to define a new variable entirely. New underscore name equals F plus name What we are doing here is string concatenation. We are combining two or more strings together by using the plus operator. The first string is this. The second string is a substring of name. The index 1 is L. Because the upper bound is not specified, it is going to move from index 1 till the end of the string. So let's try to print out new name. Great. So that's how we are able to modify the value by assigning it to another variable. Thank you for watching, and I hope you enjoyed the video. See you in the next video. Hi friends, and welcome. In this lesson, we will explore the string methods available in Python and their functionalities. Python provides some special functions to manipulate strings. Although we haven't yet covered the concept of functions in programming, we mentioned earlier that functions perform specific tasks. In the context of strings, these functions are referred to as string methods. For instance, you may want to capitalize the first character in a string while converting all other characters to lowercase. You can use the capitalized string method in Python to achieve this. The methods listed here represent only a fraction of the string methods available in Python. One of the goals of this course is to provide you with a foundation so that you can continue exploring and discovering other string methods that Python offers. One point to note about string methods is that when they are used on strings, they do not modify the original string since strings are immutable, as discussed in the previous lesson. Instead, the methods return a new string with the desired changes. We will also learn how to discover other methods using a code editor. If you are new here, my name is Ridwan. Without further delay, let's dive in. The first method we are going to try is the capitalize method. The capitalize method is used to convert the first letter in a string to uppercase while transforming all other characters to lowercase. Let's declare a variable. Message equals you are welcome. To capitalize the first letter and change all other characters to lowercase, we can utilize the capitalize method. New underscore message equals message dot capitalize. So let's print out the new message. As you can see, we have been able to transform the string. The original string remains unchanged after applying each method. We can verify this by printing out the message variable using the print function. Print message. The original string is intact because strings are immutable. They cannot be changed once they are created. The upper method is used to convert all lowercase characters in a string into uppercase. Using the previous example, message.upper. This converts all the characters into uppercase. The lower method is the opposite of the upper method. It converts all uppercase characters in a string into lowercase. Message.lower. This is going to transform the message into lowercase, but remember, it doesn't change the original string. The title method is used to convert a string to title case, where the first character of each word is capitalized and the remaining characters are in lowercase. Message.title. This produced a new string where the first character in each word is capitalized. The argstrip method is used to remove white space from the right side of a string. We are going to put some spaces here by using the tab key. Let's run the program. To really confirm that white spaces have been removed, we can utilize the len function, which returns the number of characters in a string. Print len message, print len new message. We are able to confirm this because the initial length of the string is 21, but after using the argstrip method, the length has been reduced to 15. The lstrip method is used to remove white space from the left side of a string. We are going to put some spaces before the main message. With lstrip method, we can have all the spaces before the main message removed. Let's try that out. Great. The initial message is intact, but after using the lstrip method, we have the spaces removed. In addition to the argstrip and lstrip method, Python profiles the strip method, which removes white space from both the right side and the left side. Going by the previous example, we have added some spaces before and after the main message. Let's try that out. The default behavior of all the strip methods is to remove white space characters such as spaces, tabs, and new lines from the start and end of a string. But you can specify optional characters to be removed. Let's put the @ symbol here. To specify the characters to be removed, we use single or double quotes and specify the characters to be removed. Great, this removes all the @ symbol. We can also add the hash symbol. We have been able to remove both the special characters from the string. The start with method determines if a string starts with a particular string. It returns true if so and false otherwise. Let's define a variable name equals read1 arg suffix equals name dot starts with r print arg suffix. This is either going to return true or false. The expected result here is true because this string starts with arg. The ends with method determines if a string ends with a particular string. Let's define a variable title equals holding arg suffix equals title dot ends with print. The expected result is false because the string coding does not end with arg. The isDigit method returns true if all the characters in the string are digits between 0 to 9 and the string is not empty. Let's define some variables. I'm going to replicate all this. For the first variable var_1, the result should be true because all the characters are digits. var_2 will be false because it contains a character different from a digit, which is a. The same thing for the third variable, it is an empty string. Let's execute the program. All the characters in the first string are digits, while the second and the third variable contain a character that is different from a digit. The replace method is used to replace a substring with another substring within a string. It has the following syntax. String represents the original string, followed by the replace method. Old represents the substring to be replaced. New represents the substring to replace old. The count parameter is optional and it specifies the maximum number of occurrences to replace. By default, the method replaces all occurrences. Let's try an example to explain the method. var_1 equals 1 new var equals var1 dot replace 1. With the replace method, every occurrences of 1 can be replaced with 2. Let's print out the new var. As you can see, we have been able to replace all the occurrences of string 1 with string 2. The third parameter, which is optional, specifies the maximum number of occurrences to replace. With the same example, we only want to replace up to 2. Let's run the program again. It only replaced the first 2 occurrences. The find method determines if a string occurs in another string. It returns the lowest index of the substring if it is found, otherwise it returns -1. If you do not know what an index is, please check the previous lesson on string operations for more information about string indexing. Let's define a variable string underscore message equals hello world. Index equals string message dot find world print index. Let's run the program. The substring world is found in the hello world string and the index of the first occurrence is 7. We can confirm that by checking the index 0, 1, 2, 3, 4, 5, 6, 7. The first occurrence is 7, that is the lowest index of the found substring. If a substring is not found, it returns -1. Let's say Python and save. This returns -1 because the substring Python cannot be found in the original string hello world. Strings have lots of methods associated with them. The methods introduced in this lesson are only a fraction of what is available. To discover more methods, you just need to type a dot immediately after a variable name in the code editor. This shows all the methods available: else strip, lower strip, starts with, ends with. Once you find the method you want to use, press the enter key. That's all about Python string methods. If you have more questions or need further assistance, I'm here to help. Thank you for watching, and I hope you enjoyed the video. Hi friends, and welcome. String formatting is the process of inserting a string or any variable into another string. This is not the same as string concatenation, where two or more strings are joined together using the plus operator. Say we have a variable name called user information, whose value is your name is and your age is. String formatting provides a way to insert any variable or a string into the original string, which is user information in this case. As of now, Python provides 4 ways to achieve this string formatting, each with its own pros and cons. In this course, we will explore all the 4 techniques and learn when to use each. Without any further delay, let's get started. The oldest way to do string formatting is to use the interpolation operator. You are likely to come across this in a legacy code base. Let's declare some variables. Name equals Alex. Message equals your name is. For you to be able to insert the first variable, which is name, into the message, we can make use of the interpolation operator. To achieve this, we put the %sign at any desired location in the string, followed by S. The S indicates that the variable that will take this position is a string. Other variants include D, which is used to insert integers. Although we haven't yet covered numbers, that will be covered in the next chapter. The same thing for decimal values and binary format. Once we have specified the position where we want to insert a string or variable, next is to write the interpolation operator immediately after the string, followed by the variable name or string that we want to insert. Let's print out the message. Print message. Great. We have been able to successfully insert a variable into a string. One point to note here is that you can directly specify the value to insert instead of referencing a variable already declared. We can use the value directly. Let's say the name is Ray. That works. When you need to insert more than one variable or string using the interpolation operator, the approach is slightly different. The strings or variables to be inserted are enclosed in brackets. Let's consider another example. Age equals 9. Your name is and your age is. We are using letter D immediately after the interpolation operator because we intend to insert a whole number. To specify the variables or strings we want to insert, we make use of the interpolation operator again, then brackets. Then the variable to insert, name, age. Remember that the order matters. Name represents the first operator and age is for the second variable to insert. Let's run the program. In this example, taking note of the order is important, otherwise there might be a mismatch for variables to insert. For instance, let's reverse the order. Age, then name. Since age is a number, let's replace this by D and name, which is string. Let's run the program again. As you can see, the result now is your name is 9 and your age is Alex. That is a mismatch. We need to be careful with the order. The interpolation operator provides a way to eliminate the need to remember the order of variables. To achieve this, the variable names and the corresponding values need to be enclosed within curly braces. Instead of using brackets, we make use of curly braces. The name of the variable needs to be enclosed in single or double quotes. Name followed by the value, which is name. When we mention name here, which is a variable, the value would be taken from what we have defined on line 1. Let's do the same thing for age, which is the second variable. Remember to separate each of the variable with a comma, then the value of the age. Take note that we can also use the value directly instead of using a variable. Before we execute the program, we need to mention the variable name, which is name. It is a string, and age is an integer. Now let's run the program. The good part about this is that we don't need to remember the order of variables. We can change the order by mentioning the age first, then separated by a comma. This is going to give us the same result. Let's try it out. As mentioned earlier, you are allowed to mention the value directly rather than referencing variables already defined. Let's execute the program. Great. The string.format method is an improvement over the interpolation approach. This method allows you to insert variables into the string by using curly braces as placeholders. In this example, we are using the variable names we have already declared. You can also mention the values directly. Let's run the program. This method provides a more flexible and readable way of formatting strings compared to the interpolation approach. Take note of the order of the variables. Name maps to the first placed order, while age maps to the second, and so on. You should also note that the number of placeholders must not be greater than the number of variables you pass to the format method. For instance, let's put another placeholder here. This is going to throw an error because the expectation is that you want to insert 3 variables, but you have only provided 2. Let's run the program. The string.format method allows us to specify the index of each variable in curly braces. The index refers to the position of each variable, starting from 0. Let's use the same example. We can specify the index of the variable to occupy this position, 0, 1. Remember that index counting starts from 0. The first variable or value will be 0. The second would be 1. Let's try that out. This produced the same result. Let's reverse the ordering. 1, 0. Great. Python is going to throw an index error if the index does not exist. The first value or variable is 0, the second is 1. If we try to use index of 2, which does not exist, Python is going to throw an index error. Let's see that in action. Error. This shows an index error. Just like the interpolation approach, the string.format method also allows us to mention the names of the variables in the strings. This provides a more readable and explicit way to insert values into the string, making the code more easier to understand. We simply need to mention the name of the variable in curly braces, age, and we need to say name equals the value, which is name, age equals age. The second name in this format method is referencing the variable we have already declared and put it here, but we are going to go by the variable name. The variable name here, which is age, is taking its value from what we have declared on line 16, which is 9. Let's run the program. With this approach, we don't need to bother about the order of variables. We only need to put the names of variables as placeholders. Python 3.6 introduced a new way of formatting strings called f-string. You just need to put a capital or lowercase letter f before the string and the variables to include in curly braces. Name, age. It is as simple as that. Let's try it out. You are allowed to put expressions because f-strings are evaluated at runtime. That is when the program is running. I can decide to do name.upper, which is a string method we have discussed. Let's see the results. Let's do name.upper, age plus 1, which is a number. Let's run the program. We are able to do this because f-strings are evaluated at runtime. Template string is another tool for string formatting in Python. To use it, we need to import the template class from Python's string module. From string imports template. Let's declare a variable name equals Alex, age equals 9, message template equals template name age. The template string is enclosed between the opening and closing brackets. A string template uses the $sign followed by the variable as a placeholder for the variable to insert. This means we want to insert the value of a variable named age. The same thing applies to the variable named name. Once we have declared the template to be used, we can use the substitute functionality to insert the values of the variable. Message equals message template dot substitute name equals name, age equals age. Print message. We are using the substitute functionality that comes with the template to insert the relevant variables. Like we have mentioned before, we can also make use of the values directly. Let's run the program. Great. If you are working with untrusted or user-provided data, using the template string technique is a recommended approach to avoid security issues. The template string class ensures that user-provided data will be safely substituted in the template, preventing potential security vulnerabilities like code injection. If the data is not user-supplied, consider your Python version. For Python 3.6 and above, use f-strings. For older versions or compatibility reasons, use the string.format method. Thank you for watching and see you in the next video. Hi friends and welcome. In lesson 4 of this course, we discussed strings along with related topics. In this lesson, we will focus on another vital data type in Python known as numbers. Average software engineers generally need a basic level of mathematics to be successful, so there is no need to be scared. The required level of mathematics may vary depending on the type of application they are working on. Python supports 3 numeric data types to represent numbers. Integers are positive and negative whole numbers. 0 is inclusive. Floating point numbers refer to numbers having decimal places. Complex numbers have real and imaginary parts. Integers are positive or negative whole numbers of any length with no decimal point. 0 is also an integer. Let's declare some variables with integer values. X equals 100. Z equals 10. The name for the integer data type is int. We can use the type function to know the type of an object. Print. Let's run the program. This shows that all the variables we have declared are all integers. We have the type to be int, which refers to integer. You can use an underscore to group digits. This is particularly useful when dealing with long numbers to improve readability. To improve the readability, we can put underscore. Take note that Python does not allow using comma as a delimiter. Print x. Great. Floating point number is a number with a decimal place. The name of a floating point data type is float. Let's declare variables with float values. A equals. We can make use of the type function to check the type of the variables. Print. Let's run the program. The type shows the type of the variables is float. Python uses E notation to display large floating point numbers. Let's say we have a variable x equals a large sum of floating point number. Point. E notation is short for exponential notation. This is how programming languages and calculators display large numbers. This is the same as 1 times 10 raised to the power of 28. A complex number has a real part and an imaginary part. Let's declare a variable complex number equals. To create a complex number in Python, you write the real part followed by a plus sign. Then specify the imaginary part with the letter J at the end. Let's print it out. Print complex number. Great. Complex number has the real and image properties. To get the real and the imaginary part, it also has the conjugate method that returns the conjugate of the number. Print complex number dot real. Print complex number image. Print complex number dot conjugate. Let's run the program. Complex number dot real returns the real part in float format as well as the image property. The conjugate method returns this. Complex numbers are generally used in fields like computer graphics. So for someone learning Python for web development or data science, they may not need to use them. In this part of the lesson, we will explore different operations that can be performed on the number data type. This involves using operators with numbers. Addition of numbers is done with the plus operator. The numbers on either side of the operator are called operands. Let's declare a variable summation equals 5 plus 5. Print summation. Let's run the program. In this case, we are adding two integers together. 5 is an integer because it is a whole number. Instead of using values directly, we can also make use of variables. Let's see that in action. A equals to 5, B equals to 10. Summation equals A plus B. Print summation. Let's run the program. In this case, instead of mentioning the value directly, we are referencing the variables we have already declared. We have already declared A and B. It is important to note that adding integers together will always result in an int, that is an integer. In this example, 5 is an integer, as well as 10. The result, which is the summation, will always be an integer. Let's check the type of summation. Print type summation. This shows that the summation is an integer. Whenever you add an integer to a float, the final result will be a float. In this case, variable A is an integer. Let's change variable B to be a float. 10.5. Let's run the program again and see the results. As you can see, the final result we have now is a float. We can use the minus operator to subtract two numbers. Let's declare the third variable. Difference equals A minus B. Print difference. Let's run the program. This returns the difference between A and B. Also note that subtraction between integers will always result to an integer. For float and integer, the result will always be a float. Let's change the variable A to a float. Print type. Let's run the program again. The final result is a float. To multiply two or more numbers, we make use of the asterisk sign. Variable C equals A times B. Print C. Let's run the program. This returns the multiplication of the two numbers. The / operator is used to divide left-hand operand by right-hand operand. Division with the / operator always returns a float, irrespective of the operands. Let's see that in action by running this program. Great. Python throws an error when you try to divide a number by 0. Let's change the variable b to 0. Python raises a 0 division error because you can't divide a number by 0. To raise a number to the power of another number, we use the double asterisk operator. Print exp. This is the same thing as writing 5 times 5 times 5. Let's execute the program. We are also allowed to raise number to decimals. This should return a float. Great. The modulus uses the % sign and it returns the remainder of dividing the left-hand operand by the right-hand operand. One of the uses of the modulus is to determine if a number is divisible by another number. It returns 0 when the first number is divisible by the second number. Let's execute the program. This returns 0 because the remainder of dividing 6 by 2 is 0. Let's change 6 to 5. This returns 1 because the remainder of dividing 5 by 2 is 1. An expression is a combination of operands and operators that Python can compute to return a value. Understanding the order of precedence is crucial when dealing with expressions containing multiple operators to obtain accurate results. Operators with higher precedence are evaluated first before operators with lower precedence. In this example, 3 times 2 will be the first part to be evaluated before the other parts. 3 times 2 equals 6. 6 minus 1 equals 5. The expected result of this expression is 5. Let's run the program. Great. We can use parentheses to change the order of evaluation. Parentheses come before any other operator in the order of precedence. This means 2 minus 1 will be first evaluated before the multiplication operation. Let's execute the program. The result is different from the first expression because operation in the parentheses is evaluated first. Thank you for watching, and I hope you enjoyed the video. See you in the next lesson. Hi friends, and welcome. Python provides several built-in functions that can be used to convert an object, such as a variable, from one type to another. In this lesson, we will explore some of these functions and observe their practical usage while coding. The first function is the int function, which stands for integer and is used to convert objects to whole numbers. Let's declare some variables. A equals 10, B equals 5, which is a string, C equals A plus B, print C. If we try to run this program, Python will throw an error because we are trying to perform an addition operation between a number and a string. 10 is a number data type and an integer, while B is a string. It is impossible to perform an addition operation between a number and a string data type. Let's execute the program and see the result. As you can see, we have a type error, unsupported operands type for plus, int and string. To make this work, we can convert variable b, which is a string, to a number type using the int function. We simply type int and put the string inside of it. What we are trying to do here is to convert a string to an integer using the int function. By this, we expect our program to work fine. Let's execute the program again and see the result. The program is working now because we have successfully converted string to an integer using the int function. We can also use the int function to convert floating point numbers to whole numbers. Here is an example. Floating number equals 20.0. Floating number. Let's use a type function to check the type of the variable. Point type. This is a floating point number. Let's convert it to an integer using the int function. Int. Let's run the program again. This floating point number having a decimal value is now converted to an integer. The decimal part has been removed. Take note that the int function in Python does not perform rounding for floating point numbers. It simply truncates the decimal part and returns the whole number part. Here is an example. Number 1 equals int 20.9. Number 2 equals int 20.1. Point number 1, point number 2. Let's execute the program and see the results. As you can see, the int function does not perform rounding for decimal values. It only returns the whole number parts. Another point to note is that you cannot change a string that looks like a floating point number into an integer, because you would lose everything after the decimal point. Python provides the float function for this. The float function allows you to preserve the decimal part of the number. This conversion will throw an error because we are trying to convert a string that looks like a float into an integer. Let's execute the program and see. We got a value error. The float function stands for floating point and is used to convert objects into numbers with decimal points. Let's declare some variables. A equals 20, B equals 20.5, c equals 20. The first two variables a and b are strings, while the third variable c is an integer. Let's make use of the float function to convert all of them into floating point numbers. Float, point a, b, c. Let's execute the program. All the variables have been converted into floating point numbers. Note that for string to number conversion to be successful, all the characters in the string must be digits. A equals int 3c. The conversion will throw an error because the string 3c contains the character c, which is not a digit. As a result, Python will raise a value error indicating that the string cannot be converted to an integer. Let's run the program. All the characters in the string must be digits. If we remove c, it is going to work fine. Great. The string function is used to convert non-string data types to a string. We have declared a variable named msg, short for message, and we intend to assign the value on the right hand side to it. The plus sign does not indicate addition of numbers, it signifies string concatenation. Whenever you see a string followed by a plus sign, Python interprets it as string concatenation, and the value that follows is expected to be a string. In this case, since 5 is an integer, Python would raise an error. Let's execute the program and see what happens. We have a type error which says can only concatenate string, not int, to a string. To address this, we can convert 5 to a string using the string function. String 5 point message. Let's run the program again and see the results. Great, the program works now. Let's try one more example. A equals 20, b equals 20.9. Point type of a. Let's execute the program. Variable a is an integer, while variable b is a float, as shown by the type function. Let's convert them to a string using the string function. Str. Let's run the program again. With the help of the string function, we have been able to change the data type to a string. Thank you for watching and see you in the next video. Hi friends and welcome. In this lesson, we will explore some mathematical functions in Python. A function performs a specific task in programming. Let's get started without any delay. The absolute value of a number refers to the positive distance between the number and 0. If a number is positive, the absolute value of that number is the same number. If a number is negative, the absolute value is the positive value of the same number. To get the absolute value of a number, we use the ABS function. Let's say we have a variable called ABS value equals 4. Point ABS value. To get the absolute value of this number, we make use of the ABS function. ABS. Let's run the program. Great. Let's change the number to a negative value, -4. Execute the program again. We get a positive value. A simple use case of the absolute function is when you need to get the absolute value of a number, regardless of its original sign. In a previous lesson, we used a double asterisk to raise a number to another number. The power function serves the same purpose. Exp equals power 2, 4. In the power function, the first number is the base, and the second number is the exponent, which is 4 in this case. This means 2 raised to the power of 4. Let's print out the result. Print exp. Execute the program. Great. When the max function is used with numbers, it returns the highest value among all the given numbers. In this case, the maximum number is 90. Print maximum. Let's run the program and see the results. We are able to retrieve the maximum number among the numbers. The min function, short for minimum, is used to find the smallest number from a provided list of numbers. Print minimum. The expected result is 0 because that is the lowest number. Let's run the program. we have been able to retrieve the smallest number. The sqrt function, short for square root, is used to return the square root of a number. We need to import the math module. To use this, import math.square-root, print square root. Let's run the program. The result is 4.0. Keep in mind that the result is always a float, even if the number square root is a whole number. Also note that the number must not be less than 0. We can use 0, but if we try to use anything less than 0, -1, Python throws an error. The round function is used to round a number to the nearest integer, that is, the nearest whole number. Round number equals round 1.2 point round number. If the number after the decimal point is less than 5, Python rounds to the same whole number. The expected output is 1. Let's run the program. Great. Let's modify the initial number, 1.8. If the number after the decimal point is greater than 5, Python rounds up to the nearest integer. In this case, 8 is greater than 5, so the expected output will be 2. Let's run the program and see the results. The default behavior of the round function is to round to the nearest whole number, but you can optionally specify the number of decimal places to be considered. Default is 0. Let's take a look at some examples. Number 1 equals round 22.44, 1 decimal place. Number 2 equals round 22.48, 1 decimal place. Number 3 equals round 22.438, 2 decimal place. Point number 1, point number. For number 1, we want to round to 1 decimal place as specified by the second value. The number after the 1 decimal place is 4 and it is not up to 5. So the output for num1 will be 22.4. For num2, we also want to round up to 1 decimal place. The number after the 1 decimal place is greater than 4. In this case, the number is 8. We need to round up by adding 1 to the previous number, which is 4. The output for num2 will be 22.5. For num3, we need to round up to 2 decimal places. The number after the 2 decimal places is greater than 5. In this case, the number is 8, so we need to add 1 to the previous number. So the output of num3 will be 22.44. Let's run the program and see the results. Num1 is 22.4, rounded to 1 decimal place. Num2 is 22.5, while num3 is 22.44. The round function shows unexpected behavior when the digits in the decimal part ends with 5. Here is an example. Number 1 equals round 6.5. Number 2 equals round 7.5. Point number 1, point number 2. Let's run the program. Both 6.5 and 7.5 end with 5, but 6.5 rounds down, that is to 6, while 7.5 rounds up to 8. This is because Python 3 and many other programming languages adopt a strategy known as round ties to even. A tie is a floating point number ending with 5. For instance, 4.5, 4.85, 6.485. All these numbers are ties because they are floating point numbers ending with 5. 4.7, 5.2. These two numbers are not ties. If the digit to the left of the last digit in a tie is an even number, you round the number down. In this case, the digit before 5 is 6, which is why 6.5 is 6, because we need to round it down. If the digit is an odd number, you round up, which is why 7.5 is 8. Thank you for watching, and I hope you enjoyed the video. See you in the next video. Hello friends, and welcome to the Learn Python series course. This course will equip you with the core fundamentals needed to start building real-world applications with Python. In this lesson, we will explain the various operators available in Python. Arithmetic operators are primarily used with numeric data types. This includes addition, subtraction, multiplication, and more. For a more comprehensive understanding of numbers and arithmetic operators in Python, be sure to explore Lesson 8 of this course. Assignment operators are used to assign values to variables. Comparison operators compare the values on both sides of them. Additionally, we have logical operators. In Python and programming in general, the equal sign signifies the assignment operator, which facilitates the allocation of values from the right-hand side to variables on the left-hand side. The variable name is age, and the value assigned to the variable is 10. This statement means you want to assign a value of Ali, which is a string data type, to a variable name called name. Once a variable has been declared, we can retrieve the value assigned to it by mentioning the name of the variable. Point name. Let's execute the program. We are able to retrieve the variable because we have declared it. If a variable is not declared and you try to access it, Python will raise an error. Let's comment out the variable name that we have declared. Python raised an error, which is name is not defined. Other variants of assignment involve using an operator alongside the equality sign. Let's declare some variables. A equals 10, B equals 5, C plus equal B. This is equivalent to C equals C plus B. C plus equals B is a short form of C equals to C plus B. If we execute this program, Python is going to raise an error because the second variable C is not defined. We have only defined A and B. Let's run the program and see what happens. Python raised an error. Name C is not defined. We need to define variable C before we can make use of it. C equals 20. On line 6, we defined a variable C and assigned a value of 20 to it. On line 7, we are reassigning a new value to variable C, which is the result of C plus B. Print C. The expected result should be 20 plus 5. Let's execute the program. Aside using the plus operator, we can also make use of other operators such as subtractions, multiplication, division, modulus, exponent, and floor division. C plus equals C is the same as C equals to C plus A. C minus equals A is equivalent to C equal to C minus A. Let's use the subtraction operator. C minus equals B. C equals to C minus B. The expected result should be 20 minus 5, which is 15. Let's execute the program. Great. Comparison operators are used in programming to compare values. The first operator on the list is greater than. It checks if the value on the left is greater than the value on the right. It returns true if so. Less than returns true if A is less than B. Greater than or equals returns true if A is greater than or equal to B. Less than or equal returns true if A is less than or equal to B. Equal to checks if two values are equal. Not equal to checks if two values are not equal. If the value on the left is greater than the value on the right, greater than returns true. Print result. So let's execute the program. The result is true because 4 is greater than 1. Let's modify the code to return false. 0 greater than 1, the result will be false. Execute the program again. If the value on the left is less than the value on the right, less than returns true. Let's execute the program. If that is not the case, less than returns false. Let's modify this to be 6. 6 less than 5, false. Execute the program. This shows that 6 is not less than 5. This sign means greater than or equals to. It compares the value on the left side with the value on the right side. 0 greater than 1, the expected output is false. Let's execute the program. We can modify this to be 1. 1 greater than or equals to 1, true. Execute the program. This returns true. Let's modify the number to be a number greater than 1, 2. 2 greater than or equals to 1, yes. Execute the program again. This sign means less than or equals to. It checks if the value on the left side is less than or equals to the value on the right side. 6 less than or equals to 5. The result will be false. Let's execute the program. Let's modify the value to be 4. 4 less than or equals to 5. It returns true. 5 less than or equals to 5. Yes, the result will be true. Let's execute the program. Great. The double equal operator checks if the values on both sides are equal. If they are equal, it returns true. If not, it returns false. 5 equals to 5. The expected output is true. Let's change 5 to 6. 6 equals to 5. The result will be false. A single equal sign is used for variable assignment, while a double equal sign performs a check between two values. The opposite of the equal to is the not equals to, which is written like this. It checks if the value on the left side is not equals to the value on the right side. 6 not equals to 5. That is true. The result will be true because 6 is not equals to 5. Execute the program. Great. We can also change the value of 6 to be 5. The result will be false because 5 is equals to 5. Let's run the program again. Great. Logical operators are used in conditional statements to control the flow of the program based on the evaluation of conditions. The AND operator returns true if all the conditions are true. For instance, 2 greater than 1 is true, 4 greater than 2 is true. All the conditions are true, so the result will be true. If any of the condition is not true, the AND returns false. The OR operator returns true if at least one of the operands or conditions is true. In this case, 4 greater than 2 is true. 2 greater than 4 is false. The result will be true because one of the conditions is true. The NOT operator negates the value of a condition. If a condition is true, NOT will make it false. Not true means false. The AND operator will return true as long as all the evaluations are true. In this case, 5 greater than 4 is true and 7 greater than 6 is true. The expected result is true. Print result. Let's execute the program. The final output is true. Let's add a false evaluation to it and 1 greater than 2. In this case, the result will be false because the first evaluation is true, the second is true, meanwhile the third is false. So let's execute the program again. Great. The OR operator requires only one of the evaluations to be true to result in a true value. Result equals 5 greater than 2 or 1 greater than 5. 5 greater than 2 is true. 1 greater than 5 is false. The result will be true. Let's execute the program. The NOT operator negates the initial value. If the initial value is true, not true makes it to be false. In this case, let's run the program again and say the result. The result is true. If we enclose everything in brackets, then not. The result will be false. Let's try one more example. Result equals 5 greater than 4 is true. Using not in front of it negates the value. Let's execute the program. The result is false. Initially, 5 greater than 4 is true. Just like arithmetic operators have an order of precedence, logical and comparison operators also have their own order of precedence. This order determines how expressions involving these operators are evaluated. Parentheses are always evaluated first, followed by comparison operators. The comparison operators are on the same level. Logical and logical OR. In the order of precedence, comparison operators are higher than logical operators. That means the comparison parts will be evaluated first. 5 less than 10 is true, or 10 less than 15 is true. 15 greater than 5 is true. At the moment, we have only the AND and the OR operator in the order of precedence and is higher than OR. That means this part will be evaluated first. True or true and true will be true because AND returns true if all the evaluations are true. Finally, we have true or true. True or true will return true if at least one of the evaluation is true. In this case, the result will be true. Let's print out the final result, which is expected to be true. Execute the program. The final output is true. Thank you for watching, and I hope you enjoyed the video. See you in the next video. Hello friends and welcome. In this lesson, we will explain the Boolean data type in Python. The Boolean data type has only two possible values, true and false. A true value is used to represent yes, while a false value is used to represent no. Remember that true and false are reserved keywords in Python, which means they cannot be used as variable names. When you need to declare a variable where its value can only be yes or no, the suitable data type to use is Boolean. For instance, if we need to know a user status, we can use isActive equals true. Similarly, to determine if a student has graduated, we can use isGraduate equals false. We can use the type function to determine the type of the variables. Point type isActive. Let's execute the program. The type function shows that the type of the variable is bool. Apart from assigning a true or false value to a variable directly, we can also determine the value from any evaluation that returns a Boolean data type. For example, isActive equals 6 greater than 5. Point type isActive. The expected data type is bool. This shows that the data type is bool. Here is another example. Starts with arg equals read1 dot starts with arg. Point starts with arg. Point type starts with arg. The start with method is used to check if a string starts with a particular substring. In this case, read1 starts with letter arg, so the expected result is true. The type of variable starts with arg is expected to be a bool. Let's execute the program. Great, the result is true, and also the type of the variable is bool. The bool function is used to convert a value to a Boolean. If true value is passed to it, it returns true. It returns false if the parameter or value passed is false. X equals bool true, y equals bool false. Point x, point y. Let's run the program. Whenever true is passed to bool, it returns true, but when the value passed is false, it returns false. When the bool function is used with a numeric data type, such as an integer, it returns true for all non-zero values and false for 0. For instance, point bool 5, point bool -5, point bool 0. Let's run the program and see the result. The first two evaluations are true, while the third is false. A sequence is any data type that holds collection of items or elements. For example, a string data type is a sequence because it can contain multiple elements. X equals to bool. What we have here is a string data type. Y equals to bool empty string. Point x, point y. If a sequence is not empty, it returns true when the bool function is used with it. If it is an empty sequence, such as an empty string, it returns false. Let's execute the program and see the result. The first result is true because this is not an empty string, while the second is false because it is an empty string. Aside using a string, we can also make use of other sequences, such as a list, 1, 2. This is an empty list. Let's run the program and see the result. Great. Just as we have been using arithmetic operators with numbers, we can also make use of arithmetic operators when dealing with Boolean data types. True is equivalent to 1 and false is equivalent to 0. So we can perform arithmetic operations with the Boolean data types. Results equals true plus true point result. True is equivalent to 1. The expected output here is 2. 1 plus 1 equals 2. Let's execute the program. Great. We can also make use of the minus sign. True minus true, which is 1 minus 1, the result will be 0. We can also say true minus false. That will be 1 minus 0. The result is 1. Let's run the program. Great. We can make use of all the arithmetic operators. True, which is 1, multiplied by false. That will be 1 multiplied by 0. The result will be 0. That is all for now on the Boolean data type. Thank you for watching, and I hope you enjoyed the video. See you in the next video. Hello friends and welcome. In Python, a list is used to store multiple pieces of data at once. In the previous lessons, all the data types we have encountered could only store a single item. The list data type in Python is considered a sequence because it can contain multiple elements. Simply consider a list as a container capable of holding multiple items. Items within a list are ordered and indexable. This implies that we can reference an element using its index. A list is mutable, enabling us to modify the original list. This is in contrast to a string, which is immutable. An essential aspect of Python lists is their ability to accommodate multiple data types. For example, within a single list, we can include both strings and numbers, regardless of their type. Creating a list is as simple as placing various comma-separated values within square brackets. The name of the variable is users, and the value assigned to it is a list which contains more than one item. All the data in this list are strings. Python allows us to store different data types in a list. For instance, items equals 3, 9, 2. The second list, which is items, has different data types. The first item is a string, 9 is a number, while 2 is a Boolean. Let's use the type function to know the type of the variables. Point, type, users, point, items. Let's execute the program. This shows that both of the variables are lists. Sometimes you may need to create an empty list. This can be done by using an open and close square bracket. My list equals print type my list. Let's execute the program. Great. This is an empty list. Another way to achieve this is by using a list function in Python. List underscore a list print type list of a. This is how we can create an empty list. Similar to the string data type, each element in a list has a position known as the index. Indexing in Python, as well as in most programming languages, follows zero-based counting. This implies that the first element in the list has an index of 0, the second element has an index of 1, and so forth. To access an element in a list, we just need to mention the name of the list names, followed by open and close brackets, then the index of the item, in this case index of 0. Let's print the result. The expected output here is early. Let's execute the program and see the result. This is how we can access elements in a list by using the index. Let's do the same thing for other elements. 1, 2. We are able to access the element in the list by using the index. Attempting to use an index that does not exist will result in an index error. Let's use index of 3. Python raised an index error because the index cannot be found. Python supports negative indexing for its sequences. The index -1 corresponds to the last item, -2 to the second to the last item, and so forth. Let's try that out. -1, -2, -3. Let's run the program. Great. To check if an item exists in a list in Python, we use the in keyword. It returns true if the item is present and false otherwise. Here is an example: is present equals 6 in numbers. Print is present. The value from this evaluation is assigned to a new variable called is present. We are making use of the in keyword to check If 6 is in numbers, the result will be false. Let's run the program and see the output. Great. Let's use another number that is present. 2. 2 in numbers, yes. The result will be true. Lists are mutable, which means the items within a list can be modified. Consider a list of numbers. Numbers equals 5, 6, 7, 8. To modify a specific element, you must know its index within the list. For instance, the index of 6 is 1. We need to mention the name of the list and the index which we want to modify. In this case, 1 equals 9. This operation assigns a value of 9 to the element at index 1. Print numbers. Let's execute the program. Great. By now, the original list has been updated. 6 has been replaced with 9 by making use of the index of 6. If we specify an index that cannot be found, Python raises an index error. The indices present in this list are 0, 1, 2, 3. If we specify 4 which cannot be found, Python raises an index error. Let's execute the program and see. This is an index error. List assignment index out of range. List concatenation involves combining 2 or more lists to create a new list. To concatenate lists, we make use of the plus operator. Let's declare a variable list underscore a equals 1 plus 4, 5. Print lists underscore a. The result of this operation will be a new list containing all the elements from both lists in the order they are combined. Let's execute the program. This is how we can combine 2 or more lists to form a new list. The multiplication operator, when used with a list, repeats its element. Here is an example. X equals 1, 2 times 2, print x. Let's run the program. Great. The elements in the list are repeated. In Python, you can access a section of a list by using the slicing operator. Let's declare a new variable, sliced underscore list equals my list, which is the original list, 2, 5. The first part is the starting position and the second part is the upper bound. This is going to get elements from index 2 to index 5, excluding index 5. 0, 1, 2. This will be the starting position. 2, 3, 4. The expected output is all these elements. Let's print the results. Sliced. Execute the program. Great. If the upper bound is not given, it takes all the items from index 2 to the end of the list. Let's try an example. Print my list 2. In this case, the upper bound is not given. That means it returns all the elements from index 2 to the end. Let's execute the program again. Great. When the starting point is not given, it takes all the elements from index 0. Print my list. The starting point is not given and the upper bound is 4. This is going to return all the elements from index 0 to index 4, but excluding index 4. 0, 1, 2, 3. This will be the results. Let's execute the program. Great. If both the starting point and the upper bound are not given, all the elements in the list are returned. Print my list. The result will be a list containing all the elements. This is because the default starting position is 0 and the default upper bound is the end of the list. Let's execute the program. Great. This returns all the elements in the list. Apart from the starting and upper bounds, the slice operator allows us to specify a third value, which is referred to as the step. Slice list equals my list 1, 2. The starting position is 1. If the upper bound is not given, it returns all elements up to the end of the list. The third number indicates selecting every second element. The expected output here should be starting from the index of 1, 0, 1 and selecting every second element. The second element after 2 is 4. After 4 is 6. After 6 is 8. That means the expected output will be a list containing 2, 4, 6, 8. Let's print out the result. Print slice list. Execute the program. This is how we are able to select every second item in the list. The default value of the step, if it is not given, is 1. We can make use of the slice operator to reverse a list. Reversed list, my list. Print reversed list. The starting position is not given. That means the default will be used, which is 0. The upper bound is omitted, making it return elements up to the end of the list. The negative step indicates that this should be done in a reverse order. Let's execute the program and see the output. We have been able to reverse the original list and store it in another variable. Thank you for watching, and I hope you enjoyed the video. See you in the next video. Hi friends, and welcome. In this lesson, we will explore various functions and methods designed to work with a list data type. To understand the concepts better, it is crucial to distinguish between functions and methods. Functions are general purpose tools that perform specific actions. They are called by their names, followed by parentheses, without being tied to a particular object. For example, we can use the len function, which is used to determine the length of an object. In the first example, we are using len with a string, while the second example is a list data type. Methods, on the other hand, are actions that can be performed on specific objects. They are called directly on the object by using a dot notation. For instance, you might use methods like string.startsWith, which is used to determine if a string starts with another string. The startsWith method is particular to a string data type. It cannot be used with a list or a number. The same applies to pop. It is specifically used with a list data type. More in-depth explanations of functions and methods will be provided in upcoming lessons. Without further delay, let's dive in. The insert method is used for inserting a new value into a list. X represents the value we want to insert at index I. Let's say we have a list of courses: agriculture, biology, and chemistry. We can insert a new value into the list by using the insert method. Courses.insert 0 physics. This means we want to insert a new value, physics, at index 0, which is the first position. When physics is inserted at index 0, the value of agriculture and all the following values are shifted to the right. Point courses. Execute the program. Great. We have been able to insert a new value into the list at the specified position, which is the index of 0. By now, agriculture, which was the first element in the list, has been shifted. All items in the list are shifted to the right whenever we use the insert method. The insert method automatically inserts a new item to the end of the list if the specified index cannot be found. The largest index in this list is 2, 0, 1, 2. Let's specify an index greater than 2, such as 5, math. The new item we want to insert will be inserted at the end of the list because the index of 5 cannot be found. Let's execute the program and see the result. Great. This shows that the new item has been added to the end of the list. You can also use a negative index with the insert method. Courses.insert -1 echo. Index of -1 corresponds to the last element in the list. Chemistry, which was initially at index -1, will be shifted to the right by 1 step. Let's run the program. Great. The pop method removes and returns the last item from a list. The value that is removed is returned by the method. Using the same example, courses.pop pop point courses. Let's run the program. The last item from the list has been removed. The removed item can be stored in another variable in case we need to use it later. We just need to say removed item equals courses.pop point removed item. Let's run the program. This makes the value available whenever we need to make use of it. Optionally, we can specify the index of an item to be removed when using the pop method. Let's try that out. 1. This is going to remove the item at index 1, 0, 1. After executing this line of code, biology would have been removed. Let's run the program and see the output. Great. The pop method supports using negative index. Index of -1 corresponds to the last item in the list. This is going to remove the last item in the list. The final list would only include agriculture and biology. Let's run the program. Note that if we specify an index that cannot be found, the pop method raises an index error. The largest index in this list is 2, 0, 1, 2. Specifying any index above 2 will raise an index error. Let's try 4. We got an index error saying pop index out of range. The append method is used to append an item to the end of a list. Let's declare a list of numbers. Numbers equals 1, 2, 3, 4. Numbers dot append 5 point numbers. This operation is going to add 5 to the end of the original list. Let's run the program. Fantastic. The extend method is used to add several new items to the end of a list. You can pass a sequence type as an argument to the extend method. Let's say we want to add several courses. Courses.extend agric math point courses. The extend method allows us to add multiple items at once. Let's run the program and see the results. We have been able to add multiple items to the original list. Additionally, you can pass a string to the extend method, and each character in the string will be treated as a standalone element. Remember that what you really need to pass to the extend method is any sequence type, that is, any data type that can hold multiple elements. Courses.extend math. Let's run the program and see the output. Each element in the sequence are treated separately and added to the original list. The reverse method is used to reverse the items in a list. This method modifies the original list in place and does not return any value. For example, numbers equals 1, 2, 3, 6, 5, 9. Numbers.reverse point numbers. Let's execute the program. This code reverses the order of elements in the list, that is, from the last item to the first item. It is important to note that all list methods do not necessarily return a value. New numbers equals point new numbers. The reverse method modifies the original list, but it does not return anything. In this case, new numbers will be null because the reverse method only modifies the list in place and does not return a reversed copy. Let's run the program and see what we have as the new numbers. This is none. The remove method removes the first occurrence of a specified value from the original list. If the specified value cannot be found in the list, Python raises a value error. Courses.remove biology point courses. Let's run the program. The first occurrence of biology has been removed. Specifying a value that does not exist makes the remove method to throw an error. Let's try that by including 1 to the biology. Execute the program. Value error. List.remove x. X not in list, which means that the value we passed to the remove method cannot be found in the list. The count method returns the number of occurrences of a specified value in a list. This is particularly useful when you need to know how many times a value occurs in the list. We can define a variable times equals numbers dot count 1 point times. Let's execute the program. This shows that 1 occurs 2 times. The sort method sorts the list items in ascending order. Numbers.sort point numbers. Let's execute the program. Great. The numbers are now sorted in ascending order. To sort in descending order, you can make use of the reverse flag. Reverse equals 2. Let's run the program again. Great. The clear method removes all the items from a list. Numbers.clear point numbers. After running this line of code, all the elements in the list would have been cleared. The final output shows an empty list. That's all for now. Thanks for watching and see you in the next video. Hi friends and welcome. In Python, there are 2 ways of copying values from one object to another: shallow copy and deep copy. To fully understand these techniques, we need to know what happens when a variable is declared. A equals 1. This translates to the assignment of the value 1 to a variable named A. When you perform this assignment, a variable is created and the value associated with this variable is stored in a specific location in computer memory. In computer terms, this is referred to as an object. A serves as a reference to that object. After this assignment operation, the value of A is 1. That means we can easily say print A, and the value we get from it is 1. On line 2, when we say B equals A new variable B is created, but it references the same previously created object. At this point, if we access both A and B, their values are both 1, since they both reference the same object in the computer memory. The third assignment, A equals 2, creates a new reference to a completely new object entirely. That is why the value of A is 2 and the value of B is 1, which was the first object created. Going by the same principle, but using a list in this case. In this example, A represents a list of numbers. A new object is created in the computer memory and A references this object. When we assign B equals A new reference B is created and it references the same objects. Every change made to either A or B will affect the other one. This is because A and B are referencing the same object in the computer memory. When we say A.append 4, the value of A is modified and the value of B is also modified because both of them are referencing the same object in the computer memory. When we say B.append 5, that is, we are making modification to B, A is also affected because they are referencing the same object in the computer memory. This behavior is not always what we want. The copy method provides a solution to this problem. If you want to avoid this behavior and create a separate copy of the list, you can use the copy method or other techniques such as slicing. Every object in Python has a type, a value, and a reference count. Operations such as variable assignments or passing an object to a function increase the reference count of an object. When the reference count drops to 0, the object is automatically discarded and its space becomes immediately available for use. At that point, there is no reference to such an object. We mentioned in the presentation that when you need to create a new object from another object, using the assignment operator may not produce the desired result because any changes you make to either the original list or the new list will affect the other. Let's practicalize that. Point original list, point new list. Let's execute the program and see the output. Great. For now, the original list and the new list have the same result because they are referencing the same object in the memory. So now let's make a modification to original list dot append 5. Let's run the program and see what happens. As you can see, any modification we make to any of the list will affect the other. In most cases, this is not the desired output. A workaround this, as mentioned, is to use the copy method. Let's try that. Original list.copy. Let's execute that and see what happens. Great. As you can see, the change we made to the original list does not affect the new list. That is exactly what we want. We can also make use of the slicing operator to achieve this. Original list. This syntax is going to copy all the items in the original list. Let's execute the program. Great. This method of copying object is known as shallow copy, which means that the new copy has some references to the child objects found in the original list. This will be revealed in the next example. Let's modify the original list to have some sort of children. Let's modify any child element. Original list, index of 1. Remember that index of 1 is referring to the list inside the original list. 0, 1, 2. The index of this element is 1, 0, 1. So we can make reference to it. 1 equals 9. What we are doing here is that we are assigning a new value of 9 to this element, and this element is referring to 3. In this line of code, we are modifying the original list. Remember to put a comma after each of the elements. Let's see what happens after executing the program. We have modified the original list by changing 3 to 9, which is what we have here, but the new list, which is a copy of the original list, was affected. This method of copying objects, whereby the inner objects or child objects are referenced in the copied version, is known as shallow. To really overcome this behavior, we need a deep copy, where the original and the copy are fully independent. To use deep copy, we need to import the copy module. Import copy. Then we do copy dot deep copy original list. Let's execute this program and see what happens. Great. As you can see, the original list and the new list are now fully independent. This time, the original list was cloned recursively, including all of its child objects. Any modification to the original list does not affect the copied list, as we can see from the result we have here. The sum function takes a list of numbers as input and returns the sum of the values in the list. Result equals sum, a list of numbers 1, 2, 3, 4. Print results. This is going to return the sum of all the numbers in the list. Let's execute the program. The sum of the numbers in the list is 10. If the list is empty, the sum function returns 0. Let's try that out. The min function, short for minimum, returns the minimum value from a list. Numbers equals 1, 2, 3, 4, 5. Minimum equals min numbers. Point minimum. This is going to return the minimum value in the list. Let's run the program. Great. The minimum value in the list is 1. If the list is empty, the minimum function raises a value error. Let's run the program again. The minimum function raised a value error. The error says minimum argument is an empty sequence. That means the sequence passed to the minimum function must not be empty. The max function, short for maximum, returns the maximum value from a list. Maximum equals max numbers. Point maximum. The maximum value in this list is 8. Let's execute the program. Great. Just like the min function, if the list is empty, the max function also raises a value error. Let's see that in action. Let's run the program. Great. This error is similar to what we encountered when using the min function. You can use the list function to create a new list from any other sequence. When you pass a sequence into the list function, it turns the sequence into a list. Each item in the original list is treated as a separate element by the list function. Let's declare a variable var name equals mango. Let's use a list function to turn this into a list. Point var name. This code will create a new list containing the individual characters of the string. Let's run the program. Great. As mentioned earlier, you can create an empty list by using the list function. Let's execute the program. This returns an empty list. In Python, both the sort method and the sorted function are used to sort lists, but they behave differently. The sort is a method, which means to use it, we need a dot notation on the original list. Sorted, on the other hand, is a function. The sort method modifies the original list and does not return a new list. The built-in sorted function takes a list or just any iterable as input and returns a sorted list. The original list remains unchanged with the sorted function. If you want to keep the original list intact and create a new sorted list, you should use the sorted function. We declared a variable called myList, which is a list of numbers. By using the sorted function, the original list is not modified. New list equals sorted. Point new list point original list my list. Let's execute the program and see the output. Great. With the help of the sorted function, we have been able to sort the list without modifying the original list. The new list is 1, 2, 3, 4, 5, which is a sorted list, while the original list is intact. This is in contrast to using the sort method, which modifies the original list in place. That's all for now. Thanks for watching and see you in the next video. Hi friends and welcome. In this lesson, we will explore the tuple data type in Python. A tuple data type is similar to the list data type. It consists of items separated by commas. Unlike lists, tuples are enclosed within parentheses. The key difference between a tuple and a list is that lists are enclosed in square brackets and their values can change, whereas tuples are enclosed in parentheses and their values cannot change. This means that a tuple is an immutable sequence which contains multiple items but cannot be changed. Similar to the list data type, items in a tuple are ordered and indexable. The first element is array, which is a string data type. The second element is 9, which is an integer, and the third is a Boolean. A tuple is written out as a comma-separated list of values surrounded by parentheses. My tuple equals 1, 2, 3. Tuples may contain any type of value, including values of different types. My tuple B equals array 786.2.23. The first element in the second tuple is a string. This is an integer, a float, and a Boolean. Let's use the type function to show the type of the variables created. Point type my tuple. Let's execute the program. This shows that the type of the two variables is tuple. If you need to create an empty tuple, you simply use empty parentheses. Empty tuple equals empty tuple B equals. Another way to create an empty tuple is to use the tuple function. These two approaches are similar to creating empty lists. For an empty list, we use square brackets and the list function. Let's also make use of the type function to know the type of the two variables. Point type empty tuple point type empty tuple B. Let's execute the program and see the results. Great. The two variables we have created are empty tuples. Similar to the list data type, we can access an element in a tuple by using the index of such an element. The first element has an index of 0, 0, 1, 2, 3. To retrieve the first element, we simply mention the name of the tuple, followed by square brackets, then the index of the element we want to retrieve, which is index of 0. Let's print out this point. Let's execute the program and see what we have. Great. We have been able to access the first element by making use of the index. Index of 0 corresponds to the first element. Index of -1 corresponds to the last element in the tuple. Let's execute the program and see what we have. Great. Specifying any index above 3 is going to throw an index error. Let's try 4. Python throws an index error. Tuple index out of range. A tuple is an immutable data type. That means we cannot modify its element once it is declared. Let's try to change one of its items by using the index value. My tuple 2 equals 7. This part of the code is referring to the item at index 2 in the original tuple, which is 2.34 equals 7. We are trying to assign a new value of 7 to this item. This operation is going to throw an error because tuples are immutable. Let's execute the program and see what we have. Great. Tuple object does not support item assignment. Tuple does not support removing an item from its contents as an immutable data type. This means using the del statement and the index of the item to be removed will not work. Let's say that in action. Delete or del my tuple and index of 1. We intend to delete the item at index 1, which is 7. Let's see what happens. Python raised a type error, which is tuple objects does not support deleting an item. You can combine two or more tuples together using the plus operator. My tuple equals 1, 2 plus 3, 4 point my tuple. When this is done, all the elements in the individual tuples are packed into a single tuple. Let's see the result. Great. This is how we can combine or concatenate multiple tuples together. When the multiplication operator is used with a tuple, a new tuple is produced containing repetitions of the original tuple. Let's see that in action. Great. The original elements are repeated. The len function returns the number of items in a tuple. Let's declare a new variable. Size equals length of my tuple point size. This line of code is going to return the length of the tuple 1, 2, 3, 4, 5. The expected result is 5. Let's execute the program. Great. Take note that a tuple can also be inside another tuple. In that case, it will be treated as an element. For instance, let's replace 5, 1, 2. This is treated as an individual item in the tuple, though it is another tuple. 1, 2, 3, 4, 5. Let's run the program again and see the output. Great. The max and min functions in Python return the maximum and minimum values from the elements within a tuple or any other iterable sequence such as a list or string. That's all for now. Thanks for watching and see you in the next video. Hi friends and welcome. One of the most useful data types in Python is a dictionary. In this lesson, you will learn what a dictionary is and how it differs from a list and a tuple. Think of a dictionary as another container like a list and a tuple, but it stores its data in a slightly different way. Every item in a dictionary has both a key and a value. You can visualize the Dict data type as a real dictionary where a word corresponds to its definition. In the context of Python, the word represents the key, and the definition is the value that the key holds. To create a dictionary in Python, we simply enclose all the keys and values within curly braces. Each key is separated from its value by a colon. For instance, the first key is age, and the value is 7. The second key is name, and the value is array. Immediately after the first key and value, a comma is introduced before the next key and value. Essentially, a dictionary in Python allows you to associate one thing with another. The values of a dictionary can be any data type. For example, the first value is a number, while the second is a string. But the keys must be of an immutable type, such as a string, numbers, tuples. A mutable data type, such as a list, cannot be used as key in a dictionary. Creating a dictionary in Python is like making a list of words and their meanings. Every item in a dictionary has a key and a value. Let's declare a variable which is a dictionary. User_info, which is user information, equals. Items of a dictionary are enclosed in curly braces. Then we can say the first key is name and the value is array, which is a string. The second key is age and the value is 10. This is a dictionary data type. Each key in a dictionary is separated from its value by using a colon. An item is separated from another item using a comma, which is what we have here. Remember that keys of a dictionary must be an immutable data type, such as strings and numbers. We cannot use a mutable data type, such as a list, as a dictionary key. Let's use the type functions to know the type of the variables created. Print type user_info. Let's execute the program and see the output. Great. The type of the variable we have just created is a dictionary, which is a key value pair. To create an empty dictionary, we can make use of empty curly braces or simply use the Dict function. Let's declare a new variable. Variable A equals Dict. Variable B equals Dict. These are the two ways we can create an empty dictionary, by using empty curly braces or by using the Dict function. Let's print out the value of both variables. Print variable A, print variable B. Let's execute the program. Great. The two variables we have created are empty dictionaries as shown on the terminal. We can access a dictionary item by using square brackets along with the key to obtain its value. For example, let's say we want to access the age from the user information dictionary. We need to mention the name of the dictionary, which is user_info, followed by open and close brackets containing the key we want to access. In this case, let's access the name. Let's print out the results. Print. So let's execute the program. Great. We have been able to access the value by using the key, which is name in this case. If we need to access age, we specify the age as the key. Let's run the program again. Great. The first result is Ray, which is the value of the name, and the second result is 10, which is the value of the age. We simply make use of the keys to access the values. You do not need to remember the order of items as you do with lists or tuples. It is important to note that if we try to access a key which cannot be found in the dictionary, Python is going to throw a key error. Let's see that in action. H1, which is a key. Now let's execute the program. Python raised a key error. That is because H1 that we have specified is not a key in the dictionary. You can add an item to a dictionary by specifying the name of the dictionary, followed by square brackets containing the key you want to add. Let's say age equals 9. This operation is going to add a new item having the key to be age and the value to be 9 to the dictionary. By the end of this operation, we have two items in the dictionary, which is name and age. Let's print out the content of the dictionary. Execute the program. Great. The content of user information has been updated to include a new item having the key to be age and the value to be 9. If the key we intend to add is already existing in the dictionary, the value gets updated with that key. In the original dictionary, we already have the name as a key. So let's add a new item having the key to be name, which is already existing in the dictionary, and the value to be Bob. After this operation, the value of name will be updated to be Bob. Remember that a dictionary does not contain duplicate keys. So let's execute the program. Great. The value of the name has been updated to Bob. To delete an item from a dictionary in Python, you can make use of the del statement. Del, specify the name of the dictionary, then the key to delete, which is name in this case. Let's print out the content of the dictionary after the operation. Alright, so let's execute the program. Great. As we can see, the item in the dictionary having the key to be name has been removed. If we specify a key that cannot be found, let's say 1, name 1, Python is going to throw a key error as shown earlier. Let's execute the program. Great. We can merge two or more dictionaries by making use of the pipe symbol, that is, this vertical line. The items in the individual dictionaries are packed into a single dictionary. Final dict equals A, which is 1, merged with another dictionary B, 2, point, final dict. The final dictionary will be a merge of what we have on the right hand side and the left hand side. We can merge more than two dictionaries. Let's execute the program and see the content of the final dict. Great. The final dictionary is now a single dictionary containing items from the individual dictionaries. We should also note that when keys are shared in the dictionaries, the values of the second or last dictionary take priority. In the second dictionary, we are going to create another item having the key to be A, the value to be 5. In this example, two dictionaries are having the key to be A. That means the value to be taken would be coming from the second or the last dictionary. Let's execute the program and see what we have. Great. A is now having value of 5 and B is having value of 2. The in keyword can be used to check if a dictionary has a particular key. Let's declare a variable has underscore key equals age in user info point as key. The result we get from this evaluation is stored in a new variable called hasKey, age in user information, so the result will be false. Let's execute the program. Great. Let's change this string to a key that can be found in the user info, which is name. Name in user information, yes. The result will be true. Let's run the program again. Great. The len function returns the number of items in a dictionary. Items in a dictionary are separated by commas. That means in this dictionary we have 2 items, 1, 2. Let's print out the total number of items in the dictionary. Total item equals, then user information, print total items. Let's execute the program. Great. The total number of items we have in this dictionary is 2. That's all for now. Thanks for watching and see you in the next video. Hi friends and welcome. In this lesson, we will explore some of the methods available to work with a Dict data type. Without further delay, let's dive in. Using the get method on a dictionary is another way to access the value of a particular key. Let's declare a variable value equals userinfo, which is a dictionary.get. The key to be retrieved is put within open and close brackets. If the key exists in the dictionary, the value will be stored in a variable called value. If the key does not exist, it won't cause any error. Instead, it will return none by default. Let's print out the value. Execute the program. Great. We have been able to use the get method on a dictionary to retrieve the value of a particular key. If the key does not exist, let's say age 1, the get method is going to return none. Great. We are also allowed to provide a default value if the key cannot be found in the dictionary. Let's say NA, which means not available. Let's execute the program again. We are able to provide a default value for a particular key if it cannot be found in the dictionary. The get method is helpful because it avoids potential errors if the key does not exist in the dictionary. It also allows us to set a default value. The clear method is used to remove all the items from a dictionary in Python. After using this method, the dictionary becomes empty, containing no key value pairs. Userinfo.clear print userinfo. Let's execute the program. Good. Initially, the userinfo dictionary has an item which is a key and a value, age 10. After using the clear method, all the items in the dictionary are cleared, which makes the dictionary to be an empty dictionary, as we can see on the terminal. If a key is in a dictionary, the pop method removes it and returns its value. Let's declare a variable called removed item equals userinfo, which is the dictionary dot pop age, print removed item, print userinfo. The item having age as the key will be removed from the dictionary, and the value of the key removed will be saved in a variable called removed item. Let's execute the program and see what we have. Great. The age has been removed from the original dictionary, and the value of the key removed is saved in a new dictionary, which is 10. The pop method can take a default value to be returned if the key cannot be found. Let's specify a key that cannot be found in the dictionary, such as age 1. In this case, if we try to execute this program, it is going to throw a key error because the key age 1 cannot be found in the original dictionary. One way to avoid this is by providing a default value. Let's provide a default value of 20. That means if we try to remove age 1, which the key cannot be found in the dictionary, it is going to return a default value of 20. Let's execute the program again and see what we have. As you can see, the default value returned is 20. The age 1 cannot actually be found in the dictionary. If the default value is not given and the key is not in the dictionary, a key error will be raised. With this operation, Python will raise a key error because age 1 cannot be found as a key in the original dictionary. Let's execute the program. Python raised a key error. The update method can be used to update the content of a dictionary. Let's say we want to add a new item to the original dictionary. We simply say userinfo.update. Then the dictionary we want to add to the original dictionary. Name. Point userinfo. Let's run the program. We have been able to update the original dictionary. Another approach to achieve this is by specifying the name and the value. Let's try that out. We simply say userinfo.update. The key, which is name, equals way. With this approach, we are going to arrive at the same results. Let's execute the program. In addition to the previous dictionary methods we have discussed, a Dict data type also supports items, keys, and values. All these are methods that can be used to visualize the content of a dictionary. The Dict.items method returns a view of the dictionary's items. Print userinfo.items. Let's execute the program. These are key value pairs of the items in the dictionary. We can also make use of the keys. Print userinfo.keys. Let's execute the program. This returns a view of the dictionary's keys. Print userinfo.values. Let's execute the program. Good. This returns a view of the values 10, array, and 7. The dictionary copy method works similar to a list copy method. It provides a shallow copy of the original dictionary. Check out the list copy method to know more about shallow copy. That's all for now. Thanks for watching and see you in the next video. Hi friends and welcome. A set is an important data type in Python. It can store multiple items, just like lists, dictionaries, and tuple. But items in a set must be unique. This means a set is particularly useful when you do not want duplicate data. In this course, we will explore the set data type and its associated methods and operations. We will also explore concepts like set union, intersection, and others. Without any delay, let's get started. We can create a set by enclosing its elements within curly braces separated by commas. Let's declare a variable called set_a equals 5, 6, 7, 8. The items in set_a are 5, 6, 7, and 8. Now let's print out the value of the variable. Print set a. We can also print out the type of the variable. Type set a. Let's execute the program. The type of the variable as shown is a set. The good part is that if we include duplicate values when declaring a set, all the duplicates are automatically removed when the set is created. Let's try to include duplicate values like 5, 6, and 7. So now let's execute the program again and see the output. Despite all the duplicate values we included, the final set is unique. Remember that elements within a set must be unique. Python sets should not be confused with dictionaries. Dictionaries are key value pairs enclosed within curly braces. We should also note that mutable data types such as lists and dictionaries are not allowed to be used as elements in a set. String, number, boolean, and tuple are examples of data type that can be stored in a set. Another way to create a set is by using the set function. It takes any iterable object such as a list, string, or tuple. Let's declare a variable set_b equals set. Now let's pass a list to it. 1, 2, 3. Print set b. Print type set b. Let's execute the program and see what happens. Great. The type of the variable created is a set. Remember that we can pass any other iterable to it. Let's pass a tuple to the set function and see what we have as the output. We simply need to change the square brackets. So now let's run the program and see what we have. The type of the variable created is a set, and the value we pass to the set function is a tuple. We can also pass a string to it, A, B, C, C, D. Let's execute the program and see the output. The type of the variable created is a set. The values inside the set are B, D, C, and A. A, B, C, C, D. A duplicate value is automatically removed when creating a set. To create an empty set in Python, we simply use the built-in set function. Empty set equals set. Let's check the type of the variable created. Print empty set. Print type of empty set. Let's execute the program. Great. The type of the variable created is a set, and this is an empty set. Using empty curly braces will only create a dictionary, not a set. Let's try that out. So now let's execute the program. Great. This is an empty dictionary, and the type of the variable created is a dict. Sets are mutable but not ordered. This means that updating an element in the set using an index value will not work. To add an element to a set, we use the add method. So let's add an element to set_a. Set_a dot add. The value we want to add will be inside the add method. Let's run the program. We have successfully added a new element to the set. The update method is used to update a set with other items from other collections, such as lists, tuples, or other sets. When the update method is used, all items from the collection passed are treated as individual elements within the original set. Let's declare an initial set, initial_set equals 1, 2. Now let's use the update method to update the initial set. Initial set.update. We can pass any collection type such as a list, string, tuples, or a set. So let's pass a list to the update method. 4, 5, 6. Let's print out the initial set after it has been updated. Let's execute the program and see the output. Great, the final set has been updated to include elements from the list passed to it. Let's try to use a tuple as well. Let's execute the program. Great, we get the same result. We can also make use of a string data type, ABC. Let's execute the program. All the elements are treated as individual elements within the original set. The discard method is well suited for removing an item from a set. If the item passed to this method cannot be found in the set, nothing happens. Set_a.discard. So we want to discard 2. We just need to pass 2 to the method. Print set_a. Let's run the program and see what we have. The final set contains 1 and 4. The clear method removes all the elements from a set, making it empty. Let's try that out. Set_a.clear. Print set_a. We are printing set_a, that is the value of set_a after performing this operation. So let's execute the program and see the output. The value of set A is now an empty set, as we can see from the terminal. The pop method removes and returns a random element from the set. Let's try it out with an example. Set_a.pop. Let's print out the set after performing the operation. Let's execute the program and see the output. Great, the value of 4 has been removed from the original set. The pop method raises an error if the set is empty. Let's try it out. Now let's execute the program. We got a type error because the set is empty. That's all for now. Thanks for watching and see you in the next video. Hi friends and welcome. In this part of the course, we are going to cover some built-in functions that can be used with a set data type. The sorted function provides a way to transform a Python set into ordered values. When the sorted function is used with a set, the final output will be a sorted list of items. Sorted_values equals sorted set B. Let's print out sorted values. The type of sorted value, type sorted values. Let's execute the program and see the output. Great, we now have a list of sorted values. Remember that the final output after using the sorted function is a list. It is no longer a set. Values inside a set are not ordered. The set function, aside from being used to create a set, can also be used to remove duplicates from a list. To remove duplicates from the list, we can make use of sets. We simply need to use the set function on the list. Let's declare a new variable called set_values equals sets. Then we pass in the list, which is duplicate list. We can print out set values, which is going to be a set. Let's execute the program and see what we have. We have been able to remove duplicate value from the list. What we can do now is to convert the set back to a list. Remember that the initial data type is a list. So now let's convert this set value into a list. We can make use of the list function to achieve this. We say final list equals list, which is a Python function. Then we pass in the value of the set values. Print final list. We are using the list function to transform the set back to a list. And finally, we are printing it out. Let's execute the program and see what we have. We now have a list containing unique values. The len function returns the length of a set, which is the same as the number of items in the set. Print len of set A. Let's execute the program and see the output. The number of items in the set is 3. The max function returns the largest item in the set. We are going to declare a variable called max_value to store the largest item, max of set A. print max value. So now let's execute the program and say the output. The largest item in the set is 9. The min function returns the smallest item in the set. Min value, which is a new variable we are declaring, the value we are assigning to it should be min minimum of set A. So now let's print out the min value. Let's execute the program. The minimum value in the set is 1. The sum function returns the sum of all the elements in the sets. Let's declare a variable called total equals sum of set A. Print total. Let's execute the program. The summation of all the values in the set is 6. The union of two sets A and B includes all the elements of A and B. Let's declare a third variable C equals A union B. The pipe symbol can be used for union operation. Now let's print out C, which is union of A and B. Let's execute the program and see the output. Another way to achieve this is by using the union method, which is C equals A dot union of B. Let's execute the program. Great, we have the same results. The intersection of two sets A and B includes the common elements between set A and B. Let's declare a third variable, C equals A intersect B, print C. Let's execute the program and see the output. The intersect includes elements common to both sets. We can also make use of the intersection method. C equals A dot intersection B. Let's run the program again. We have been able to retrieve elements common to both sets. The difference between two sets A and B includes the elements of set A that are not present in set B. We simply need to write A minus B, print C. The expected output should be a set containing 4. 4 is the only item present in A but not in B. Let's execute the program and see the output. Great. We should also take note that A minus B is not the same as B minus A. Let's try that out. B minus A. B minus A means elements of set B that are not in set A. The expected output should be an empty set because there is no element in set B that is not in set A. Let's execute the program and see the output. Great, the difference is now an empty set. The is disjoint method returns true if the set has no elements in common with other. Sets are disjoint if and only if their intersection is empty set. Let's declare a third variable C equals A dot is disjoint B, print C. The final output is false. The in keyword in Python can be used to check if an item exists in a set. Let's declare a variable called check equals 1 in set A, print check. The expected output is true because 1 is present in set A. Let's execute the program. Great. Let's try to use another value which is not present. 0. 0 in set A. No. Let's try that out. Great. That's all for now and thank you for watching. For further information on sets in Python, please check the link provided in the video description. See you in the next video. Hi friends and welcome. So far so good. We have been able to cover the essential data types available in Python. As a software engineer, you will always need to make decisions about which data type best suits the problem you are solving. In this lesson, we are going to discuss how to choose the right data structure when building an application. A data structure provides a particular way of storing and organizing data so that any subsequent operations such as data access and modification can be performed easily. List, tuple, dictionary, and set are all basic data structures that come with Python by default. Complex data structures such as trees, graphs, linked lists, and so on are beyond the scope of this series. In general, the type of data structure you need depends on the problem you are solving. If what you need to achieve involves maintaining unique items within a dataset and the order of items does not matter, then a set is the right choice. Sets also allow for operations such as intersections, union, and difference. A list is the right choice when the primary purpose of the data is iteration. Iteration involves going through the items in the dataset one by one. It is important to remember that Python lists are mutable, making it possible to modify the original items. For example, if you have a list of numbers and you need to square all the numbers, then a list would be suitable for this purpose because you will need to iterate through each number and make necessary modifications. A tuple is also well suited for iteration, but you will not need to alter the data during the program. Remember that a tuple is immutable. If there is any data container you do not want to modify by mistake, then a tuple would be the right choice. You should use a dictionary if the primary purpose of the data structure is looking up values. Given a particular key, we can look up the associated value in a dictionary very quickly. Looking for an item in a list, tuple or set can be challenging because we need to iterate through each item and check if it is the one we are looking for. This approach is not efficient. That is why Python dictionaries are suitable for effective lookups. That's all for now. Thanks for watching and see you in the next video. What's going on, guys? In this video, I'm going to explain how Python makes decisions. Don't worry if you are new to Python. By the end of this lesson, we are going to create a basic Python project. It will take a student's score as input and figure out their grade. Without any delay, let's dive in. In our previous lessons, we wrote a few lines of code using a code editor. You might have noticed that the code we write runs one line at a time. This means line 2, which is this print statement, will only run after line 1 is finished. Let's execute the program and see the output. Great, so the program runs line by line, from the top to the bottom. Sometimes we only want to run a part of the code when a condition is met. For example, you might want to run line 2 only if a particular condition is true. This is where the if keyword in Python becomes useful. I will show you how it works in a moment. When you write an if statement in Python, you must provide a condition. This condition is a regular Python code that must evaluate to true. If the condition is true, then this block of code will run. If it is false, the block of code will be skipped. Now, what makes a valid condition? Let's go over it. The first type of condition you can use is a Boolean data type. If the condition is true, then the inner block will run. If it is false, the inner block of code will not run. Notice that the inner code is not starting from the beginning. Another valid condition is any expression that evaluates to a Boolean. For example, 5 greater than 4 will return a Boolean, which is either true or false. A variable can also be used as a condition. The key is to understand when a variable evaluates to true or false. Let's dive into actual coding. Every program starts running from the first line of code. Let's introduce a condition before line 2 runs. We need to use the if statement. If followed by a Boolean or anything that evaluates to a Boolean. True. Then add a colon. Now we have set a condition. The next part is what we want to do if the condition is true. Press enter after the colon. Notice that the next line does not start from the very beginning. This is the inner code to execute if the condition is met. Print coming after a condition is true. The spaces before this line of code are known as indentation. Python uses indentation to group lines of code together. This inner part of the code runs if the condition is true. We can decide to write something else to the terminal. Condition is true. Now let's run the entire program and see what happens. Great. As we can see, the conditional statements run because the condition is true. If we were to use false, it wouldn't run. Let's check that out. False. Now let's run the program and see the outputs. The inner block of code did not run because the condition is false. Instead of using just true or false, in real applications, you usually use expressions that check if something is true or false. Let's declare two variables. X equals 20, y equals 10. Now let's use the if statement. If x greater than y, print x, which the value is 20, is greater than y, which the value is 10. This expression is going to evaluate to either true or false. This inner line of code will only run if the condition is true. 20 greater than 10, the answer is true. This line of code is going to run. Let's execute the program and see the output. Great. Let's make this expression to evaluate to false. We just need to change the variable value x equals 5. 5 greater than 10, the answer is false. That means if we run this program, this line of code is not going to run. Let's execute the program and see the output. Nothing is printed to the terminal because the condition we have here is not true. You can also evaluate a condition by using a variable directly. Simply declare a variable like this: x equals 10. This can be a number, string, dictionary, or any other data type. If x print, this line runs because x is true. This raises an important question: when will a variable evaluate to true? Any non-zero number like 1 and 2 is considered true. Also, a non-empty string is true. A non-empty list, dictionary, or similar container is considered true. Let's declare some variables. Number underscore 1 equals 2. I need to reduce the font size to show more code on the screen. String underscore 1 equals AB. List underscore 1 equals a non-empty list. Dict underscore 1 equals a non-empty dictionary name. If number 1 print number is not 0, if string 1 print string is not empty. You can also say if list underscore 1 print list is not empty, if dict dictionary print dict is not empty. Now let's execute the program and see the output. Great. As you can see, all the inner blocks of code ran because the variables are considered true. Number underscore 1 is true because this is not 0. The same thing for string. This is not an empty string. That is why it is considered true. The same applies to a list and any other container such as a dictionary and set. If they are not empty, they are considered true. That is why the inner block of code ran. Now let's change the values assigned to the variables. 0, an empty string, empty list, and empty dictionary. Let's execute the program again and see the output. Great, the inner blocks will not run because the variables are now considered false. I hope this clarifies the topic for you. In the next lesson, we will cover another aspect of conditional statements in addition to the project exercise. If you have any questions, please feel free to ask in the comment section. Also, consider liking and subscribing to the channel for more educational content. Thanks and see you in the next video. What's up everybody? In this lesson, we are picking up right from where we left off with conditional statements. If you missed the previous lesson, make sure to catch up on it. We are also going to write a Python application that calculates a student's grade based on the score entered. Without further delay, let's dive in. Just like if, else is also a keyword in Python. This means when the first condition is not met. In other words, when it is not true, you want to do something different. This block of code will only run if this condition is true. If it is not true, this part of the code will be executed. Let's jump into the code editor and practice this. Let's declare two variables, x equals 10, y equals 20. If x is greater than y, print x is greater than y. This is the line of code that is going to run if this condition is true. If the condition is not true, we want something else to be executed, and that is why we need the else keyword. Type else keyword followed by a colon, then press enter on the keyboard. Notice that in the next line is not starting from the very beginning. Print x is not greater than y. If this condition is not true, we want something else to be executed, and that is this line of code. The expected output is this line of code because x, which is 10, is not greater than y. If this condition is false, then this line of code will be executed. Let's run the program and see the output. Great, x is not greater than y. Let's modify the variable x to be greater than y by writing 50. 50 greater than 20, yes, the output is true. That means this line of code will be executed. Let's try and run the program again and see the output. X is greater than y. Essentially, you make use of the else keyword if you want a block of code to be executed when an initial condition is not true. Let's try one more example by using a list. List underscore a equals a list of strings. If a, which is a string, in list a, print a is in list underscore a, else print not found. We are establishing a condition here which is going to evaluate to either true or false. A in list A, that is string A present in list A, the answer will evaluate to either true or false depending on whether string A is present in list A. A in list A, the answer will be true. That means this line of code will be executed. If this condition is not true, that is if string A is not present in list underscore A, the result will be false, and that is why this line of code will be executed. Let's try to execute the program. The output is string A is in list A. Let's try and modify this to be D. D in list A, the answer will be false because D, which is a string, is not present in the original list, which is list underscore A. That means this line of code will be executed. So now let's run the program again and see the output. The answer is not found. The elif keyword in Python allows us to perform an additional check in case the first check is not true. It is a way of saying if the previous condition is not true, then try this condition. If this condition is not true, then try this condition. Else, if none of the conditions is true, then execute this. Let's use a grade system as an example. Grade equals A. If grade equals A, point, excellent. Elif grade equals B, point, very good. Elif grade equals C, point, good. Else, point, grade not found. The first condition is to check if grade is equal to A. If this check does not evaluate to true, then we want to try another condition by using elif. Elif grade is equals to B, then this line of code will be run. We can use as many elif statements as needed. If this condition is not true, that is, it does not evaluate to true, then we want to try another condition, which is grade equals C. If none of the conditions is true, then the else block will be executed. If grade equals A, execute this. Elif grade equals B, execute this. Elif grade equals C, execute this. Else, that is, none of the conditions is true, then execute this line of code. Let's try and execute the program to see the outputs. The output is excellent because grade is A. Now let's modify grade to be B. Save the file and run the program again. The output is very good because grade is equal to B. So now let's try to use K. The expected output here is grade not found because none of the checks is true. Let's execute the program. Great. The answer is grade not found. One point to note is that if any of the conditions is true and its block is executed, then the rest of the conditions would not be checked. Alright friends, so let's start writing the grade calculator app. The first requirement is to display a welcome message to the user. After that, we need to accept the user's input. Once a user provides an input, we need to validate what the user provides because we cannot always trust the user's data. After that, we check where the user score falls. And finally, we display the grade. We can use the print function to display something on the screen. We are just going to write print grade calculator. Print this app computes grade based on score. To ask the user for a value, Python provides the input function for this purpose. We need to declare a variable to store what the user provides. User underscore score underscore input equals inputs, enter your score. The string inside the input function is optional. It is meant to be displayed before a user inputs a value. The value from the user is captured and stored in this variable, which is user underscore score underscore inputs. For now, let's print out what the user has entered. Now let's run the program and see the output. Let me enter 90, then press enter. As you can see, the user provided input is printed to the terminal by using the print function. Regardless of the data type entered by the user, the input function always converts it to a string. Let's confirm that. Print type user score input. The expected output should be string because the input function converts anything to a string. Now let's run the program. Enter your score. I'm going to enter 90 again, then press enter on the keyboard. Despite entering a number, the returned value is a string. The next step is to check if the user enters a positive whole number. This can be done by using the isDigitString method in Python. This method returns true if all the characters in a string are digits. If user score input dot isDigit print valid number, else print invalid number. The isDigitString method returns true if all the characters in the string are positive whole numbers. Otherwise, it returns false. Now let's run the program again to see the progress. Enter your score. If I enter P, which is actually not a number, we are getting invalid number. So let's run the program again by imputing a valid whole number. Press enter on the keyboard. Great, this is a valid number. The next thing to do is to take the user score, which is a string, and turn it into a number. This is important because we want to do some math with it. I'm just going to declare a new variable score equals float because I want to convert user score inputs to a float number. Then after this line, I'm going to check where the score falls. If score is greater than or equals to 90, grade, which is a new variable, equals A. We can make use of elif because we want to do some further check. Elif score greater than or equals to 80, grade should be equals to B. Elif score greater than or equal to 70, grade should be C. Grade equals C. Elif score greater than or equals to 60, grade should be equals to D. Else, that is, none of the conditions is true, grade equals F. After all the checks, what we want to do is to print out a message to the user, a string. Your score is the score, which is the variable we declared up here. Your grade, the grade. Alright, I'm going to briefly explain this line of code again. The first part is to print out a welcome message to the user. After that, we collect an input from the user, and the input collected is saved in another variable. The next part of the code is to check if the value provided by the user is a digit, and that is why we are using the string isDigit method. Remember, anything entered by the user is a string because the input function returns a string. This isDigit method is either going to return true or false. If all the characters in the strings are numbers, then this block of code will be considered. If you've noticed, there is another if statement inside the original if statement. This is known as nested if statement. On this line of code, we are converting the original score, which is a string, to a number because we want to do some math. After that, we are checking the score, which is a variable we declared here, against some set of values. If score is greater than or equals to 90, this line of code will be executed. If this is not true, then another check will be done, and so on. If all the conditions are not true, then F will be assigned to grade. The next line after the else block is print statement, which is printing to the terminal the score of the user and the grade. Once a block is executed, control is returned to the line immediately after the check, which is this line. In this case, this line won't be executed. That means the next line that will run in the program is this line on line 22. Print end of the program. Let's execute the program. Enter your score. I'm going to press 80. Your score is 80. Your grade is B. End of program. Let's execute the program again while using an invalid number, IO. Press enter on the keyboard. Invalid number, end of the program. If we enter a decimal value such as 22.4, the isDigit method won't regard it as a number because of the dots. To handle such cases, we can improve this solution by using a try and catch approach, which we haven't covered yet. For those curious about how this could be done, please check the description section of the video. The ternary operator is a simple way to make decisions in Python. It takes a condition. If the condition is true, it returns the value on the left hand side. Otherwise, it returns the value on the right hand side. Let's try out an example. Age equals 10. X equals, if age is greater than 10. This is the condition. If age is greater than 10, this should be returned, which is the value on the left hand side, old. Else, this should be returned, which is young. Now, Let's print x. So the question is 10 greater than 10. The answer is false. This means this part of the code will be returned. Let's execute the program. Great, the answer is young. Now let's try to use 15. You cannot say 15 greater than 10. Yes, the answer is true. That means this part of the code will be returned. So the expected output is old. Let's run the program again and see the output. Great. This is particularly useful when you need to choose between two values based on a condition without writing a full if-else block. That's all for now. Thanks for watching and see you in the next video. What's going on, friends? If you are familiar with programming languages like JavaScript and Java, you might have encountered the switch case keyword before. It looks similar to this. We declare a variable called day and use the switch keyword to check different cases. For example, if the day is Sunday, this corresponding block of code is executed. Then we break out of the switch. If no match is found, the default block is executed. Fortunately, the switch case concept has been recently introduced in Python 3.10 and it is more powerful and flexible than you might think. Python refers to it as match case. Join me in this lesson as we explore the capabilities of this awesome feature. Without further delay, let's get started. Alright friends, the match statement evaluates the value after the match keyword and checks it against a pattern. A pattern is the code next to the case keyword. If the status is 400, then this block of code is executed. If it is 401, this block of code is executed. There is no need for the break keyword. The default block is represented by an underscore. This is similar to the else keyword when using if statements. If no match is found, then this block of code is executed. Let's declare a variable called day, which is a string data type. We bring in the match keyword, followed by the variable we want to match. Then comes the case keyword. If the day is Monday, this inner block of code will be executed. You can write as many lines as needed in the inner block. Another case we would like to try is Sunday. If it is Sunday, this inner block of code will be executed. Case Friday. This inner block of code will be executed. We want to provide the default block if there is no match. Print no match found. So now let's try to execute the program. The expected result is Monday because the variable matches Monday. Let's execute the program and see the output. The output is Monday. If you try to use Friday, the output should be Friday. Great. Let's update the variable value to OP. Of course, there won't be any match for this. This means this part of the code will be executed. This is similar to the else block when dealing with if statements. Let's run the program and see the output. Great, no match found. There is a string data type. We can use any other data type such as number and Boolean. The if-else version looks like this. The match case version is cleaner. Sometimes we need to handle multiple cases in a single block. The pipe symbol can be used to match multiple values. For instance, we can decide to combine 401 and 403 in a single block. We just need to make use of the pipe symbol 403. Then we remove this other part, authentication error. This means both 401 and 403 will be captured by this case. Let's try to use 401. Run the program and see the output. Great, the output is authentication error. If we also change it to 403, the output will be authentication error. Let's run the program again. Great, we can use the pipe symbol to combine as many values as needed. In addition to matching variables like strings, numbers, and booleans, the match case statement also enables you to match specific data structures such as lists, tuples, and dictionaries. I have declared a variable here which is a list data type. Match the variable we want to match items. Case A, B. Point two items are present. Point F string A is A and B is B. Another case to consider: A. Point one item is present. Point A is. Now let's move on to define the default case. Point no match found. The first case is designed to match a collection, whether it is a list or a tuple, containing two items. The variables A and B serve as references to these items. you have the flexibility to use any other variable names of your choice. A refers to the first item, while B refers to the second item. If there is a match, this inner block of code is executed. We are making use of the variable A and B in this line of code. The second case is designed to match a list or tuple containing just one item. A serves as a reference to the item, and it is used in this line. If no match exists, then the default block is executed, which is this line of code. When we execute this program, this block of code is executed because it matches a list or a tuple containing two items. Let's run the program to see the output. Great. The output is two items are present. A is 1 and B is 2. Now let's update items to contain just one item, 1. The expected output is this block of code because only one item is present in the collection. Now let's run the program again. Great. One item is present. A is 1. If there is no match, this block of code is executed. Let's execute the program and see the result. No match found. To match an empty list or tuple, we can provide another case. Case empty list or tuple print no item in the collection. So now let's try to run the program. The expected output is no item in the collection because this is going to match an empty list or tuple. Let's run the program to see the results. No item in the collection. That means this part of the code is executed. We can also match for specific values within a collection. Let's modify one of the variables to be a string. Array. We also need to update the print statement because variable A is no longer available. This case will match a collection where the first item is array, which is a string data type, and the second item can be any value. The value of the second item is captured in the variable B. Let's modify the contents of the items to be array. The expected output is 2 items are present, B is 2. Let's run the program to see the output. Great, 2 items are present, B is 2. Any other string which is not array is not going to match. Let's run the program. The expected output is no match found. Great, no match found. So far, we've been matching lists and tuples. In this one, we are going to use a dictionary. Match information case, the first case, age, name, point, f string, and name is name. Let's also provide a default case, print no match found. The first case involves matching a dictionary where name and age are present as keys. The values are captured as age and name. You can use any variable names of your choice. There will still be a match if extra keys are present in the dictionary. For now, if we try to execute the program, the output will be not found because name is present in the dictionary but age is not present. Let's run the program to see the output. Great, no match found. So now let's try to update the dictionary to include age as well. Age 10. This block of code will be executed because there is a match for this dictionary. Age can be found in the dictionary and name can also be found in the dictionary. The order of items in a dictionary does not matter. So let's run the program again and see the output. Great, age is 10 and name is Ray. We can also match for specific values in a dictionary. Let's try that out. Age is 9, name is Ray. This is going to match a dictionary where the value of the age is 9 and the value of the name is Ray. For now, if we try to execute this program, the output will be not found because age is 9 but name starts with uppercase. Meanwhile, it is lowercase here. Let's run the program and see the output. Great, not found. We need to update the value of name for it to be able to match. Let's run the program again. Great, age is 9 and name is Ray. The rest of the items in a dictionary can be captured using double asterisks. Let's try that out. Age is 9 and the rest of the items can be captured in a new variable. Let's call it rest. This is going to match a dictionary where age is present as a key. All other keys and values are captured in rest. We can then access the items by using the keys print, rest, name, print, rest. This is how we can access items in a dictionary. So now let's run the program. Ray and 10. There's no need for this bracket. Let's execute the program again. Ray and 10. Specifying a key that does not exist can lead to key error. Let's say contact. This is going to raise a key error because contact key cannot be found in the rest. Let's run the program and see the output. Key error, contact. Conditional matching allows us to perform additional checks before executing a block of code. Let's declare a variable called status. Status equals 5. Match status case x. If x greater than 0, print positive number. Case x. If x less than 0, print negative number. Case, the default case, print 0. In the first case, we want to match for x and verify if a condition is met before executing this inner block of code. X is just referring to the matched value. In the second case, if x is less than 0, then this block of code is executed. If no match is found, then the default case, which is this line of code, is executed. Let's run the program now and see the output. Positive number. Let's update the status to be a negative number, -1. Let's run the program again and see the output. Negative number, -1. So now, if we use 0, these two cases are not going to match. So let's run the program again. The expected output is 0. Great. You need to be extra careful when using conditional statement. For instance, if I change the status to be a string, let's run the program and see the output. Type error, greater than not supported between instances of string and integer. This error is because x is captured as a string and we are now trying to perform math between a string and a number. This is not going to work. The fix for this will be shown when dealing with type matching. Let's try out one more example. Item, which is a list data type, 1, 2. Match, item, case, x, y. If x plus y greater than 4, print sum is greater than 4. Another case, if x plus y less than 4, print sum is below 4. The first case is going to match a list or a tuple containing 2 items. But before we move on to execute this inner block of code, we want to do some further checks. If x plus y is greater than 4, then this block of code should be executed. Remember, x is pointing to the first item in the list, while b is pointing to the second item. If this case is not matched, then we want to try another case, which is this case. If x plus y is less than 4, then this inner block of code should be executed. Sum is below 4. Let's run the program and see the output. 2 plus 1 is 3. 3 is below 4. Let's run the program. Sum is below 4. Let's update the items in the list. 5. 6 is greater than 4. So the output will be sum is greater than 4. Let's run the program. Sum is greater than 4. Sub-pattern match involves matching a pattern inside a pattern. Let's try out an example to understand this. Route equals go east. Match route. Case go east or west or south or north. Print go to the direction. The default case, print no match. What we have here is a pattern, a list or a tuple. The first item is expected to be go and the second item is a pattern. This is going to match any of these items as specified by the pipe symbol. So now let's run the program to see the output. Go to the direction. Let's update the list. West. Execute the program again. Great. Go to the direction. The question here is, how can we get the specific value matched? The as keyword in Python can be used for this purpose. We just need to say this second item as direction or any other variable we want to use. Let's update the print statement to capture the direction. So now let's run the program. The output should be go to the west. Great. So I'm going to update this to be east. Execute the program again. Go to the east. The match case statement supports matching the type of a specified value. Here is an example. X equals 5. Match x. Case string x. Print x is a string. Case int integer. Print x is an integer. Alright, This case ensures that when x is matched, it is a string data type, and if it is an integer, this part of the code is executed. Let's execute the program to see the output. X is an integer. This block of code is executed because x is an integer. Let's update x to be a string data type h. Let's run the program again and see the output. Great, x is a string. Let's use one of the previous examples to show a practical usage of this. Let's change the second item in the list to be a string. So now let's run the program and see what happens. Python throws a type error. Unsupported operand types for plus, int, and string. In this line of code, we are trying to perform an addition between an integer and a string. That is why Python raised a type error. To ensure that the matched items are of a specific data type, we can use type matching. The first item should be an integer, and the second item should also be an integer. If they are not integers, there won't be a match, int. Let's provide a default case, print, no match. So now let's run the program and see the output. Great, no match. This means the two items present are not integers. This is particularly useful in order to avoid any kind of error in the program. Let's change the second item to be 9. So now the program should run fine. 9 plus 1, 10. 10 is greater than 4. We haven't mentioned how we can capture a set data type. The type matching can be used for this purpose. We just need to define another case set of x. Print x is a set type of x. Let's update this variable to be a set data type. Now let's run the program again and see the output. X is a set. Alright friends, let's recap what we have learned in the lesson. The first match is a constant match. This is going to match a string, number, or a Boolean data type. The second case is going to match a list or a tuple containing two items. The first item must be string A and the second item must be string B. For this one, it matches a sequence containing exactly two items. The two items can then be referenced as variable A and B in the block. This is going to match a list or a tuple containing two items. But the first item must be string A. The second item can be any other value. This is going to match a list or a tuple containing at least one item. The first item is referenced as A, while the rest are referenced as B. The pipe operator signifies OR. It means any of these values is going to match. We also have a conditional matching, which is used to do any further check. This is going to match a dictionary where name and age are present as keys in the dictionary. An underscore is referred to as a default case. This case is similar to the else keyword when using if statements. This matches a list or a tuple containing two items, but the values of the two items cannot be used in the block. That is why they are represented as underscore. To use the values in the inner block, we can make use of any other variable names. This will match a list or a tuple containing two items, but the first item must be a string and the second item must be an integer. If you missed the previous lessons, make sure to catch up on them. Thanks for watching and see you in the next video. What's going on friends? In this video, I will break down all you need to know about functions in Python. Up until now, we've used functions like print and input to display text and collect information from a user. These functions are called built-in functions because they are defined in Python by default, making them available for use. A function performs a specific task, such as calculating the length of items in a list. One of the benefits of functions is that they are reusable. For example, you can call the print function as many times as needed. Stick around until the end, as we are not just learning but also applying our knowledge by building a practical Python project that takes all the scores of a student and determines the grade. Alright friends, the first thing we want to do is to write our own custom functions. This is known as function definition. Once we've created our own functions, we will move on to using them, a step commonly referred to as calling a function. Next up, we will explore the distinction between function parameters and arguments. We will also touch upon optional parameters, the return keyword, the pass keyword, docstrings, and finally, to solidify our understanding, we are going to complete a project exercise. Without further delay, let's get started. To create a function, we use the def keyword followed by the function name, parentheses, and a colon. The inner part of the code is the function body. The function body is the indented block of code below the function name. It contains statements, logic, and the functionality that you want the function to perform. Let's create our very first function that greets a user. We need to bring in the def keyword, def, then the function name, greet, parenthesis, a colon. Then we press enter. Print, welcome. Print, how are you? All the instructions needed for a function to perform its task are enclosed within the function body. Now we've been able to define a function, and the next step is to make use of this function. To use a function, we need to call it by its name. The name of the function is greet. We just need to mention the name of the function, which is greet, followed by parentheses. That's all. When we call a function, the function body is automatically executed. The body represents what the function does. Let's run the program and see the output. Great, welcome, how are you? As you can see on the terminal, the function body is automatically executed when the function is called. One advantage of defining a function is that we can call it any number of times. For instance, we can decide to call this greet function again. We just need to call it again. I'm going to bring up the terminal. So now let's execute the program again. Great, the function body was executed twice because we called the function twice. This is similar to how we've been using the built-in print function. Print. As you can see, they look similar. The only difference is that Python has defined the print function, so we just need to use it without declaring it. One point to keep in mind is that a function must be defined before it is called. Function definition comes before function call. We are able to make use of this greet function because we have defined it up here. Now let's reverse the approach whereby a function call comes before a function definition. The code editor is already showing us a warning before we run the program. Greet is not defined. If we run this program, Python is going to throw an error because a function definition must come before a function call. Now let's run the program and see the output. Name error. Name greet is not defined. On line 5, which is this line of code. To make this to work, we need to bring down the function call below the function definition. Whenever you define a function, you are allowed to put a placeholder that would be passed when the function is called. The placeholder you put in between parentheses are called parameters, and you can actually make use of those parameters in the function body. As you can see, the greet function is now customized to say the name of the person. The actual values sent or passed when we call the function are called arguments. Let's write a function that calculates the sum of two numbers. Let's define the function def. The name of the function should be descriptive enough, sum underscore numbers. The first parameter should be n1, which is the first number. The second parameter should be n2, which is the second number. The body of the function result, which is a variable, equals n1 plus n2. Point sum of the two numbers is result. We've been able to define a function which is sum underscore numbers. It requires two parameters, n1 and n2. In the body of the function, we summed the two parameters n1 and n2. After that, we print out the result to the terminal. Now it is time to call the function. We just need to say sum underscore numbers, which is the name of the function. Then we pass in the arguments. This function requires two arguments. As you can see, the code editor says add two missing arguments. Sum underscore numbers expects two positional arguments. So let's pass the actual values 10, 40. This is how we are going to call the function. The name of the function followed by parentheses. Then we pass in any arguments that is required. Let's run the program and see the output. Sum of the two numbers is 50. Let's try it out again. 50. Let's run the program again and see the output. Great. Sum of the two numbers is 90. This is one of the benefits of writing a function. You can use it as many times as needed to perform a specific task. For instance, this sum number is only adding two numbers together and giving us the results. The greet function takes two parameters, name and age. As a result, two arguments must be passed when the function is called. Arguments passed as comma-separated values are called positional arguments. This means the first argument maps to the first parameter, the second argument to the second parameter, and so on. Now let's change the order to see what happens. Let's execute the program again. Your name is 10 and your age is Ali. The function may even still work, but it is very unlikely to produce the correct results. This is because we are using positional arguments, meaning the first argument is mapping to the first parameter and the second argument is mapping to the second parameter. In this case, this 10 is referring to name and this Ali is referring to the age. This is where keyword arguments come in handy. We don't need to worry about the order of the passed arguments. When you are calling a function, you can specify arguments in the form of age equals 10, name equals Ali. Arguments specified in this format are called keyword arguments. It means you have to specify the name of the parameter and the value, the name of the parameter and the value. Each keyword must match a parameter in the function definition. This is a keyword, which is age. It is mapping to age in the function definition. This is another keyword, which is name. It's matching a parameter in the function definition. Now let's run the program again and see the output. Great, your name is Ali and your age is 10. The program still works fine if we change the order, because the order does not really matter. Let's run the program again and see the output. Your name is Ali and your age is 10. Using a keyword that is not present as function parameter throws an error. Let's try that out. Let's pass in a keyword that is not present. Level equals 5. The code editor shows a warning before we even run the program. Remove these unexpected named arguments. Level should not be included because it is not present as a parameter in the function definition. Let's run the program and see the output. Type error. Greet function got an unexpected keyword argument level. You should also remember that the number of arguments must be equal to the number of the parameters. We are also allowed to mix positional argument and keyword argument in a single function call. Let's remove this keyword argument, making it positional argument. This string is positional argument while this one is keyword argument. This maps to the first, while age, which is keyword argument, maps to the age in the parameter. All positional arguments must come before keyword arguments. So let's run the program and see the output. Great, your name is Ali and your age is 10. Let's change the order by writing this way. This is not going to work. The rule is that positional arguments must come before keyword arguments. Let's run the program and see the output. Syntax error. Positional argument follows keyword arguments. In Python, if you set a value like this in function definition, it becomes the default for that parameter. This is called default or optional parameter. It means if you don't provide a value when calling the function, it uses the default one you set. If we move on to call this function without specifying the age, it is going to rely on this default one, which is 10. This is a mistake. Age is meant to be an integer. If we call this function without providing the age, it is going to work because we have provided a default value. Let's run the program and see the output. Great, your name is Ali and your age is 10. Now let's provide a value for the age, 20. In this case, it is not going to rely on the default value. Your name is Ali and your age is 20. We can also provide a default value for name. In that case, I can decide to remove the arguments passed. Let's run the program and see the output. This function call works because we have default values. The return keyword is an optional statement in the body of a function. If we want our function to return some values to a function call, we use the return statement. Let's use one of the previous examples. When a function is called, all the code in the function body is executed. If a return statement is encountered inside the function body, the execution stops and the control of the program is returned to the caller. Let's modify this function to return a value, which is the result, return result. Let's call this function sum numbers 5, 4, x equals some numbers. This function has been designed to return a value. When the function is called, a value is returned back to us. That value is now what we save in this new variable x. Let's give the variable a better name, summation. We can now move on to use the variable however we want. Print sum of numbers is summation. Let's run the program and see the output. Great, sum of the numbers is 9. A return statement in a Python function serves two purposes. First, it terminates the function and passes execution control back to the caller. It also lets the function send data back to the caller. The data returned or sent by the function is saved in this new variable. The pass statement is a statement which can be used as a placeholder for future code. For instance, if you declare a function without the function body, Python receives a syntax error stating that you must provide a body. Let's declare a function without a body, add numbers. So if we try to actually run the program, Python is going to throw an error because you must provide the function body. But sometimes we just want to come back to this part of the code. In that case, we can use pass. Let's run the program again. The pass statement does not really do anything. It only prevents Python from throwing a syntax error. We can also make use of pass in if statements. Let's say if 5 is greater than 6. Let's run this program and see what happens. It shows an error that the inner block of code cannot be empty. We can simply use pass. This block of code is going to run fine now. Great. Docstrings are string literals that appear right after the definition of a function, method, class, or module. A function docstring is like a note that explains what the function does, its arguments, its return value, and any other helpful details. We can access the documentation of a function by using the doc attribute. We just need to say function name dot double underscore docs. Let's print this out to the terminal. Print. Now let's execute the program. Great. Built-in functions also have docstring. Let's try that out. Print, which is the built-in function, dot docs. So now let's execute the program and see the output. Great. As you can see, it is showing us the parameters that can be passed to the print function. Value, print the values to a string. The docstring does not always need to be a single line. You can use multiple lines if needed. Let's take a look at this example. This function calculates the area of a rectangle. As you can see, we have the parameters mentioned in the documentation as well as the return values. Alright friends, the task is to create a project that takes student scores and computes the corresponding grades. The first thing we need to do is to create a function that calculates average score. We also need another function that determines the grade. Let's create the first function that calculates the average score. Def calculate average scores. This function takes scores as the parameter. The score is a list of numbers, then the body of the function. If not scores, that is when the score is an empty list, we want to return 0.0. Be sure to check out the lesson on if statements for a more detailed explanation on when a variable evaluates to false. We want to define a new variable total equals sum, which is a built-in function, scores. The sum built-in function is going to sum all the scores together, that is all the numbers. Then we want to define a new variable average equals total divided by the length function returns the length or the number of items in a list. And finally, we need to return the average score. This function is going to take a list of numbers as scores and compute the average. This part of the code is needed because if the list is an empty list, the length of the list would be 0 and any division by 0 is going to raise an error. Let's move on to define the second function. This function determines the grade given an average score. The function name is determine grade. Then we pass in the parameter. The parameter needed is the average score. If average score is greater than or equal to 90, then this part of the code should be executed. Return. We want to return string A. which is the grade. If average score is greater than or equal to 80, return B, which is the grade. If average score is greater than or equal to 70, return C. If average score is greater than or equal to 60, return D. Else, if none of the conditions is true, return F as the grade. The first function is to calculate the average score, and the second function, which is determine grade, is to compute the grade based on the average score. Let's make use of the two functions. Average score value which is a new variable equals calculates average. Then we pass in a list of numbers 1, 2, 6. Let's declare a new variable called grade value equals determine grade. Then we pass in the average score value. Alright, on this line we are computing the average score by making use of the calculate average function. The calculate average function returns a value, and the value returned is saved in this new variable. On this line we are computing the grade. We are passing the average score as an argument to this function, which is the determine grade. This determine grade returns the grade. So now let's print out the grade value. Print grade is grade value. Let's execute the program and see what happens. Great, your grade is F. Let's use 90, 80. Hopefully the grade should be B or A. Great, your grade is B. Let's pass an empty list as the argument and see what happens. Your grade is F. Now let me show you the purpose of this part of the code, if the list is empty or not. Let's run the program and see what happens. 0 division error, division by 0. Remember, when the list is an empty list, the length of scores is going to be 0. So the total divided by 0 is going to raise a division by 0 error. Here are some questions you can try on your own. Write a function that takes a list of numbers as parameter and returns the highest value. Write a function named isEven to determine whether a given number is even. Create a function named Celsius to Fahrenheit that converts a temperature from Celsius to Fahrenheit. Create a function called isPalindrome that checks if a given string is palindrome. I hope you enjoyed the video. Feel free to let me know in the comments if you have any questions. Please like and subscribe to the channel. Thanks for watching and see you in the next video. One of the things I struggled to understand and apply while learning Python as a beginner is the use of star and double star in functions. They are used in two different scenarios: function calls and function definitions, args and kwargs. In this video, we are going to simplify these two syntaxes and provide you with different use cases from a real project. Without further delay, let's dive in. Whenever you come across star args in a function definition, it simply means that any number of positional arguments sent in a function call should be captured as args. If we check the type of args, we see that it is a tuple. Let's try to print out the type of args. Print type args. Let's run the program and see the output. Great. As we can see, the type of args is a tuple, and we can easily retrieve tuple items by using the index number. Index of 0 is referring to the first item, args. Index of 1 is referring to the second item. Let's print out the values to the terminal. Print. Now let's execute the program to see the output. Great. As you can see, we have been able to access the tuple items by using the index number. You should also note that using an index value that is not present can lead to an index error. Let's use index of 2 and see the output. Let's run the program again. This shows index error because two items, Ray and 10, are present in args. You make use of these *args in your code when you are not really sure about the number of positional arguments that will be sent when the function is called. Let's revisit the SUMNumbers function we used in the previous lesson. Let's comment out this part of the code. This function implementation only caters to 2 arguments because 2 parameters are listed in the function definition. Calling this function with more than 2 arguments will throw an error because only 2 arguments are expected. Let's add another argument to see what happens. 5. Now let's execute the program and see the output. Python throws a type error. SUM_numbers function takes 2 positional arguments, but 3 were given. As a matter of fact, the code editor is already showing us a warning. Remove 1 unexpected argument. Remember, we mentioned that the number of arguments must be the same as the number of parameters. Arguments are the actual values passed to the function call. So we need to update the function definition to accept 3 arguments. Let's call it n3, which is the 3rd number. Sum of the 3 numbers is the result. What happens if we now decide to sum 4 numbers together? We would have to keep updating the function definition, which can be challenging and may not make the code very flexible. The solution here is to use *args because you are uncertain about the number of positional arguments that will be sent in the function call. Or you simply want to capture all the positional arguments at once without having to list them one by one in the function definition. Now let's replace all these parameters with *args. You can decide to use any other name, but the convention in the Python community is to use args, which stands for arguments. The positional arguments are now captured into these args as a tuple. For now, let's print out the value of args. Print args. Let's run the program and see the output. As you can see, all the positional arguments are now captured as a tuple. The next step is to sum all the numbers together. We can use the built-in sum function to achieve this sum. Then we pass in the positional arguments, which is a tuple args. The sum function takes an iterable such as a list or a tuple and returns the sum. That means we don't have a limitation on the number of values that can be passed to the function call. Now let's run the program and see the output. Great, sum of the numbers is 55. We can pass as many positional arguments as we want. 90, 150. The length does not really matter. Now let's run the program again and see the output. Great, sum of the numbers is 295. This code is more flexible than the previous one. Let me show you another example. This is a code snippet taken from a Django codebase, a Python framework used for building web applications. It means the first 2 parameters are required and any other positional arguments are captured in args as a tuple. The double kwargs is similar to kwargs. Keyword arguments sent from a function call are packed into a dictionary and captured as kwargs. This is particularly useful when you do not want to restrict the function to specific keyword arguments. You use it to accept arbitrary arguments to be passed in the function call. Let's check the type of kwargs by using the print function print type kwargs. Let's run the program and see the output. As you can see, this is a dictionary, a Dict data type. Now let's move on to see the captured value for kwargs. Let's execute the program again. Great. As you can see, the keyword arguments are now captured as a dictionary in kwargs. In the function body, we can decide to pick the data we need from kwargs. Remember, kwargs is a dictionary, which means we can access the items by using the keys. We need to mention any key present. Let's print out the result. We are able to access the value of the key. If the key is not present, it throws a key error. That's why you may want to use .get method. We can mutate the original data present in the dictionary because dictionaries are mutable. Keyword args name equals a new name, Alish. Let's print out the name. This line of code is going to update the value of name in the dictionary. The expected result now is Ali because we've updated the dictionary. Let's run the program. Great, Ali. Let's take a look at this snippet from a Django project. This function, as implied by its name, saves a notification object into the database and sends the content of the notification to a user's email. The presence of double asterisk kwargs in the function definition indicates that this function can be called with any number of keyword arguments. As a matter of fact, we can call this function without passing any keyword arguments. In such case, kwargs would be an empty dictionary. The keyword arguments from a function call are captured as a dictionary and assigned to the parameter kwargs. In the function body, we are updating the content of the dictionary. That is, the value of this key in the dictionary user should be this value. This one is just because I did not import user. This part of the code is an ORM operation. We are querying a specific user from the database using the ID coming from kwargs. After that, we save the notification into the database using ORM. And finally, we send a message to the user. I hope this makes sense. You use *args and *kwargs a lot when you have to override methods from a library. When you have a function that looks like this, the first positional argument is required. The required here is just a name. You can use any other name. All other positional arguments are collected into args as a tuple, while keyword arguments are collected into kwargs as a dictionary. Putting a star before an iterable, such as a list or a tuple in a function call, means that the elements of the iterable should be passed as separate positional arguments in the function call. So this part of the code is equivalent to saying sum_numbers. Then each element of the iterable has separate positional argument 50, 40. This is called argument unpacking. That is, you are unpacking the items you have here and passing them individually here. I hope that makes sense. Let's print out the summation of the scores. Print total. Let's execute the program and see the output. Great, the sum of the numbers is 110. We can include as many numbers as needed. Let's execute the program again. Great. My favorite is the dictionary form, which uses double star. Let's try out an example. Whenever you see double star and a variable in a function call, it means that this dictionary should be passed as keyword arguments, that is, key value pairs into the function call. This is equivalent to notification logger, the user key in the dictionary, and the value should be this. Another key in the dictionary, which is type, equals password change, and finally content, which is a key in the dictionary. The value should be this. Your password was successfully changed. This means you are simply unpacking the items in the dictionary and passing them as keyword arguments into the function call. I hope you now understand *args and *kwargs. You should definitely explore these tips because they offer a lot of flexibility. If you liked this video, be sure to subscribe to the channel. Happy Pythoning! Thanks for watching. What's going on, friends? In the previous lesson, the def keyword was used to define a function. A lambda function is a special type of function without a function name. Here is the structure of a lambda function. The lambda keyword is used, followed by the parameters. The section following the colon is similar to the body of a function. It is executed when the function is called. The result of this expression is automatically returned to the caller of the function. But why would you want to use a lambda function? You use it when you want to pass a function as an argument to another function. You also use it when you need a disposable function to be used for a short period. All of these possibilities exist because functions are first-class citizens in Python. We are going to explain what this means. By the end of this video, you will have a solid understanding of the lambda function with different use cases. Without further delay, let's get started. To create a lambda function, we need to bring in the lambda keyword, followed by the parameters. For now, let's leave out the parameters, a colon, then the expression, print, hey, lambda. This part of the code is what gets executed when the lambda function is called. Now that we've defined a lambda function, how do we call it since it doesn't have a name? This is where the concept of functions in Python being first-class citizens comes in place. It means that functions are similar to any other objects and can be passed around. So it is possible to write x equals the lambda function. To call the function, we use the variable name, in this case x, followed by the parentheses used when calling a function. So this is how we can call the lambda function. Let's run the program and see what happens. Great, this part of the code after the colon is automatically executed. This is similar to the function body and it is automatically returned to the caller. Let me show you an example to illustrate this concept using a regular function. Let's define a function named greet. Def greet. The function body print. We need another function. Let's name it say hi. Def say underscore hi. This function takes a parameter and the parameter is a function. Let's name it func. Let's call the function in the function body. Now the next step is to call the function say hi. Say underscore hi. To call this function, we need to pass an argument because a single parameter is listed in the function definition. So we are going to pass greet, which is a function. We are able to pass greet, which is a function, into another function because functions in Python are first-class citizens, which means they can be passed around just like variables. This greet function is captured as func here. So in the function body, we are calling the passed argument, which is a function. Let's execute the program and see what happens. Great. Let's see another way to call a lambda function. We can call a lambda function by surrounding the function and its arguments with parentheses. Let's surround this function with parentheses, then another parenthesis. Arguments to be passed can be put here, but for now we don't have any arguments. So let's run the program and see the output. We got the same result. Parameters used in lambda function come immediately after the lambda keyword. We can then make use of the parameter in the expression. Let's assign this lambda function to a variable so that we can call it greet. Now let's call the function greet. Let's execute the program. Oh, I forgot to pass the argument ray. Let's run the program again and see the output. Hi ray. This is how we can mention a parameter in the lambda function and make use of it in the expression. We can also use more than one parameter h. Let's make use of the parameter in the expression f-strings. Name is the name and age is age. We are making use of f-strings here. Before we run the program, let's update the function call to take two arguments. Now let's execute the program and see the output. Name is Ray and age is 9. This is how we can use multiple parameters and multiple arguments with a lambda function. Multiple arguments can be passed to a lambda function, but only a single expression is allowed. That means we cannot use multiple lines of code in the expression. A lambda function cannot replace a regular function which has loops and multiple conditional statements in its definition. For instance, it is not possible to use if-elif-else in a lambda function because this requires multiple lines of code. A lambda function can take any number of positional parameters by using an asterisk before a parameter name. Let's define a new lambda function, lambda star x sum x. Let's assign the function to a new variable, summation. Now let's call the function summation. All the positional arguments are captured as a tuple. Be sure to check the previous lesson where we explained star args and double star kwargs in functions. Let's pass in some numbers as argument 5, 7, 9. Now let's print out the result to the terminal. Print. Let's execute the program. The output shows the summation of the numbers. The map function in Python takes a function and an iterable such as lists, tuples, or strings as arguments. The function passed to map is then called with all the items in the iterable. The map function returns an iterator containing the results. Let's try out an example. Numbers equals a list of numbers 1, 2, 3, 4, 5. Now let's make use of the map function map. The map function takes a function as its first argument. Here we are going to use a lambda function, lambda x times x. This is the function needed by the map function. Next is to pass the iterable such as a list, numbers. This function will be called for each item in numbers. Each number in numbers is referring to x. For each x, this other part of the code will be executed. This is similar to the function body. This lambda function is simply returning the square of each of the numbers. The returned value from map can now be assigned to a new variable, result equals map. result is an iterator containing the squared values. Let's print out the result. Print list of results. We are using the list function because we want to convert the returned value of map to a list. Now let's run the program and see the output. So this is how we are able to get the square of each of the numbers. This function is called on each of the numbers. We've only used a lambda function here. You can decide to use a regular function. Just ensure the function returns what you need. Let me declare a regular function to show you that we can use a regular function. Def square, it takes a parameter and it returns the square of a number. I'm going to comment out this line of code. Now we are going to use a regular function here. Let's run the program again and see the output. As you can see, we get the same result. All these are possible because functions in Python are first-class citizens, which means they can be passed around. For instance, here we are passing a function as an argument to another function. Similar to the map function, the filter function takes a function and an iterable as arguments. The filter function is primarily used when you need to extract items that satisfy a given condition from a dataset. Let's write a program that filters out only numbers that are greater than 3. My list, which is a list of numbers, 1, 5, 6, 8, 11. Result, which is a new variable, equals filter, the filter function. Then we need to write a function which determines whether an item should be returned or not. Lambda, we are going to use a lambda function. X greater than 3. Then let's pass the list, my list. Print list of results. This function, which is an argument, is applied to each element of the iterable one by one. And if the output is true, the element is selected by filter. X, which is a number in the list, is either going to return true or false. 1 greater than 3, the answer is false. So 1 is not going to be included. 4 greater than 3, the answer is true. So this function is called for each of the items in the list. Let's run the program to see the output. We have been able to filter out numbers greater than 3. So far, we have successfully employed the lambda function to accomplish various tasks. One thing about programming is the availability of multiple approaches to achieve the same task. Several examples that were completed using a combination of the lambda function and higher order functions like map and filter can also be achieved using list comprehension. These are some of the practice questions you can use to test your understanding. Let me know if you have any questions in the comment section. What's going on, friends? Scope defines how variables are accessed or searched within your code. You might have come across this kind of error before in your code. It says age is not defined. This means the variable age was searched but could not be found. Python follows the LEGB rule when looking up variables. In this lesson, we will cover everything you need to know about scope to avoid writing code that produces unexpected results. Without further delay, let's dive in. When Python is searching for a variable, it follows the LEGB rule. It looks for the variable in this order. If the variable is found here, the search stops. Otherwise, it moves on to search for it in the immediate following scope. If no match is found for the variable, Python raises a name error, indicating that the variable is not defined. A variable declared inside a function is accessible only inside the function. This means it is only visible in the function body. Let's take a look at this function. A variable named var_a is declared inside the function body. We are making use of this variable in this print statement. Variables defined inside a function are said to have a local scope. When Python is looking for the variable var_a, it first checks the local scope according to the LEGB rule. Let's run the program to see the output. Now let's try to access the variable var_a from outside the function. Print value of var_a. Let's execute the program to see the output. Python raises an error. Name var_a is not defined. A variable defined inside a function can only be accessed inside the function. Pylance, which is the extension I'm using, is already showing a warning. var_a is not defined. A nested function is a function which is found in another function. This inner function is a nested function because it lives inside another function. Any variable declared inside the outer function is not only accessible to the outer function but also accessible to the inner function. The scope here is local to the outer function and serves as an enclosing scope for the inner function. Let's put a comment here: enclosing scope for inner function. Enclosing scope in the sense that this function body is the host for this function. So now let's call this inner function inside outer function. Inner function, outer function call. When the outer function is called, everything within its body is automatically executed, including the call to the inner function. Let's run the program. The output shows that the inner function is able to access a variable declared in the outer function. When Python is looking for this variable, the first place it checks is this local scope, which is the inner function body. If it is not found here, it goes to the enclosing scope, which is the function body hosting this inner function. If it is not found here, it moves to the global scope. Let's consider another version of a nested function. Let's call the outer function. Can you take a moment to think about what would be the output? A variable declared inside outer function can be accessed within this block due to local scope. Additionally, any variable declared within this block is only accessible within this block. Can we access age from here? Well, age is local to inner function, and as a result, it can only be accessed inside inner function. The extension is already showing a warning. Let's run the program to see the output. Name error. Name age is not defined on line 25, which is this line. A variable is said to have a global scope if it is defined outside of any function. You can access the value of any global name from any place in your code. This includes functions and classes. Now let's call the showName function showName. Let's also call the show method inside test show. Let's run the program to see the output. Great, a global variable is accessible from any place in your code. Let's try out another example. When Python is looking for this variable, it first checks the local scope of inner function. If not found, it moves up to the enclosing scope of inner function. If it is not found here, it moves to the global scope. Let's run the program to see the output. The output is 9. Let's define another variable age in the enclosing scope equals 6. The expected output here is 6 because age is found in the enclosing scope. Let's run the program again. Great. If age were not found in the global scope, Python would proceed to the built-in scope, and if it is not found there, it would result in a name error. Built-ins are the keywords provided by Python. These keywords are automatically available in a program. We can use this print statement to print out all the built-in names in Python. As you can see, we have str, sum, super, tuple, and so on. It is generally advisable to avoid naming your variables with built-in names. Built-in variables are globally available, and when you use them as variable names, you override their intended interpretation within the program. Let's take a look at sum. 1, 2, 4. This function takes an iterable and returns the summation of the numbers. Great, this returns the summation of the numbers. Now, before the sum function, let's declare a new variable, sum equals 6. When you do this, you are overriding the interpretation of sum coming from the built-in. Remember that built-in names are globally available. Let's run the program to see the output. Python raised a type error. Int object is not callable. That is because the meaning of sum has been changed. We explained earlier that variables in the global scope are accessible from a function. Another question that needs to be answered is, can a function modify variables in the global scope? Let's consider this example. We declared a variable in the global scope. Then in the function body, we try to modify the variable. On this line, we are calling the function. This print statement is printing out the value of the global variable. Now let's run the program to see the output. This value is coming from the function body after an attempt to modify the global variable. This shows that the global variable is unchanged. In Python, it is impossible to update a global variable from within the function body. You can only modify a global variable in a global scope. As a result, Python creates an entire new local variable inside the function body. So this is a new variable, different from the one declared in the global scope. The global keyword is used to indicate that a variable declared within a function should be treated as a global variable rather than a local one. Global variable. This tells Python to use the global scope variable instead of creating a new one. Let's run the program to see the output. We have been able to modify a global variable from within a function using the global keyword. We declared a variable in the global scope. Then in the function body, we are trying to compute a new value for initial value by using the previous initial value plus 1. Let's run the program to see the output. Python raised an error. Local variable initial value referenced before assignment on line 72, which means we are expected to declare a new variable called initial value in the function body before using it. Remember that we have established earlier that it is impossible to update a global variable from within a function body. So Python created a new variable called initial value in the local scope, that is inside the function body. While it was trying to execute the other part of the code, it encountered a variable named initial value again. So it assumes that it is a variable in the function, but this cannot be found in the function. That's why it raised this error. To fix this, we can say global initial value, which is telling Python to use the initial value in the global scope instead of creating a new initial value in the function body. Let's run the program again. Great, it worked. Similar to how global scope works, variables in the outer function of a nested function can be accessed from the inner function, but cannot be modified from the inner function. Let's run the program to see the output. This output shows that x was not modified. We attempt to modify the value of x from the inner function, but the value remains unchanged. By using the non-local keyword, we can specify variable names that should not be treated as local to this function. Non-local x. This makes the name to refer to the variable in the closest enclosing scope, which is the outer function in this case. Let's run the program again to see the output. We have now been able to modify the value of x from the inner function. The globals function returns a dictionary containing the current global names in a program. Let's execute the program to access the global names available. This shows all the global names available. This is name, which is the global variable we declared. We also have showName, which is the function we declared. The locals function returns a dictionary containing all the current local names available in the program. Let's print out locals inside the function name. Print locals. Let's call the function showName. Now let's run the program again. Great. This shows the local variables available. Let me know if you have any questions in the comment section. If you liked this video, please like it and subscribe to the channel. What's going on, friends? In this video, you will learn what it means to pass by reference or pass by value and how Python implementation is unique. Let's say we have a function which adds two numbers together. It takes two parameters, and as a result, two arguments need to be passed to the function call. Remember that whenever you declare a variable, an actual object is created and stored in the computer memory. A is just a name pointing to that integer object. Pass by reference means that these objects are passed as arguments to the function call, and all operations performed on them inside the function will directly affect them since they are references to the existing objects. In contrast, pass by value means that a copy of the value is passed to the function call. Operations performed on the copy does not affect the initial object in the computer memory. Now that you understand what it means to pass by reference and value, let's take a look at some practical examples and how Python's approach is different. Alright friends, let's take a look at this first example. We declared a variable a before calling this function. The variable is passed as an argument to the function. We intend to update the value of a. That is, the integer passed to the function should be equal to 10. Let's run the program to see the output. This output shows that the initial value of a was not affected. The value of a was modified in the function call, but after the function call, the value of a remains the same. Does this then mean that arguments are passed by value in Python since the original object or variable is not affected? Well, we are not going to conclude just yet. Let's consider the second example. We have a list of numbers declared. This list is passed as an argument to the function call. Within the function body, we update the list, that is, passed list list.append. Finally, we print out the value of the list. Let's execute the program. Great! This shows that the original list was updated within the function body. This behavior looks like a reference of the original object was passed to the function call. So any modification made within the function affects the initial object. Does it mean that Python supports both pass by reference and pass by value? The answer is no. Python passes arguments by assignment. We are going to explain what this means. Whenever an argument is passed to a function in Python, a new local variable is created within the function scope. This newly created variable holds a reference to the object passed as an argument, not a copy of the object itself. To verify this behavior, we can use the locus function within the function body. Let's run the program to see the output. Great! This shows a new variable named past_int has been created within the function body. When you write past_int equals 10 within the function body, you are reassigning the local variable past_int to reference a new integer object with the value of 10. This does not modify the original object that was passed as an argument. Instead, it changes what past_int refers to within the function body. This is the behavior when a non-mutable data type, such as strings and numbers, are passed as arguments. Next, let's look at how the behavior differs for mutable objects, such as lists, dictionaries, and sets. As usual, a new local variable named past_list is created within the function body, but it is pointing to the initial object. Both the inner variable and outer variable are pointing to the same object. A list is a mutable data type, so any modification on this list will affect the original object. This behavior can give the impression that the actual object is being passed. If we decide to say past_list equals a new value, 5, 6. This variable is detached from the previous object. It now points to a new object entirely. Any changes on past_list does not affect the initial list. Let's run the program to see the output. Great! As you can see, the values of the two lists are different. Another way to achieve this same result is by using deep copy to create an independent copy of the previous object. We need to import deep copy from the copy module. From copy, import deep copy. Past_list equals deep copy of the past list. This past_list is an independent copy of the original list. Let's execute the program to see the output. Great! The two lists are not the same. I hope you now understand how Python passes arguments by assignment. If you have any questions, please leave them in the comment section.
If you are ready to take your Python skills to the next level, then this video is for you. I'm going to show you 30 functions you need to know. The goal of this lesson is to make you write production-ready code while leveraging functions provided by Python. I assure you that by the end of this lesson, you will be on your way to becoming a better Python engineer. Without any delay, let's dive in.
The first built-in function is enumerate. This function allows you to write a Pythonic loop without the need to manually keep track of the index of an item. Given an iterable such as a list, we can loop through the items in this list using enumerate. For index item enumerate of list, print index item. We are making use of f strings here. Let's run the program to see the output. We've been able to iterate the items in the list while retrieving the indices. Index represents the position of an item in an iterable. Optionally, we can pass an argument that specifies the first index it returns. Index of 1. This means the first item will have an index of 1. Let's run the program again to see the output. Fantastic. When I move the cursor over the function, the code editor shows what the function does. This is another way to know more about each function. The enumerate function returns an iterator, which is why you are able to use a for loop on it. As a matter of fact, each item in the iterator is returned as a tuple. Let's see this in action. For each in enumerate my list, print each. Let's run the program to see the output. Great! We can see that each item returned is a tuple. Sometimes you may have two or more iterables that you wish to combine. The zip function allows you to loop through multiple iterables in parallel. Each item returned by zip is a tuple containing elements from the provided iterables. Let's run the program to see the output. This shows each element is a tuple. The first item here is mapped to the first item here, the second to the second, and so on. we can use tuple unpacking to separate the individual item. For first, last, in zip, first names, point, first, last. Let's run the program again. Great. What happens when the iterables are not of the same length? Let's add another item in first names, Bill. The zip function considers the length of the shortest iterable. The remaining elements in any longer iterables will be totally ignored. Let's run the program again to see the output. Awesome. This shows the same output. Next, we have the all function. The all function returns true if all the items in the given iterables are true. If not, it returns false. The key point is understanding what evaluates to true or false. Non-zero numbers such as 1 and 2 are considered true. A non-empty string evaluates to true. Non-empty containers like dictionary, lists, tuples, and similar data structures are also considered true. Let's run this program to see the output. Great, the output is true because all the items in the iterable are true. If I decide to put an empty string, the output is going to be false. Let's run the program again. The output is false. Moving on, we have the any function. The any function returns true if any element of an iterable is true. If not, it returns false. In this example, the final output is going to be true because at least one of the items is true. Let's execute the program to see the output. The output is true. Let's update the list to contain items evaluating to false. An empty string. In this case, the output will be false because there is no true value in the list. Let's run the program again. The output is false. Let me show you a practical use case. Suppose you are building an application to restrict users based on certain permissions. You want to check if the user has any of the required permissions. Required permissions is a list which looks like this. The retrieved user permission is also a list which may look like this. So you want to check if the user has any of the permissions required. To do that, you want to say that for each permission in the user permissions, is that permission present in the required permission? This is going to return true or false. The final output of this line will look similar to this. If the any function returns true, then we are sure that the user has one of the required permissions. The absolute value of a number refers to the positive distance between the number and 0. For negative numbers, the ABS value is the positive number. For positive numbers, it is the same number. The argument passed to the ABS function can be an integer, a float, or a custom object we create. Essentially, any object that supports ABS function must implement this special dunder method. Let's run the program to see the output. The absolute value of -10 is 10, while the absolute value of 22.3 is the same number. Let's use a string data type to see what happens. Python raised a type error, bad operand type for ABS function. This is because the _ABS function is not implemented on a string object. Let's create our own custom class which implements the dunder method. Now let's define this special method ABS def ABS self return 5. Let's create an instance ABS value of the object, which is the instance of the class. Print ABS value. Let's comment out this other part of the code. Now let's run the program to see the output. Great. As you can see, we are able to use the ABS function on our own custom object because we have defined this special method. The bool function returns true if the value passed to it evaluates to true, and it returns false if the value passed to it evaluates to false. It is important to know what evaluates to true or false. Y is an empty container. Let's run the program to see the output. They are all false. Now let's update the value of x1, a non-empty container, and a non-empty string. All the variables now evaluate to true. Can the bool function be used with a custom object, just as we did for the absolute function? The answer is yes. A custom object passed to bool will always return true because it is a real object. If you want it to return something different, you need to implement the bool dunder method. To fully understand these two functions, you need to understand what iterables and iterators mean. Any object that you can perform a loop operation on it is an iterable. Examples of iterable include string, list, tuple, and a dictionary. So it is possible for us to write for each in my string, this part of the code should be executed. For each in my string, print each. So let's run this program to see the output. Great, we're able to iterate over these string objects. Let's change this variable to a number, 256. Let's run the program to see what happens. As you can see, Python raised an error, type error. Int object is not iterable. On the other hand, any object that implements these two special methods is called an iterator. These methods allow the object to produce its elements one at a time. You use the iter method to turn an object to an iterator. The next function returns the next value in the iterator. Let's declare a list of numbers. My list 1, 2 equals. We want to turn this list into an iterator. We pass in the list, my list. We can now make use of the next function to return the next element in the iterator. Let's print this to the terminal. Let's run the program to see the output. We turned the iterable into an iterator using the iter function. Then we use the next function on the iterator to return the next element. The next function returns 1, which is the first element. Let's return the rest of the elements by using next again. We just need to keep calling the next function to return the next element, but it raises a stop iteration error when there is no more element in the iterator. Let's call the next function again. As you can see, a stop iteration error is returned. A workaround for this is to provide a default value to be returned when nothing is left in the iterator. Let's provide a default value of none. Let's execute the program again. Great. Alright friends, this is a custom implementation of the range function. The range function is used to return a sequence of numbers from a start to a specified stop. For instance, range of 0 to 5 returns all numbers from 0 to 4. The last value, which is 5, is excluded. The init method specifies that when an instance of this class is to be created, we need to pass the start and the end value. Immediately after that, we set the current position to be the start and the end to be the second value provided. The first check in the next method is to ensure that the current position is not equal or greater than the stop. For the first iteration, the next function will return the start value as the current. For the purpose of the second iteration, the current would be the next following number, and that is why we increment it by 1. In this example, the first number returned is 2, which is the starting position. We returned it on line 82. We immediately set the current value to be 3 for the purpose of the next iteration. For number in my range, print number. Let's run the program. Great. 2, 3, 4. The globus function returns all the global variables in the program. Variables defined outside of functions are said to have a global scope. This means they are accessible from any place in the program. Let's call the globus function to return all the global variables available. We are able to find the mylist variable declared as part of the dictionary returned. Notice that this variable, which was defined inside a function, could not be found because it is a local variable. Variables defined inside a function are said to have a locus scope. When you call the locus function inside of a function, it returns the local variables available up to the point where you call the locus function. Let's call the sample function so that the locus function is automatically called. Sample function call. Let's execute the program. As you can see, it returns the local variable declared. The sorted function sorts the items in an iterable and returns it as a list. Sorted numbers equals, then the iterable we intend to sort numbers. Print sorted numbers. Let's execute the program. The numbers in the list are now sorted. The sorted function accepts an optional parameter which is reverse. Reverse specifies whether items should be returned in ascending order or descending order. The default is to sort in ascending order, which is why the default value of reverse is false. Now let's make reverse to be true so that we can sort in descending order. Let's execute the program. Great, the numbers are now in descending order. The reversed function accepts an iterable and returns a reversed version. When you pass an iterable to reversed, the last element becomes the first, the second to last becomes the second, and so on. Note that the reversed function does not perform sorting. it only reverses the elements of the iterable. Let's execute this program to see the output. As you can see, the reverse return an iterator. To turn this into a list, we can use the list function. Now let's execute the program. Great, the numbers have been reversed. We've been using list as an example. We can also use any other iterable, such as a string data type. Let's execute the program. The output should be CBA in a list. Moving on, we have the map function. The first argument you pass to the map function is a function. The second argument is an iterable. The map function calls this function for each item in the iterable. Let's take a look at this example. We defined a function called square, which returns the square of any given number. It means for each item in numbers, we want to execute this function. The final result is now converted to a list. This is one way of getting the squares of all the numbers. Let's execute the program. As we can see, we have the squares of the numbers. For each number in numbers, this function should be called. We converted the result to a list because the map function returns an iterator. Similar to the map function, the filter function takes the first argument as a function. You use it when you need to extract or select specific data from the original dataset based on a condition. Let's say we have a list of numbers and we need to filter out numbers that are greater than 4. We've defined a function which tells us if a number is greater than 4 or not. This function returns true or false. For each item in my list, this function is called. The filter function will return items for which the passed function returns true. In this case, a number is included in the final output only if this condition is true. This is how we can retrieve numbers that are greater than 4. Let's execute the program to see the output. Great, we've been able to filter out items that are greater than 4. The next function on my list is open. The open function returns a file object, which is essential for working with files. Whether you are reading from or writing to a file, this function is necessary. Suppose I have a list of courses and I need to write them into a file. First thing to do is to mention the name or path of the file you want to create. File path equals, I'm just going to call it courses.txt. Courses.txt. Next is to create a file object using the open function. File equals the open function. The first argument you need to pass is the file path. File path. Then the mode. W stands for writing. For each course, in my courses, file.write. We want to write the course plus a line break. Finally, we need to close the file, file.close. We open the file on this line, then we run a for loop on the courses. That is, for each course in my courses, the course should be written to the file. Print file saved. Let's execute the program to see what happens. File saved. Now let's go and check the current directory to see if the file has been saved. As you can see, we have a file created. The name of the file is courses.txt and this is the contents. A cleaner and more memory efficient approach is to use a context manager with the with keyword in Python. Let's comment out this part of the code. Let's use a new file name, courses2. Now let's run the program to see the output. This shows a new file has been successfully created. Let's open the file in read mode with open the file path as file for line in file print line dot argstrip. For each line in the file, we want to print out the content of the line. File path is referring to courses2.txt. Now let's execute the program to see the output. Great, this is how we can read the content of the file when the mode is read. In object-oriented programming, a child class is able to access all attributes and methods defined in the parent class. The cat class is a child class because it inherits from the animal class. As you can see, the cat class overrides the move method defined in the parent class. You use the super function when you need to call a method from the parent class. The super function returns a temporary object of the superclass that then allows you to call that superclass method. Cat_1 is an instance of the cat class. Then we call the move method on it. Let's run this program to see what happens. Animal is moving is printed out because we've used the super function to call a method in the parent class. If it turns out that a child class inherits from multiple parents and the move method is defined in all the parents, which move method would be called when we use super? Python uses method resolution order to know which method to call. Methods are searched from the left to the right. So the expected output here when the move method is called is parent2move. This is because the methods are searched from the left to the right. Let's execute this program to see the output. Great. Parent2move, child move. The only point it goes to the next class to look for a method is when it cannot be found in the first class. Let's bring parent1 method to be the first. Now if we run the program, this method is called. Let's run the program. Great. Parent1 move. You use the double_MRO attributes on a class to examine its method resolution order. Child1 class dot MRO. Let's point this to the terminal. Print. This shows the method resolution order. Parent1 comes first. Let's change the order. Parent2. Now let's execute the program again. Great. Parent2 comes first because of the order. A method is a function defined within a class. This it method is an instance method. Through the self parameter, instance methods can freely access attributes and other methods on the same object. This gives them a lot of power when it comes to modifying an object state. A class method takes the first parameter as CLS, which points to the class. It can work directly on the class without any need to create an instance of the class. Class decorator is used to flag it as a class method. On this line, we are calling the class method. Remember that we need to pass the new group argument as defined here. We are using this method to modify a class attribute, which is group. This group is pointing to this class attribute. To confirm that the group has been modified by this modify group method, we create an instance of cat so that group can be printed to the terminal. Let's execute the program. Great, group is wild. That's because we've used the class method to modify a class attribute. Static methods take neither self nor CLS as the parameter. This means a static method cannot modify object states or class states. They are mostly used as utility functions in programs. For instance, this static method is doing some computation before returning the current time. Current time equals, let's execute the program. This shows the value returned by the method. The callable function returns true if an object appears callable. If the object is not callable, it returns false. The term callable means that you can use double parentheses immediately after the object to call it. We've declared two variables, a string data type. The second variable is pointing to a function we've defined. Let's use the callable function to know if we can call the two variables. Let's try out y, which is pointing to a function. The output is true. This shows that we can call y, which is pointing to a function. Let's see if x is callable. X is a string data type. Let's run the program again. X is not callable. The implication of this is that if we try to call x, Python is going to raise an error because it is not callable. Let's try that out. Python raised a type error. String object is not callable. Instances of a class are callable if their class has this special call method. Let's call an instance of this class cat1. Let's execute the program. Cat object, which is an instance, is not callable. The double_ method is required for an object to be callable. Let's declare the method in the cat class. Def call self return. We can specify what we want it to be returned when it is called. Now we can easily call the cat object. Let's call it. This shows there is no error. Let's print out something to the terminal. Print. This works. The range function can be used to return a sequence of numbers. Suppose you want to get a sequence of numbers from 1 to 10. You can simply use the range function. The first argument is the start, while the second is the end. Let's print out the numbers. A range object is returned. You can use the list function to convert the range to a list. Alright, so let's execute the program again. Notice that the stop value is excluded. Another way to retrieve the numbers in the range function is to use looping. For each in range 1 to 10 points, let's execute this program. This is how we can use looping to retrieve the numbers. If the starting position is not given, then a default value of 0 is used. Let's remove the starting position. The expected output should start from 0. Let's execute the program again. The third optional argument that can be passed to the range function is the step. If you specify 1, which is the default step, we get the same result. Let's run the program. Now let's specify 2. Now let's execute the program to see the output. 1, 3, 5, 7, 9. So every second number is returned. Suppose we need to obtain every odd number from 1 to 20. We can use the range function to achieve this. 1 to 20. The step should be 2 so that every second number is returned. Let's convert the range to a list. We can now print out the output point. Let's execute the program to see the output. 1, 3, 5, 7, 9. We have been able to retrieve every odd numbers from 1 to 20. The len function returns the number of items in an object. Given a list, we can use the len function to know the total number of items present. Len languages. Let's print the output to the terminal. Print. Now let's run the program. The argument passed to the len function may be a sequence or a collection. The sum function returns the summation of numbers present in an iterable. Suppose we have a list of numbers and we need to calculate their sum. We just need to use the sum function. Result equals sum. Then the iterable numbers. Print result. 10 is returned as the summation of the numbers. If the iterable is empty, such as an empty list, the result is 0. Let's run the program again. Great. When calling the sum function, you can pass an optional start value to it. This start value will serve as the first element. If the list provided is empty, this start value will be returned. Let's specify the start value to be 1. Now let's run the program to see the output. Great. Given an iterable, max returns the largest item while min returns the smallest item. The maximum value is 9 while the minimum value is 2. These two functions are not limited to numbers alone. Items in the iterable can also be strings. Let's try that out. My underscore string equals a list of strings. Let's execute the program. The maximum is C while the minimum is A. The hasAttrib function, short for hasAttributes, checks if an object possesses the attribute specified by the name. It returns true if the attribute is present and false otherwise. Group is a class attribute while name and age are instance attributes. On this line, we create an instance of the cat class. These two arguments are passed as declared in the init method. So we want to know if cat_1 has name attribute, age attribute, and group. This shows the cat_1 object has all the three attributes. Group is true because instance of a class has access to the class attribute. Let's specify an attribute that doesn't exist, cat level. So we need to specify the attribute here. Let's run the program again. This shows that the cat does not have an attribute known as the level. The setAttribute function sets the value of the attribute of an object. Let's set the attribute of level which does not exist. So the first parameter we need to pass is the object cat1 followed by the attribute we want to set, level. Then the value of the attribute we want to set. Let's set the level to be 10. The previous result for hasAttribute for level was false. Now let's check the level after we've used setAttribute to set the attribute of level. As you can see, the hasAttribute function is now showing that level exists. The getAttribute function returns the value of the named attribute of an object. Let's get the value of name. Name value equals getAttribute. We need to specify the object cat_1. Then the name of the attribute we want to get its value, name. Print name value. Let's execute the program. This shows that the value of attribute name is node. The isInstance function returns true if the object argument is an instance or subclass of the class info argument. Suppose you have a variable and you need to know if it's a list data type or not. IsList equals the isInstance function is instance my list, which is the object, then the class info list. Is this list object an instance of a list? Point is list. Let's execute the program. The result is true. This means this list object is an instance of a list data type. Let's check if the variable is a string data type. Is string str of a string? Print is string. Is my list, which is a list data type, an instance of a string data type? Let's execute the program to see the output. The output is false because my list is not an instance of a string. You use the isSubclass function to check if a class is a subclass of another class. it returns true if this class is a subclass of this class. We have two parent classes, parent1 and parent2. Child1 is a subclass of parent1 because it inherits from parent1. Let's make use of the isSubclass function. Result equals isSubclass child1 parent1. Is child1 a subclass of parent1? The result is true. Let's run the program. A subclass of parent2, the result is false. This is how we can use isSubclass function to check if a class is a subclass of another class. The next function is id. The id function returns the identity of an object. Whenever you declare a variable such as x equals 5, an object is created in the computer memory. X is just a name pointing to that object. Each object in the computer memory has a memory address unique to it. The memory address for such object is returned by the id function. Let's make use of the id function. id of y. Let's print out the result. Print. Let's execute the program. This shows the id of the object. When you write sum underscore value, which is a new variable entirely, equals x plus y, a new object is created and its value will be the sum of x and y. id sum value. Let's execute the program and see the output. Great. A frozen set is similar to a regular set in Python. However, a frozen set is immutable. Immutable means that its items cannot be changed once it is declared. Sets are known for containing unique items and offering constant time retrieval of elements. Let's try to add an element to a frozen set. cities.add new. Let's execute the program. Attribute error. Frozen set object has no attribute add. This is because you cannot modify a frozen set. Adding an element works fine for a regular set, which is mutable. Regular set.add new. Now let's point out the content of regular set. This shows that a new item has been added to the set. The round function rounds a number to the nearest whole number. If the value after the decimal is less than 5, it rounds to the same whole number. If it is greater than 5, it rounds up to the nearest whole number. Let's execute the program to see the output. The first number rounds to the same number, while this rounds up to the nearest whole number. The default behavior of the round function is to round to the nearest whole number, but you can optionally specify the number of decimal places to be considered. So let's specify one decimal place. One decimal place. The number after the first decimal place is greater than 5. The result here will be 22.8. Let's execute the program. Great. 20.4, 22.8. The round function shows unexpected behavior when the digits in the decimal part ends with 5. What do you think the output would be for num1 and num2? You might expect num1 to be 7 and num2 to be 8. Let's execute the program and see the output. Surprisingly, num1 rounds down while num2 rounds up. This is because Python 3 and some other programming languages adopt a strategy known as round ties to even. A tie is a floating point number ending with 5. If the digit to the left of the last digit in a tie is even, it rounds down to the same number. If the digit is an odd number, it rounds up to the nearest whole number. This is why 7.5 is 8. A property is an attribute that is computed dynamically. Suppose we need to tell each user his full name. There are numerous different approaches this could be achieved. First, we may decide to add a third instance attribute. So we can write self.fullname, which is a new instance attribute, equals self.firstname last name. Now I'm going to show you why this approach is not the best. Let's print out person1 full name. Print person1 dot full name. Let's run the program. Great, this shows the full name of the user. On the next line, let's change person1 first name. person1 dot first name equals a new name. Let's call it Alish. Let's print the full name again after the first name has been modified. Let's run the program. As you can see, this shows the full name is not returning the correct data. The value of the first name has been modified, but it is not reflecting in the full name. Why is this happening? This is because the constructor method, which is setting the value of full name, is called once when a class is instantiated. So it is unaware of what is happening after an object is created. The second approach to get a full name is to use a method. Every time this method is called, it returns the full name based on the current first name and last name. Let's try to define a custom method to achieve this. Let's name the method getFullName def getFullName, the first parameter should be self, pointing to the instance. Return fstrings self.firstname, self.lastname. Let's remove this third attribute since we are using a method now. person1.getFullName, we are calling the method on this line. Then person1.getFullName again. Let's execute the program. The getFullName method works fine. Changes are now reflecting in the full name after the person's first name has been modified. The Pythonic solution to this problem of computing an attribute dynamically is to use property. You just need to decorate this method with @property. Let's comment out the first one. Now you need to decorate this method with @property. It would make sense to rename this method so that it resembles an attribute. Let's call it fullName. We can now make use of it as an attribute. person1.fullName. Be sure to check out the upcoming lesson on object-oriented programming, where we dive deeper into getters and setters. What's going on, friends? In this lesson, we are going to cover all you need to know about loops, a fundamental concept in programming. Later on, we will explore advanced tips, including comprehensions. Without further delay, let's get started. Looping means repeating the same block of code over and over until a particular condition is satisfied. Python supports what is known as collection-based looping. This means for you to repeat a particular block of code, you need an iterable. An iterable is any data type that can store multiple items. Examples include a list data type, tuple, dictionary, string, and so on. The part of the code we intend to repeat is the loop body. Each is just the individual item present in the iterable. For each item in the iterable, this part of the code will be executed. Suppose we have a list of names. We can loop through the list using a for loop. We bring in the for keyword followed by a variable name. This name is up to you. For name in the in keyword, then the iterable we want to loop over names, which is a variable we've declared, followed by the colon, then press enter key on the keyboard. Notice that the next line is not starting from the very beginning. What we have to write now is the loop body print hi. This inner block of code, which is the loop body, will be executed for each name. For each name in names, this code is executed. Let's run the program. As you can see, this loop body runs for each item in the collection. It runs 4 times because we have 4 items in the iterable. Next step is to make use of this variable. This variable is always pointing to the next item each time we loop through the collection. For the first iteration, it points to this item, which is Ray. For the second iteration, it points to the next one after the first item, and so on. Now let's make use of the variable name. Let's execute the program again. Great, each name is returned. The range function is popularly used with a for loop. The range function returns a sequence of numbers from a start to the specified stop. The upper bound is excluded. For instance, if you want to run a program for 5 times, you can use the range function. For I in range of 5, print I. Let's execute the program to see the output 1, 2, 3, 4, 5. So we've been able to repeat this inner block of code, which is the loop body, 5 times. We are able to use a for loop on range because the range function returns an iterator. Variable I is pointing to each number. Suppose we have an iterable and we need to return each item with its index. Let's declare a list of alphabets, letters equals A, B, C, D. If we try to use the normal for loop, we can't get the actual index for each in letters. Print each. Let's execute this program. This returns the actual items in the list. How do we get the indices of the letters? Let's use the range function to achieve this. For index in range, the length of the letters len of letters, the number of items in letters. So this part of the code is the same as range of 4. Range of 4 evaluates to 0, 1, 2, 3. Technically, these numbers are the same as the indices found in this collection. Let's use the print function print. Let's make use of fstrings. Index, the value should be the index item. We can get the items using the index value. Index. Now let's execute this program. Great, we have each item returned with the index. A better approach is to use the built-in enumerate function. The enumerate function returns each element with its index. Let's use enumerate for index item in enumerate letters print f strings index item. Let's execute the program. Great, we have the same result. When you use a for loop on a dictionary, it only returns the keys. Let's try that out for each in my Dict print each. Let's execute the program. This shows that each is only pointing to the keys in the dictionary. For us to get the keys and the values, we can use the items method on the dictionary .items. Let's execute the program again. This shows that each item is returned as a tuple, the key and the value. We can further use tuple unpacking to separate the items. For key, item, let's print out the key and the item, key, item. Now let's execute the program. Great, it works. The break keyword is used to exit a loop prematurely. When the break keyword is encountered in a loop, the loop is terminated immediately. We have put a check in this for loop. If I, which is a number in the sequence, equals 4, break. If this condition is met, the line following the break keyword won't be executed, and the loop will also be terminated. Let's execute this program to see the output. 0, 1, 2, 3. When it gets to 4, the loop is terminated. The next line that runs is the first line following the loop. This part of the code represents the for loop block. The immediate line after the for loop block is the line on line 23. We can bring this up, but for readability, let's leave it like this. The continue keyword is used to skip the rest of the code inside a loop for the current iteration and move to the next iteration. If I is equal to 4, continue, that is, skip the rest of the code in the current iteration and jump to the next iteration. Let's execute this program to see what happens. As you can see, 4 is skipped. This is because when this condition is met, the rest of the code is skipped. Then we move on to the next iteration. Iteration using a for loop is called definite iteration because the number of times the inner block of code will be executed is specified at the time the loop starts. The while loop is used for indefinite iteration. Indefinite iteration is when the number of times the loop is executed is not specified in advance. The loop is executed repeatedly as long as some condition is met. This is the syntax of a while loop. The loop body represents the block to be repeatedly executed. The loop body will only run if the expression evaluates to true. Let's declare a variable x equals 0, while x print high. This print statement is never going to run because x evaluates to false. Let's execute the program to see what happens. As you can see, nothing is printed to the terminal. Now let's use a true value such as a non-empty list 1, 2. Let's execute the program. The block of code will continue to run forever. I have to terminate it. This block keeps running because the value of x is always true. Let's take a look at an example. Let's declare a list of number nums equals 1, 5, 6, 8. While nums, which is the condition or the expression, print the loop body nums dot pop -1 print done. We have 4 numbers in nums. This block of code will run because nums evaluates to true. Nums.pop removes the last item in the list. The last item is 8. 8 is printed to the terminal for the first iteration. For the second iteration, nums is now 156 because 8 has been removed. This process continues until nums is an empty list. When nums is empty, the iteration stops because nums now evaluates to false. Let's execute this program to see the output. Great, 8651. This loop does not run forever because at some point nums becomes an empty list. You use a while loop when you cannot predetermine how many times a block of code will be executed. However, always remember to break out when a certain condition is met, except if you want the block of code to run forever. Let's write a program that stores a user's to-dos. First is to have a container where the user's actions are stored. Let's declare a variable store equals an empty container, which is a list data type. We need to use a while loop because we don't know in advance how many actions they would like to store. We can simply say while true. The next thing is to collect an input from the user underscore input, which is a new variable name, equals Input, we need to use the input function, an optional text to be displayed on the terminal. What do you want to do? A new line, enter n to quit. Let's do a check to know if the user wants to quit the application if user input equals n. So what we want to do is to break out of the loop. Otherwise, we are going to say store dot append to add a new element to the list. Let's pass in the user input. If we don't break out of this loop will run forever because the condition here is true, and true will always be true except if we modify it. The final step we should do is to print out the content of the store. Once the loop is completed, print store. Now let's execute the program. What do you want to do? Enter n to quit, cook. Again, drive, code. If the input is equal to letter n, the loop is automatically terminated and the next line to run would be this line on line 50. Line 50 follows the loop block. Now let's press n to see what happens. Great, the items in the store is now pointed to the terminal. Comprehensions offer a more Pythonic way of looping, and that's what we will explain in the next lesson. Subscribe, like and comment. What's going on, friends? List comprehension is a fast and elegant way to create a new list based on an existing iterable. This is a powerful functionality provided by Python that allows you to write clean code with just a single line of code. Set and dictionary comprehensions are the other forms of comprehensions. In this lesson, you will learn how to effectively write code with comprehensions and when not to use them. Let's get started. Suppose you have a list of numbers and you want to get the squares of the numbers in the list. You would probably want to use a for loop to solve it. First, you initialize an empty list to store the squares. Let's call it result. Result equals an empty list. Next is to use a for loop to iterate over the original numbers. For num in numbers, this inner part is the loop body. It runs for each number in the numbers. Now let's add the square of each number to result. Result dot append num times num. For each number in numbers, we add the square to result by using the append method on a list. Let's print out the result. Print result. Now let's execute the program to see the output. We now have a new list containing the square of each number. This solution involves 3 steps. The first step is to initialize a list. The second involves looping. And finally, the third step is the append operation. We can achieve the same result in just one line of code when list comprehension is used. This is the syntax of list comprehensions. For each member in the iterable, the specified expression should be executed and the result should be added to the list. Let's revisit the previous example. Result equals, we bring in the square brackets for num in numbers. This part of the code on the left hand side should be executed, num times nums. For num in numbers, this part of the code will be executed and the result will be added to the list. Let's run the program to see the output. We have the same result. This card on the right hand side shows the equivalent when the map function is used. For more information about the map function, be sure to check the top 30 functions you need to know. List comprehension supports adding a conditional logic. Here is the syntax. For each member in the iterable, the member is considered only if this condition is true. Let's say we have a list of numbers and we need to filter numbers that are greater than 4. Let's make use of list comprehension. Result equals, for num in numbers, num should be returned, which is the number. Now let's put a conditional check. If num is greater than 4. For num in numbers, this part of the code should be added to the new list, but we put a condition here. If num is greater than 4, that is, the number will only be considered if this condition is true. Results. Let's execute the program. Fantastic. We now have a new list containing numbers that are greater than 4. Another version of the conditional statement is when you place the condition near the beginning. This is particularly useful when you want to use a ternary operator. For each member in the iterable, if the condition is true, this expression should be considered, else this should be considered. Result equals square brackets for num in numbers. If num is greater than 2, this part of the code should be considered, else this should be considered no. This means if the number is greater than 2, yes will be put into the list. If not, no would be considered. Let's print out the result. Print result. Let's execute the program. Great. We have the result. A set comprehension is almost the same as a list comprehension. The difference is that set comprehensions make sure the output contains no duplicates. Let's turn the previous example into a set comprehension. We just need to use curly braces instead of brackets for num in numbers. This part of the code should be put in the new list num. Let's execute the program. 4 is repeated twice in the initial list, but in the final output it appears once. Dictionary comprehensions are similar. We only need to add the key. For instance, we can make this a dictionary comprehension. Now let's execute the program. Great. Let's further check the type of the result. Type. Now let's execute the program. This shows it is a dictionary. While list comprehensions can allow you to write elegant code, they may not be the right choice for all circumstances. List comprehension loads the entire list into memory. Therefore, it is suitable when working with small or medium-sized lists. However, if you are dealing with millions or billions of data, using a generator is recommended. Otherwise, the computer might crash due to the excessive memory usage. For instance, this code is using list comprehension to calculate the squares of all the numbers from 0 to 10. We can turn this to a generator by using parentheses. This is no longer a list comprehension. Generators use lazy evaluation, which means they produce values on the fly as you iterate over them. This can significantly reduce memory usage because it doesn't generate the entire sequence at once. Let's print out the squares. Print. This shows squares is a generator object. Since generators are iterators, you can use a for loop on them to retrieve the items, or you use the next function to retrieve the next element in the iterator. Let's make use of the next function. Next. Now let's execute the program. It works. Subscribe, like and comment. Thanks. Errors are the reasons why most applications fail. If not properly handled, they can stop your program or cause it to produce unexpected behavior. In this lesson, you will learn how to effectively handle errors in your program. Let's dive in. The most common mistake for beginners learning Python is a syntax error. This happens when you don't follow Python's rules while writing code. For instance, whenever you use a for loop for iteration, a colon must end the first line before you move to the loop body. Now let's intentionally omit the colon. Let's execute the program. As you can see, a syntax error has occurred. The arrow indicates where it happened. Additionally, the error message gives you a hint about what went wrong. Syntax error expected a colon. These errors are usually spotted by your code editor or through an extension if you are using one. The extension I'm using is already showing where something is wrong. Another syntax error is when you use the return keyword outside of a function. Return hi. Let's execute the program. It shows syntax error. Return outside function. The return keyword is expected to be used in a function definition. Moving on, an exception is what occurred whenever syntactically correct Python code results in an error. This program prints the result of a division operation between two numbers. Now let's make a variable y, which is the divisor, to be 0. Execute the program again. Python receives a 0 division error when you attempt to divide by 0, which is not allowed in mathematics. The error message also indicates the file and line where the error occurred. This error occurred on line 10, which is this line of code, and this is the expression that raised the error. A Python program terminates as soon as it encounters an error. In this case, line 12, which is the last line of the program, was not executed due to the encountered error. If you know that a portion of your code may produce an error, it is important to handle such error. You can use the try except block to manage exceptions within your code. Let's include the portion that might cause an error in a try except block. We need to use the try keyword, try, followed by a colon, then press enter on the keyboard. Then the portion we want to try that might cause an error, which is this line. Now the next part is except. Then we need to mention the error that might be raised, 0 division error. Except 0 division error, followed by a colon, then press enter again on the keyboard. Print division by 0 is not allowed. You are simply telling Python to try and execute this part of the code, and if zero division error occurs, you want to handle it in this block of code. So we are telling the users that they cannot divide by 0. Let's execute the program again to see the output. Division by 0 is not allowed, the end. Now the last line in our program runs because we've handled the 0 division error. If you omit the specific type of exception, Python will catch all exceptions inheriting from the exception class. Let's remove this 0 division error and see what happens. Run the program again. We have the same result. It is advisable to avoid this practice whenever possible. Another way to do it is to mention the exception class, exception. Let's run the program again. It works. We can also say except exception as E, which is a new variable we can use inside the except block. Error. Now let's execute the program again. 0 division error. The error is captured as variable E, which is then used in this block. This table displays the most commonly encountered errors. For more errors, you can use this command to check. In some situations, we might want to run a certain block of code if the code block inside try runs without any errors. In such cases, you can use the optional else keyword with the try keyword. Line 26 will run only if there is no error in the try block. Let's execute this program to see what happens. 20 divided by 5 is 4.0. Now let's try to divide by 0. Let's run the program again. You cannot divide by 0. The finally block is executed regardless of whether an exception occurs. It is optional and each try block can have only one associated finally block. It is useful in cleaning up resources such as closing files and database connections. On line 30, we opened a file without specifying the mode. The default mode whenever the mode is not specified is read. Line 33 will raise an unsupported operation because we are trying to write to a file when the mode is read. The closed attribute of the file object tells whether a file has been closed or not. Let's execute the program. This shows that this file was opened but was not closed. The finally block is a good place to perform cleanup operations because it will always run. Let's close the file in the finally block. Let's run the program again. Great, the file has been closed. The raise keyword allows you to force a specified exception to occur. It allows you to interrupt the program based on your requirements. Building on a previous example, we can choose to raise a value error to prevent a situation that could cause the program to fail. If y equals 0, raise value error. We can then put an optional message here. Division by 0 is not allowed. Let's execute the program. Value error, division by 0 not allowed. It is important to raise the suitable exception based on the requirement. For example, using file not found error might not be the most appropriate choice in this context. The preceding examples only utilize a single except block following the try block. This example demonstrates how to use multiple except blocks to handle various types of errors. If the denominator is 0, this except block would handle the exception. For a type error, another except block takes care of it. Let's set the value of y to be 0 and see what happens. Division by 0 error. This block handles it. Now let's make y to be a string data type. Let's run the program again to see the output. Type error. Unsupported operand types for division. Int and string. We are getting this error because we are trying to perform a division operation between an integer and a string data type. X is an integer while y is a string data type. So it is impossible to perform a division operation between the two data types. Using a tuple of exception types is a simple way to catch multiple exceptions in a single except block. When an exception occurs in the try block, Python checks if the exception is any of the listed types in the tuple. If so, the corresponding except block is executed. Now let's execute this program to see what happens. 0 division error is captured by this block when the denominator is 0. Now let's try to use a string data type. Let's execute the program again. Unsupported operand types. Both 0 division error and type error are captured by this block. Reading data from and writing data to a file are very common activities in our day-to-day life. In this lesson, you will learn how to work with files using Python make sure to stick to the end because we are going to create a program that reads IP addresses from a file, goes over to the internet to look for locations corresponding to those IP addresses, and then adds that information back into the initial file. By the end of this lesson, you will have confidence in working with files. When working with files, 3 steps are involved. The first step is to open the file, read information from or write information to the file, and finally close the file. Before you can read or write a file, you have to open it using Python's built-in open function. This function creates a file object that will be used for further operations. Let's declare a variable called file object. File object equals the open function, open. The first argument you need to pass to the open function is the file name. To specify the file name, you can use either the absolute or the relative path. A relative path refers to a specific file from the current working directory, which is the directory where your Python script is located. An absolute path provides a complete sequence of directories from the root of the file system to a specific subfile. If we create a file in the current folder where this Python script is located, then we can simply mention the name of the file, and that serves as the relative path. The name of the file is sample.txt. Sample.txt. To determine the absolute path, you can use the pwd command in the terminal. This displays the full path from the root directory. Another way to obtain the absolute path is to right-click on the file, then click copy path. Now let's move back to our Python script. Ctrl V. So this is the absolute path, which is the same as the full path of the file. The next step is to specify the mode, which could be read, write, append, and so on. In this case, we can leave the mode as arg since we only intend to read from the file. Now we have the file objects, and there are various methods available to be used. Make sure to check the free PDF guide to see the full list. When you call the read method on a file object, it returns the entire content of the file in the form of a single string. Let's declare a new variable called file_data, file data equals file objects dot read, which is the read method. Let's print out the type and the content of the file data. Print type file data, print file data. Now let's execute the program. This indicates that the read method returns the content as a string. The type of the file data is a string, and this is the content. This shows what we have in the file. Now let's use the readLines method. ReadLines. Let's run the program. The readLines method returns a list of all the lines in a file. Each item in the list represents a single line. Python plus a new line, Django plus a new line. /n is an escape sequence that represents a new line. Now let's use a for loop to print the content on the screen. For line in file data, print line. Remember that file data is a list data type. Line.strip. The strip method removes white spaces from the start and end of a string. Let's run the program again. Great, we now have the content of the file printed on the screen. So that's how we can open a file and read the content of the file. We've used Python to open a file, work on the file, but we haven't closed it. Remember that the last step is to close the file. Once you have finished your work, the closed attribute on a file object indicates whether a file is closed or not. Let's make use of the closed attribute to know whether the file is opened or closed. File objects dot closed. Let's comment out this part of the code. Let's execute the program again. This shows that the file is not closed. The close method is responsible for closing the opened file, while closed is an attribute that signifies whether the file is closed or not. File objects dot close. On this line, which is line 8, we are closing the file. Let's run the program again. Fantastic. The closed attribute shows that the file has been closed. Before we proceed, a better way to work with files is to use a context manager. When you use the with keyword, resources such as file closing are automatically managed for you. This approach involves manual closing of the file. If an error occurs before we get to the point of closing the file will remain open. So let's use a better approach. Let me zoom out. We need to use the with keyword with, then copy this part of the code here, as file objects. I'm just going to comment out all we have here. File data equals, then we cannot make use of the for loop on the file data for line in file data print line dot strip. Now let's execute the program. Great, we have the same result. If any error occurs, Python will automatically close the file for you. Another point to mention is that using read and read lines is not ideal for working with large data sets because they load the entire file object into memory at once. So if you are working with a file containing thousands of lines, it would be better to loop through the file one line at a time to minimize memory usage. Let's put that into practice. We are going to comment out this file data. Then we can say for line in file objects. This is how you are going to write your code if you are working with a large data set. Let's execute the program. We have the same result. The file is automatically closed outside of this with block. We can confirm that by using the closed attribute outside of the with block. Let's try that out. Print file objects dot closed. Let's execute the program again. As you can see, the file has been closed by Python because we are using context manager. Writing to a file is similar to reading. We need to mention that the mode is right and use the appropriate methods. With open, the name of the file, let's call it sample2.txt, sample2.txt. The mode is right as file objects dot write hi, a new line. If a file does not exist, the write method will create it, but if it exists, it first deletes the content of that file before writing a new content into it. So you should be careful when using the write mode. The write method does not add a new line character to the end of the string. You must do it manually. Print done. Let's comment out this other part of the code. Now let's execute the program. Done. The name of the file is sample2.txt. Let's look for the file, sample2.txt. A new file has been created with the name sample2.txt. Just to show you that you need to manually add a new line, you will see that the write method does not add a new line. Let's execute the program again. Let's go back to sample2.txt. As you can see, all the contents are written on a single line. The second method you can use is writelines. Writelines writes a list of strings to a file without adding a line separator. File object dot writelines. Then we pass in the list we want to write. Hi again. Save the file and run the program again. The two strings have been written to the file. The append mode is similar to the write mode. You have to signify that the mode is append by writing letter A. If the file exists, it starts writing to the file from the last line. If the file does not exist, it creates a new file for writing. Writing in append mode is recommended when you don't want the initial content of the file to be overwritten. You just need to specify the mode as A, and that's all. We've already created sample2.txt. It contains 2 lines. What we want to do now is to write a new line to sample2.txt. Let's add a new line before writing the content. Let's execute the program. Let's go and check sample2.txt. Great, we have hi written to the last line. Alright friends, let's start the project exercise. The requirement states that given a file containing IP addresses, a program should be written to fetch the locations and save them into the same file. I have discovered that this website can be utilized to obtain the location associated with a given IP address. Before starting any coding exercise, make sure to document your steps to stay organized. I have listed a couple of steps needed. The first step is to read the IP addresses from the original file. Next, for each IP address, make an API call to the IP info website to retrieve the location. Finally, save the IP address and its corresponding location back into the file. Before making a network call to a website, ensure the request library is installed. You can install it by typing pip install requests. Press enter on the keyboard. Requirement already satisfied means that the library is already installed on my system. Now let's move on. Let's declare a variable to hold the name of the file containing the IP addresses. file underscore path equals the name of the file is ip underscore addresses dot txt equals ip dot txt. This is the name of the file containing the IP addresses we want to work with. Now let's read the content of the file. We can make use of the open function with open, then the name of the file, which is file path. The mode, we need to specify the mode to be read as file object. IP addresses equals, which is a new variable, equals for line in file objects line dot strip. For each line in the file object, line dot strip should be added to the new list. Here we are using list comprehension to perform iteration over the file object. For now, let's print out the IP addresses. Print IP addresses, IPs. Let's execute the program to see the progress. Great. So we've been able to read the content of the file, which is this file, and save it into a new variable, IP addresses. The next step involves getting the locations for these IP addresses. For each IP address in the IP addresses, we need to make an API call to the IP info website. Let's create a function that takes an IP address and return the location. We are going to call it def, which is a new function, get underscore location. It takes an IP address as the parameter address pass. Let's head over to the IP info documentation. This URL returns the location as plain text based on a given IP address. So that's what we need. I think you may want to check out this link. Let's declare a new variable URL equals fstrings https. This part is the IP address. We can replace it with the IP address response equals requests dot get the URL. On this line, which is line 5, we are using the request library to make an API call to this URL. Let's import request, which is the library we've installed. Import requests if response dot status code equals 200 data equals response dot text else data equals not found. Whenever you make an API call to a URL, the status code indicates the status of your API call. A status code of 200 means everything is fine. If it is not 200, we want to set the location as not found. Let's return data. Now we have a function. Given an IP address, it returns the location. Let's make use of this get location function. Locations equals for IP in IP addresses. We want to call the get function location with the specific IP address. For each IP in the IP addresses, this function will be called and the result will be added to this list. We are also making use of list comprehension on this line. Be sure to check out the lesson on comprehensions to know more about how comprehensions work. Let's print the location to the terminal. Print locations. Let's execute the program to see the progress. Great, we have the locations returned 1, 2, 3, 4. 1, 2, 3, 4. You might notice that there is a delay before the locations are returned from the API. The first reason is that this code is synchronous, meaning it processes requests one after the other. The next call to the IP info website would not start until the first one is complete. We can leverage asynchronous programming to address these delays. However, this topic has not been covered yet. As a bonus, the code for the asynchronous version will be provided in the description below. The second reason for the delay might be that the website takes some time to return the location due to network or internet connectivity issues. The final step is to write the locations into the same file. For simplicity, we are just going to overwrite the file by using write mode. Let's open the file again with open the file path. We need to specify the mode as write, W, as write file object. So we have two lists, one containing the IP addresses and the other containing the locations. The zip function will iterate through the two lists in parallel.
and return a tuple containing items from each list. Let's make use of the zip function to loop through the two lists in parallel. For IP underscore address, comma location in zip of IP addresses and locations. Write file objects dot write f strings IP address location. When we open the existing file on this line, the file will be overwritten because we are using W. Now let's execute the program again to see what happens. Alright, so now let's go and check the initial file. Great, we now have IP addresses and the cities. The CSV format is the most common import and export format for databases and spreadsheets. This means whenever you want to import data into or export data from the database, you would come across the CSV format. If you open a CSV format with Excel or LibreOffice, it looks similar to this. To read a data from a CSV file, we need to use the open function as usual. With open, the name of the file and the mode as file object. We first need to import the CSV module. Import CSV. You don't need to install any package here because CSV comes with Python. Now you need to declare a new variable reader or any suitable name equals CSV.reader. Then you need to pass in the file objects. For name level in reader, print f strings name level. Now let's execute the program. Great, we've been able to read the content of the CSV file. If you notice, the headers of the CSV file, which are name and level, are also returned here. So what you can do to avoid that is to use the next function. Then you pass in the reader. Let's execute the program again. It works. You are able to use the next function on reader or a file object because a file object is an iterator, which means it produces its elements one at a time. Calling the next function on it will return the first line, which is the header. Writing to a CSV format is similar to reading. You need to use the open function, the name of the file, and the mode. The mode needs to be W, which is for writing, as file objects. Then you say writer equals CSV.writer. Then you pass the file object to it. Now you have a CSV writer which can be used to write into the file. We can say writer.write role to write a single role into the CSV format. Then you pass a list of columns you want to write, name, level. This will serve as the headers. Now we want to write a new row into the CSV, a new row, level equals to 10 as well. Now let's execute this program to see what happens. Alright, so now let's go and check if a new file has been created. Sample2.csv. Sample2.csv. Let's check the content. Great, we have the exact content written into it. For more practice questions, be sure to check the description below. Subscribe, like, and comment. Thanks. Object-oriented programming, also known as OOP, is an important concept in programming. In this lesson, I will simplify this concept so that you can start writing real-world applications by leveraging it. This lesson has associated projects and assignments to solidify your knowledge. Without any delay, let's dive in. Before we move on to fully explain what object-oriented programming entails and the problems it solves, let's create one or two real-life scenarios. Suppose you are building an application like Facebook and you need to represent different users on the platform. One approach might be to create variables to uniquely identify users on the platform. So we can use this set of variables to represent a particular user, which is the first user. User1_email, user1_username, user1_date of birth. This information is for a particular user on the system. Aside from having basic information as we've listed, users on the platform have certain actions they can perform. This could include a user creating a post, changing a password, and so on. So we could represent these actions with functions. Remember that functions in programming perform specific actions. So we are going to say def, which is for defining a function, user1 create post, print first post. Now suppose we want to represent another user on the platform. we would just need to do as we did earlier. We are going to create a new set of variables and functions. User2, email, user2, username, date of birth. User2 create post to represent the second user creating a post. The problem with this approach is that it is not efficient. If we have multiple users in the system, repeating this same process is not efficient or scalable. Rather than repeating these similar pieces of code, what if we have our own defined structure or template for creating any users on the system? After all users have the same information and the same actions, such as creating a post. Our own defined structure, template, or blueprint for creating real users on the platform is called a class, while the actual users that we create using this blueprint are called objects. In object-oriented programming, everything is seen as an object created from a template or blueprint known as a class. I hope you now understand what a class and an object mean. We've only used a user as an example, but this same idea can be applied to anything. For instance, you might want to represent products that you are selling. You can simply create a blueprint for products so that any real product you want to create would then use the blueprint. Alright, we've talked about classes and objects, but how do we represent them in programming? To create a blueprint which is the same as a class, you just need to use the class keyword and specify the name of the class. In our case, let's call it user, class, user, followed by a colon, then press enter. The convention when naming a class is that the name should start with an uppercase letter. If you need to use more than one word, then you can follow Pascal case naming convention. How do we create the real users based on these blueprints? Remember that the real users you create from a blueprint are called objects. To create an object from a class, you need to mention the name of the class, user, followed by parentheses, similar to when calling a function. I'm going to assign this object to a new variable, user1 equals. So you can create as many users as needed. User2 equals user. We are using the user blueprint, which is a class, to create real objects. So you can create as many user objects as you want from a single class. You see, the objects you create are also called instances, signifying an instance of a class. I hope you understand. That's why the process of creating an object from a class is also referred to as instantiation. Now you may want to ask how users would exist on the platform without basic details or information such as email, username, and so on. Those details and information about an object are called attributes. For a product you sell, attributes would include things like price, color, size, production year, and so on. The question now is, how do we represent this using code? For this user 1, how do we say his email is 1@gmail.com, age is 10, and so on? How do we do the same for the second user? This can be achieved using the idea of functions. It works by passing those pieces of information to each individual object, just as you do when calling a function. For the first user, we can say the email is 1@gmail.com and the age is 10. For the second user, let's say the email is 2@gmail.com and the age is 20. For now, let's print out the type of these objects to see what is displayed on the screen. Print type of user1, user2. Let's execute the program to see the output. There is an error. There is an important step we omitted. You can't just declare those attributes and move on. You need to let the class be aware. Remember that we mentioned that classes are defined blueprints or structures. There is a special function called init that needs to be defined inside the function. Def init self. This function is responsible for creating a real object from a class. The first argument you need to pass to it is self. Self is referring to the object being created. Then you can now proceed to specify all the data and information that would be passed to the class when a real object is about to be created. In our case, we can call those information email and age. So you are telling the class that whenever this object is about to be created, some extra data would need to be passed. By the way, any function that you find inside a class is called a method. Class functions are called methods. If I were to run the program, you would see that it works. Great. The type of user1 and user2 is user as shown on the screen. We've only told the class that whenever an instance of this class is to be created, email and age must be passed. For those pieces of information to be attached to the instance that is about to be created, we need to make use of self. Remember I said earlier that this self is referring to the instance or object that is being created. You have to say self, which is this object or instance that is about to be created, followed by dots, then the name of its attribute, which is email, equals the email that was passed, which is this email. We have to do the same thing for the age. Self.age, that is the age attribute of this object, equals the age, that is the age that was passed here. Any pieces of information or data that you attach to an instance are called instance attributes. The init method is called a constructor because it is responsible for constructing or creating an instance from a class. This init method is automatically called whenever you try to create an instance of the class. Any method whose name starts and ends with a double underscore has a special meaning in Python. Now that user1 and user2 have some attributes, it becomes easy to access those attributes once an instance of the class has been created. So it is possible to say user1 dot the attribute, which is email. Let's print this to the terminal. Print. We can do the same for the second attribute, user1 dot age. So let's execute the program to see the output. Great, we are now able to access those attributes on the instance or the objects. If we pretend to omit the values that are supposed to be passed, then Python will raise an error. Let's try that out. Let's comment out this second user. Then we can remove this data from the user1 object. Let's execute the program to see what happens. Python raised a type error. User init method missing two required positional arguments, email and age. Like I mentioned earlier, the implication of this is that whenever an instance of this class is to be created, then these two values must be provided, email and age. Also, if you notice, this init method takes three arguments, self, email and age, but we've only passed two arguments here. What happens is that whenever you call a method on an instance, Python automatically passes the instance or the object as the first parameter. So this self is referring to the instance. Any method having the first parameter as self is called an instance method. Instance methods operate on an instance of a class. Remember that instances are the real objects created from a class. I need to mention to you that you can update an instance attribute after it has been created through the init method. So let's print out the email value before we update the value. Before update user1.email. Now let's update the email attribute on user1. User1, we need to mention the name of the object, user1.email equals a new value. Let's call it 3@gmail.com. Let's print out the value after the update. After update, user1.email. Let's execute the program to see the output. Great, it works. We have been able to update the email attribute on user1 after it has been created using the init method. The risky part about this is that you can even add a new attribute that does not conform to the structure you've defined in the class. Let's add a new attribute different from email and age to the user object. user1.price equals 100. Can you see what we are doing on this line? We are going against the defined structure. Price is not part of the initial attribute we want when creating a user. Imagine someone comes to the platform and adds unsuitable attributes such as price to a user. Then there is a problem. So let's print out the value of price. Print user1.price. Let's execute the program to see the output. As you can see, it works. We are able to set a new attribute on user, and we are also able to retrieve that attribute from the user, user1.price. Later on, we are going to explore how these kinds of actions can be prevented. Now, we are able to associate data, also known as attributes, to an instance of a class. Instances or objects don't only possess attributes, but they also have actions they can perform. For example, a user can create a post, change a password, and so on. You represent objects' actions as functions in a class. Let's go ahead and create a new action for an object. Let's name the function createPost. Def createPost. It takes the first parameter as self. Print firstPost. This function or method takes the first parameter as self because it is an object that would need to perform this action. The interesting thing is that we are able to access an instance attribute within this method using self. Self is referring to that instance. So we can say first post by self.email. Let's make use of f strings. Alright, so we are able to access the email attribute on that instance. Now let's go ahead and make use of this createPost method. User1, the name of the instance or object, dot. Then we need to make use of this createPost method. We need to call the createPost method on the user instance. That's how we can call a method on an instance of a class. Immediately we call this method, which is this method here, this inner part of the code was automatically executed. First post by, which is the email address, by 1@gmail.com. Let's create another user instance. User2 equals, the email is 2@gmail.com and the age is 20. User2 dot createPost. Let's call the createPost method on user2 instance. Now let's execute the program again to see the output. It works. First post by 2@gmail.com. This means we are able to easily access an instance attribute from this method. Remember that any method that takes the first parameter as self is an instance method. That means we can call this method on an instance of a class. For now, the user can only post a constant string, which is first post. Let's modify this method to accept another parameter, which is going to be the post content. So we cannot make use of the content in the createPost method. That means whenever we want to call the createPost method, we must pass the contents. Let's say hello world. For the second, hi there. Alright, let's execute the program again to see what happens. It works. Hello world by 1@gmail.com. Hi there by 2@gmail.com. Remember that self, which is the instance, is automatically passed to the instance method. So you only need to call this method with a single parameter, which is the contents. For the product example, you might want to ask what would be a suitable action a product instance can perform. Well, think of methods as functions that serve as a means to an end. when a user tries to buy a product, we need to compute the total price based on the price and quantity. So it makes sense to have a method that computes the total price. So the implementation will look similar to what I have here. GetTotalPrice would be a method, which is actually a function that can be called on that product instance to get the total price of a product based on the quantity that was passed. We now understand the meaning of classes and objects. Objects are the same as instances of a class. Instance attributes are the details about each individual object. Whenever there is an information that you don't want to tie to a particular object, then you can associate such information with the class itself. Let's consider the name of the company selling the product as an example. If we decide to associate the company's name with each object, then we would have to keep mentioning the name every time we are creating a new object. So that means we would have to say company_name. This is clearly a repetition. Any piece of information that is generic to all instances or objects is a good candidate for what we call class attributes. Class attributes are details that are tied to the class. Class attributes are placed immediately after the class definition. Company_name equals, let's call it Moon Inc. You don't mention class attributes as part of the init method. Remember that the init method is responsible for creating an instance of the class. For the Facebook app, the app name would be a good candidate for a class attribute. Now, you might want to ask, how do we then access class attributes? Class attributes can be accessed in two ways, either directly on the class or through an instance. Let's try to access the class attribute through the class. You need to mention the class name, product, followed by a dot, then the class attribute, company name. Let's print this to the screen. Alright, so let's execute the program to see the outputs. It works. The class attribute, which is company name, has been printed to the screen. The second way to access a class attribute is through the instances. Let's use the first instance of product, which is product1. Now let's print out product1 dot company name. Let's comment out the first part of the code. Print. Alright, so let's execute the program again to see the output. Great. We are able to access a class attribute from an instance of a class. Whenever you try to access an attribute on an instance, it first checks if the instance has the attribute. If it doesn't have it, then it proceeds to look for it in the class. If it is not found in the class, then it throws an attribute error. Let's try to use an attribute which cannot be found. Let's say company year. Let's execute the program to see what happens. Python raised attribute error. Product object, that is this object, which is an instance of a class, has no attribute company year. Do you mean company name? Again, when you access an attribute on an instance, it checks the attribute on the instance first before moving on to the class to look for it. However, if you access an attribute on the class, it only checks the class. It doesn't go and look for it in the instances. I hope you understand. Let's try that out by using this line 77. Let's try to access product.name. This attribute is not present on the class, but it exists as an attribute on the instance. Let's execute the program to see what happens. Python raised attribute error. Type object product has no attribute name. I want to give you another use case for class attributes. Suppose we want to be able to track all products created on the platform. How do we do that? So what we could do is to define a container such as a list to keep the products for us. Let's call it all_products equals an empty list. We know for sure that this init method is automatically called for every product created. Then we can say self.allProducts. This is how we can access a class attribute from inside an instance method. self.allProducts, which is a list data type, dot append self. Self is that object that is being created. Now let's go ahead to create a couple of products. We have 3 products here: socks, shoe. We've created a couple of products which are the same as instances of the class. We can access all products attributes either directly on the class or any of the class instance. For now, let's access it on the class itself. Print products, which is the class, dot all. Let's run the program to see the outputs. This shows that 3 objects have been created. 1, 2, 3. We have 3 objects created. 1, 2, 3. The name of the class, which is product, and the memory address, product object at this memory address. We don't really like how the objects are represented here. There's a special method called rep_arg, which is short for representation. This method controls how an object is visually displayed. Remember that any method whose name starts and ends with double underscore has special meaning, so they are called special methods. We are going to declare this method to have a custom representation of our objects. Def double underscore rep_arg. It takes the first parameter as self. We are going to make it to return a class name, which is product. Let's make use of f string. Then the name of the product, self dot name, and price of the product, which is self dot price. Alright, let's execute the program again to see the progress so far. As you can see, we now have a better representation of the objects, which are the actual products on the platform. If you don't want to add code the class name, which is product, in this case, you can make use of the class name attributes on self, which is the object itself. Let's try that out. So we are going to say self dot double underscore class dot double underscore name, which is the name of the class of the object. Let's comment out this first part of the code. Alright, let's execute the program again. Great, we have the same results. Alright friends, we've discussed class attributes. There are some functionalities, functions, or methods that don't fit into being an instance method. For example, you might want to get the count of all the products on the platform. You should not tie that kind of functionality to an instance or a specific object because it is generic. Those kinds of methods are called class methods, and they take the first parameter as CLS. Let's move on to create a method that returns the number of products we have. Get product count. It takes the first parameter as CLS, not self. CLS simply means the class. Inside the method, we can say platform underscore products equals CLS. CLS is pointing to the class, which is product. All products, which is a class attribute on the product class. Return the length, len, of platform products. This is going to return the length, that is the number of items in these all products. The final step is to tell Python that this method is a class method. We need to use class method decorator as class method. Alright, we are telling Python that this method is a class method. Now, how do we call this method get product count? We can call it directly on the class since it is a class method. Python also allows this kind of method to be called on an instance. For now, let's move on to call it on the class itself. Before that, let's create a couple of products. Alright, so let's say this one is socks, shoe, shirts. Let's call this class method on the class itself. The name of the class is products. Dot the class method get product counts. This method is expected to return the length, that is the number of products we have. Let's call it products underscore count equals this. Now let's print out product count. Print product counts. Now let's run the program. We have 4 returned because we have 4 items or we have 4 products all together. So we are able to call the class method on the class directly. Like I mentioned, Python also allows us to call this method on an instance, but most of the times you would want to call this kind of method on the class. So let's say pro.1 equals this product. Now let's call the product on an instance, which is product1 dot get product count. Let's comment out this part of the code. So product count equals this. Now we can print out the product count. Let's execute the program to see the output. We have the same result. If your project requires that you need to pass an extra argument, then you should do. That means you would need to declare an extra parameter here. Alright friends, the final type of method we need to discuss is a static method. This category of methods is not bound to a specific class or instance. Unlike class and instance methods, static methods do not have access to class data or instance data. The price is an instance attribute. An instance method can have access to an instance attribute. An instance method such as getTotalPrice can access instance and class attributes. This getTotalPrice is able to access an instance attribute, which is price, and also this method is an instance method, but it is a special method. It's able to access a class attribute, self.allProducts. A class method such as getProductCount can access a class attributes, which is allProducts, cls.allProducts, but a static method cannot access either of the two attributes. Most times you use a static method as a utility function, a function that helps you to do something. Let's define a method that returns the current time. Def getCurrentTime. It doesn't take self or CLS as the first parameter. You need to use @static method decorator to flag it as a static method. So we can call this method directly on the class pro.class.getCurrentTime. Let's set it to a new variable, current_time equals this. Print current time. Let's execute the program to see the output 12 p.m. Let's also try to call it on an instance of the class product1.getCurrentTime. Let's comment out this part of the code. Current time equals product1.getCurrentTime. Let's execute the program again. We have the same result. If there are some data or attributes that you really care about, then you should make them read-only. Let's consider an instance of our product. Product1 equals product, the name of the product, and the price. With the current implementation, it is possible to read and modify the price of a product after it has been created. Let's try to access the price of product1. Print product1.price. Now we are going to update the price. Product1.price equals 150. Print product1.price. The expected output now is 150. Let's run the program. We have 150 as the new price. The first problem with this approach is that an untrusted user can decide to manipulate this price to another value. This is possible because the user is able to modify the price attribute directly. The second issue is that a user can set the price to an invalid data type by mistake. Let's change the price to a string ABC. Let's execute the program again to see what happens. As you can see, it still works. You won't know there is a problem until you try to call a method where those values are used. Let's get the total price of this product. Print product1.getTotalPrice. GetTotalPrice, where is the method? We need to pass the quantity. Let's say we are buying 4. Now let's execute the program to see what happens. Before that, let's comment out this part of the code. Alright, so let's execute the program now. The getTotalPrice method returns an invalid value because a string data type was passed as the price. Sensitive data such as the price should be read-only when accessed from outside a class. To make the price attribute read-only, you can use a double underscore before its name. This convention signals that the attribute is intended to be private. Using double underscore limits direct access from outside the class. So now let's say self.double underscore equals the price that was passed. Now what we need to do now is to update our code base to reflect this new variable, double underscore price. We used the price variable here as well. Now this price attribute is private, which means it can only be accessed within the class methods. Let's pretend to access the price attribute from an instance. This is an instance of the class. Let's say product1 price. Let's comment out this part of the code. We are trying to access an attribute which is now private from outside the class, such as from an instance. Let's execute the program to see what happens. Python raised this error because this double underscore price attribute is now private, which means it can no longer be accessed from outside the class. It can only be accessed from the methods within the class. Now, the attribute we care about has been effectively hidden and cannot be accessed from outside the class. The next step is to use the @property decorator to create a read-only attribute. The name of the method will be the read-only attribute you want to create. Let's say def price, which is the name of the price attribute we want to create. Self return, you need to return the value of that attribute that is now hidden, self.double underscore price. And the final step is to make use of a decorator @property. This attribute, which is price, is now a read-only attribute, which means we would be able to read the value of the price from an instance, but we won't be able to modify the price because it is a read-only attribute. So this is how you can create a read-only attribute in Python. Remember, price is a read-only attribute. Let's execute the program to see what happens. Great. We are now able to access the value of price. Now what we want to do now is this. Let's try to modify the value of price. Let's say product1.price is now 90. Let's see what happens. Python raised attribute error. Attribute error. Can't set attribute price. We are not able to set attribute price because price is now read only. You can only read the value. You can't set the value from outside the class. Sometimes you want to be able to set the price. This means you want your program to respond to something like product1.price equals 90. To achieve that, you need to provide a setter. Setters are just a way to provide more control over how we set attributes. First, you need to use the @ symbol. Then the name of the attribute you want to set. In this case, price.setter. Now you cannot specify the name of the method as price, def price. It takes the first parameter as self, then value. Pass. The value you receive when users try to set the attribute is captured as value. The main purpose of a setter is to have control over what the user wants to set. You may want to put restrictions on what the user can set as the price, and so on. We want to be sure that the user is sending a number. If not, instance the value and the instance int floats. If the value the user is trying to set is not an integer or a float, then we want to raise an exception. Raise value error. Price must be a number. If value is less than 60, raise value error. Minimum amount is 60. Else, if all the conditions are met, we want to set the price value dot double underscore price equals
the value. We have been able to provide a setter for price. Remember that price was read-only before. Alright, so let's go and try out this in our code. Product1.price equals ABC, a string. Let's execute the program to see what happens. As you can see, price must be a number. Now let's use a value which is less than 60. Let's say 50. Let's run the program again. We have the error, which is value error. Minimum amount is 60. Now let's use 90. Let's execute the program. So that's how we can make use of getters and setters. Getters are the same as the read-only property, that is, you are able to get or read the value, while setters allow you to set the value of a specific attribute. Alright friends, the first principle we want to discuss is inheritance. In object-oriented programming, it is possible for a class to inherit from another class. Suppose we have two classes, animal class and cat class. We can make the cat class to inherit from the animal class. We just need to put the class from which it inherits inside parentheses. In front of the cat class, we are going to put parentheses, then we are going to mention the name of the class from which it inherits, animal. The class that inherits from another class is called the child class, while the class from which it inherits is called the parent class. In this case, the cat class is a child, while the animal class is the parent class. The implication of this is that a child class would be able to access all attributes and methods in a parent class. Now, let's define some attributes and methods in the parent class. Def eat. It takes the first parameter as self because it is an instance method. Print animal is eating. Let's define another method, def move. The first parameter as self, print animal is moving. Now let's go and create an instance of the cat class. Cat1 equals cat. Cat1 dot. Whenever you call a method on the cat instance or try to access an attribute, it first checks the cat class to see if they are declared. If they are declared in the cat class, everything works fine. If they are not declared, it will go up to look for them in the parent class. Let's call the eat method on a cat instance, cat1.eat. The VS Code is already suggesting some methods. Let's also declare another class attributes, animal underscore type equals domestic. Now let's access it from the cat instance. Print cat1 dot animal type. Let's execute the program to see what happens. It turns out that a cat is able to access all attributes and methods from animal due to inheritance. What happens if within the cat class we define a method that has already been defined in the animal class? Let's try that out. Def eat self print cat is eating. As mentioned earlier, the first place checked when looking for attributes and methods is the class itself before going up to any parent class. The expected output from the eat method call is cat is eating. Let's run the program to see what happens. It works, cat is eating. What you've done here is called method overriding. It involves redefining a method that is already defined in a parent class. The benefit of this is that it allows child classes to implement methods the way they want. But sometimes you may want to explicitly call a method in the parent class. The super function comes in handy here. Now let's make use of super. When you use the super function, you are essentially telling Python to provide you with access to the parent class. So once we add a dot after the super function, the code editor displays the attributes and methods that we can access on the parent class. We can then choose to call any of these functions. Now let's execute the program again to see what happens. Animal is eating is printed to the screen because we are calling a method from the parent class by making use of the super function. Remember that the super function allows you to access attributes and methods on the parent class. This type of inheritance is called single inheritance because we are inheriting from a single class. Alright friends, Python supports what is known as multiple inheritance. This means that a single class can inherit from multiple classes. When this happens, the child class will be able to access all attributes and methods from all these classes. Another question arises: when the same method is defined in multiple parent classes, which one would the child class pick? As you can see, the move method is defined in all these classes: move in parent 2 and move in parent 3. If we call this method from a child class, which one gets executed? Now let's assume that there is no move class in the child class. We are going to comment out this method. Now let's create an instance of child1. Child1 equals an instance of child1. Child1 dot move. We have this move method defined in all the classes: parent 2, parent 1 and parent 3. The answer to this question is provided by what we call method resolution order, MRO. Methods are searched from bottom to top and from left to right. Bottom to top means that a method is first searched in a child class before moving up to a parent class. Left to right indicates that it traverses from left to right when searching in parent classes. Now, if I were to run this program, the expected output would be parent2 move. The move method cannot be found in the child class. Then it moves up to search for it in the parent classes, and the first parent class is parent2. When it looks for the method in parent2, the method is found. That means parent2 move would be the expected output. Let's execute the program. Great, the answer is parent2 move. This rule also applies when the super function is used to access an attribute or a method in the parent class. It follows the method resolution order when searching. Let's make use of the super function in the move method, super.move. Alright, so let's change the order of the parent classes. Parent 3 to be the first. Now, if I were to run this program, the expected output from this move method call would be parent3 move because the move method is found in parent 3. Let's execute the program again to see the outputs. Parent3 move. A class has the MRO attributes, which allows you to inspect the method resolution order. Print child1 dot double underscore MRO. Method resolution order. This is going to print out the method resolution order. Let's execute the program. As you can see, the first class is child1, followed by child3, 2, 1, and finally objects. Let's put parent1 to come first. Parent1. Let's execute the program again. Great. As you can see, immediately after the child, we have parent1. Alright friends, now that we have some understanding of inheritance, let's put it into practice using the product class as the parent class. We are going to create a new class called shirts that inherits from product class. Shirts, it inherits from the product class products. Pass. It means that shirt will be able to access methods and class attributes from the product class. Let's create an instance of shirts. Shirts1 equals shirts. Print shirt1, which is an instance of the shirt class. If you notice, we are not yet passing information to the shirt. Let's execute the program to see what happens. As you can see, Python throws an error that the init method of product requires 2 arguments. Whenever you instantiate a class, Python will check if you've defined an init method inside the class. We didn't declare this init method in the shirt class, but because shirt is inheriting from products, Python goes up to look for that method in the parent class, which is this init method we have here. As soon as Python sees this init method, it calls it, but the needed arguments, which are name
and price could not be found. To resolve this error, what we can do is to create an init method in the Shet class that takes the needed argument as parameter. Let's define the init method in Shet. Def init self, it takes the first parameter as self. Then we want the name to be passed as well as the price. This means whenever we want to instantiate this Shet, we must provide the value of name and price. So now let's make use of the super function. This super function returns the parent class super.init. We want to call the init method on the super function. Remember that this init method is pointing to the init method in the parent class, which is the init method in product. The init method in product takes name and price. So we are going to pass the name and the price. You don't need to pass self. Self is the actual instance you are trying to create, and it is automatically passed. Now let's go ahead and run the program again. I forgot to pass the name attribute and the price to the Shets. 20. Now let's execute the program again to see what happens. Great, it works. Let's call the getTotalPrice method. Total price equals Shet1 dot getTotalPrice. We need to pass the quantity, let's say 5. Point total price total price. Alright, let's execute the program to see the output. Great, it works. Total price is 100. Let's also call the getProductCount. It returns the length of all the products. We are going to say the Shet class dot get product count. Let's print this to the terminal. Print. Alright, so let's execute the program to see the outputs. Great, it works. We only have one product. Let's add one additional product. Socks. Price is 10. Right, so let's execute the program. Great, it works. So all the methods and attributes present in the parent class can be accessed in the child class. The benefit of this Shet class is that you can include methods and attributes that are only specific to the Shet class, or you simply want to override the implementation of a method in the parent class. Encapsulation is when you prevent object attributes from being overridden from the outside. It is a way of protecting and restricting access to data. We mentioned while discussing getters that you can hide an attribute from the outside by using a double underscore before the attribute name. When you do this, it means that this attribute is only available for use inside this class. Other programming languages such as Java use the private keyword to signify that an attribute can only be used internally. We are able to access the double underscore price attribute only inside the class. So if we try to access it from outside the class, it won't work. Double underscore price. Print this to the terminal. Print. Let's execute the program to see what happens. It shows attribute error. Product object has no attribute double underscore price. Do you mean price? You can also do the same thing for methods. You can make a method to be private by making the name to start with double underscore. Let's call it process report. Def process report. Print processing. This kind of method is private. It can only be used inside the class. Let's create another method that sends the report to the user. Send. This method is not going to be private. Self dot double underscore process report. As you can see, we are able to access the process report method within the class. Print report sent. Report sent to the user. So this means from a product from a product instance, product1, we can't call this process report because it is a private method. It is meant to be used inside the class alone. If you know that a method is of no use when it is accessed from outside the class, then you can make it private. As you can see, this process report method is used internally by another method, which is send report. Let's execute the program to see what happens. Attribute error. Product object has no attribute. Process report. Now let's call send report to the user. Send report. Let's execute the program. Great, it works. Processing, report sent to the user. So this is how you can make attributes and method to be private. That is encapsulation. You are protecting them from the outside world. The abstraction principle says that you should only show necessary information and hide unnecessary information. Consider the example of visiting youtube.com to search for a specific video. Upon typing and pressing search, various videos are displayed, and that's the extent of your knowledge. The details of where the videos are stored, how they are displayed on the screen, and all the operations happening behind the scenes are not known. These hidden details are abstracted from the user because the user does not really need them. Understanding the internal workings of the entire YouTube platform is unnecessary for the user. The whole process of hiding unnecessary information from the user is known as abstraction. Abstraction is concerned with the high level and not the details. Applying this concept to programming, abstraction can be achieved through abstract classes. It means that we can have an abstract class which only provides a high-level overview of what something does, without revealing the details. So we can define an abstract class called abstract product. Class abstract product. This class needs to inherit from ABC for it to be an abstract class. We need to import ABC from ABC, import ABC, and abstract method. We can define some abstract methods within this class by decorating them using the abstract method. Get total price, self, pass. We need to decorate it with abstract method at abstract method to make it an abstract method. Abstract classes do not reveal implementation details. An abstract class is only showing a high level of the methods in a product. Every class inheriting from these abstract products must implement this method. Now let's create a product class that inherits from the abstract class. Class product. It inherits from abstract product class. Def get total price, point price is 50 naira. Let's go ahead to instantiate the product class. Product1 equals product. So now we can easily call the method on the instance product1 dot. Let's execute the program to see the output. It works. Total price is 50 naira. Abstract classes are meant to be subclassed. Let's create another product. Product2 abstract product, an instance of abstract products. Let's execute this program to see what happens. Python raised a type error. Can't instantiate abstract class abstract product. So we are not meant to instantiate an abstract class. Any class inheriting from an abstract class must implement the abstract methods declared in the abstract class. Let's decide to omit the get total price. So now let's try to instantiate product1. Let's execute the program. Python raised an error. Any class inheriting from the abstract class must implement the abstract method. Remember that the abstract method is just a high level. It doesn't provide the implementation. I hope you now understand the meaning of abstraction. Polymorphism is the ability of an entity to have multiple forms. depending on the context which it is used. First, let's take a look at the len function in Python. The len function behaves differently depending on the context which it is used. With a string data type, it returns the number of characters in the string. For a list data type, it returns the number of items in the list. Let's execute this program to see the output: 3 characters and 5 items in the list. A function is said to be polymorphic when it behaves differently in different scenarios. This len function is polymorphic because it behaves differently in different contexts. Similar to function polymorphism, operator polymorphism is when an operator behaves differently depending on the context it is used. When you use the plus sign on strings, it performs string concatenation. Meanwhile, when it is used on numbers, it performs summation. This behavior is known as operator polymorphism. If you want your custom object to respond to plus, minus, and so on, then you need this set of special methods to be defined in your class. domo_sub, and so on. Some programming languages allow you to have 2 or more methods with the same name but different arguments. In those programming languages, the implementation would look similar to what we have here. You would have multiple methods with the same name. Python does not support this exact behavior. So whenever you call the method, it picks the one where the arguments match. For example, if you call the sum method with 2 arguments as integers, then the first method would be executed. If 3 arguments are passed as integers, then the second method would be executed. Python does not support having multiple methods with the same name but different arguments. However, you can achieve a similar behavior using default values. Let's create a method with a default value a, b, c, and a default value of c, none. If you call this method with just a and b, it works because you have provided a default value for c. When c is provided, then this default value is not used. Another kind of polymorphism is method overriding. A child class inheriting from a parent class is able to override or redefine an already defined method in the parent class. This process allows a single method to have different behavior. We've discussed method overriding in detail. Make sure to check it out. If you enjoyed this video, make sure to give it a thumbs up. For more practice questions, be sure to check the description below. Subscribe, like, and comment. Thanks. What's going on, friends? As your program gets longer, you may want to split it into several files for easier maintenance. This is where modules and packages come in handy. In this lesson, I will be explaining what modules and packages entail in Python. Without any delay, let's dive in. A module is a Python file containing Python definitions and statements. When we say definitions, we mean things like variables, functions, classes, and so on. For us to be able to use the content of this Python file in another module, we need to make use of the import keyword. Let's create a new module called main.py. main.py. This file is going to serve as the entry point of our application. Within this main.py module, we want to be able to access the content of the product module and the helpers module. The first and the simplest way to achieve this is to import the module itself by using the module name. We need to make use of the import keyword import, the name of the module, which is products. When you do this, you are now able to access the content of the product.py file, which is also a module. On the next line, let's say products dot. As you can see, the code editor is already showing us the content of the product module, max price, and the product class. This is the max price, and this is the product class. Let's go back to the main.py. Now we can decide to make use of the definitions in the product module. Let's print this to the terminal. Print max price. Let's execute the program to see what happens. Great. As you can see, the value of the max price from the product module is now printed to the terminal. Now let's pretend to access a variable we didn't declare in the product module, max units. If I were to run this program, you will see that Python will raise an error. Attribute error,
module product has no attribute max units. Alright friends, the second way of importing is to import individual objects. In such case, we need to say from module name import specific object. Let's try that out. From module name, which is products, import specific object such as max price products. With this approach, you only import what you need. For instance, if you are not using max price, you can decide to omit it. Let's go ahead to create an instance of the product. Product1 equals product class. We need to supply the name and the price. The name is shirts and the price is 10. Let's make use of max price imported. Now on the product instance, we can call the get total price. Product1 dot get total price. We need to pass the quantity. Let's pass 5. Let's print this to the terminal. Print. Alright, now let's execute the program. We have the total price printed to the terminal. As you can see, we are making use of the individual objects found in the product module, max price and the product class. This is how we can import each individual object from a module. It is even possible to import everything at once by using the asterisk symbol. That means we can say from product import asterisk. This is going to import everything found in the product module. Let's execute the program again to see what happens. As you can see, the program works as expected. Using asterisk to import all objects is not recommended in large-scale code base because this could lead to conflicts. I'm going to declare the max price variable in the helpers function. Max underscore price equals, let's say, 100. Let's go back to the main.py. From helpers module import all. That is, import everything found in the helpers module. Now, if you notice, the max price variable can be found in the product module and the helpers module. Let's execute the program to see what happens. This output shows that the max price value used is coming from the helpers function because it was the last module imported. Let's change the order of the import to see what happens. The output is now 50, which means the max price value is coming from the product module. Alright friends, an imported module or object can be accessed using alternative names. This is where the as keyword becomes useful. We can opt to import an object such as max price and access it using a different name at the location where it is imported. Let's try that out. So we can decide to say from product, import product as generic product and max price as price. In this main module, we imported max price, but we want to access it with another name. That's why the code editor is showing that products and max price are no longer defined. Generic product and max price as price. Now let's execute the program again to see the output. Great, it works. A Python module, which is simply a .py file, can be used in two ways. It can either be imported for use by another module or executed as a standalone script. We've seen how it can be imported by using the import keyword. If you want to run it as a standalone script, then you need to mention Python followed by the name of the file or the name of the module. In this case, let's say Python 3 main.py. This command executes the content of a Python file. If you open up the Python interpreter shell and you import the same module, you will see that text are printed to the terminal. Let's try that out. Let's open up the Python interpreter shell and import the main module Python 3 import main. As you can see, a text is printed to the terminal. This is because the import statement is actually executing everything found in this module
So when it gets to this line of code, this method is executed and the output is printed to the terminal. Most of the times you use the import statement, you actually want to use it to import object from a module, not to call or execute the object. To fix this, we need to be able to distinguish when a module is imported and when it is run as a script. Whenever a .py file is imported as a module, Python sets the special variable _name to the name of the module. However, if a file is run as a standalone script, the variable is set to the string _main . So we can decide to say if _name equals _main, we want to execute this line of code. If this special variable _name is equal to _main , then it means that the module is executed as a script, which means we can run any relevant code in this block. Now let's try that out again. Exit Python 3 main. Great, it works. Now let's import the module. Python import main. Great, as you can see, this part of the code is not executed because the module is now imported. A package is a collection of modules organized in a directory. Packages are particularly beneficial when structuring larger projects or libraries. Suppose you are developing a very large application that includes many modules. As the number of modules grows, it makes sense to organize them based on what they are doing. Let me show you a sample code base. As you can see, everything that has to do with user is put in a separate folder. The same goes for messaging and notifications. This approach of structuring the code base makes it easier to maintain. For instance, if we need to update some functionalities about users in the future, we know the directory to go. The fact that we have a directory which is the same as a folder and a couple of modules inside it does not automatically make it a package. For Python to identify a directory as a package or a sub-package, the directory needs to contain a special file named _init . So the init file tells Python that the directory containing it should be treated as a package or a sub-package. The init file could be empty, and most of the time it is, but it can also contain initialization code. First thing first, let's make this package directory an actual package by creating the init file inside it. Let's create a new file called _init. We are just going to copy the content of this module folder, Ctrl+C, then Ctrl+V, paste. Now let's see how we can access the content of a package from an external file. Let's create an external file outside of the package. Touch external.py. Okay, so now we have a new external file outside of the package. To access the content of the package, first we need to mention the name of the package. The name of the package is package, so we're going to say from package dot, we want to import from the helpers module, import max price and get current price. From package dot product, import max price and product. Let's get rid of the max price from the product module. Alright, so let's print max price and get current time. Remember that external.py is a file outside of the package. Now let's execute this program to see what happens. Great, this is how we can make use of the contents of a package from outside the package. I mentioned earlier that the init file is needed to make a directory a package, but as of Python 3.3, a package can be created without the init file. A package created without the init file is called a namespace package, while the one created using the init file is the regular package. I recommend you stick to using the regular version. What that means is that if we omit the init file, our program is still going to work, inasmuch you are using Python 3.3 version and above. I have a link in the description explaining the difference between the two. While explaining modules, we've seen that using the asterisk will import all the content of a module. However, sometimes you only want certain declarations such as functions, variables to be imported. The all attribute is used to specify which names should be imported. Whenever we write from module, import all. Let's go to the product module to use the all attributes. So we are going to say _all equals the list of the objects we intend to import, max_price. This means that only the max price will be imported whenever we use the asterisk symbol. As you can see, the code editor is saying product is not defined. That is because product is not included. Let's go back to the product module. Now let's include the product class product. Let's save the file again. Now let's head over to the main.py file. Yeah, you can see that we can now access the product class. Let's run the program again. Great, it works. The all attributes can also be used in init files within a package or sub-package to ensure that only specific modules are imported when using wildcard imports on packages. For instance, within this package, we only want the product module imported whenever the asterisk is used. Now let's define the all attribute in this file. Double_all equals a list of modules product. Alright, now let's go back to the external file. In this external file, we are going to say from package imports all. Now we can make use of products from package import all. This means that only the module defined here would be imported, which is product. Print the product module dot max price. So now let's try to access the helpers module. Print helpers dot. As you can see, we are not able to access helpers because helpers is not included as part of what should be imported whenever the asterisk is used. For now, let's execute the program to see the progress. Great, as you can see, we are able to use product because we have included it as part of what should be imported whenever we use the asterisk. Alright friends, some modules come with Python by default, meaning that you don't need to perform any additional installations once you have Python installed. For instance, you don't need to install anything when working with modules like math, CSV, OS, and so on. So you can easily say imports math, imports CSV, imports OS. These sets of modules are called built-in modules. However, if you need other packages or libraries developed by other developers, then you need to first use pip to install the package. For instance, you can say pip install fast API to install the fast API library or package. I have an article explaining how to publish your own Python package so that you and other developers can start using it by running pip install the name of the package. If you find value in this video, please like, comment, and subscribe. Thanks. What's going on, friends? Generators are a more advanced feature in Python. A common use case is to work with large files. I believe the best way to learn is to work on projects once you understand the fundamentals. We are going to build a video streaming service using Fast API. In this project, you will learn how Python generators can be a powerful tool for handling video data efficiently. As you can see, as soon as I play the video, an API request is made to the server. Small pieces of data are subsequently streamed back to the client as they are being retrieved from the data source. With this approach, users don't need to wait for a 500 megabyte video to be completely downloaded before they can start watching. The progress bar fills up as data is downloaded from the API. By the end of this lesson, you will understand why a generator is the perfect tool for this scenario. We are going to explain generators and their practical use cases. Then we will cover their implementation and finally the video streaming project. Now let's get started. Alright friends, to fully understand generators in Python, you need to understand both iterators and iterables.
Any object that you can perform a loop operation on it is an iterable. Examples of iterable include string, list, tuple, dictionary, and so on. Numbers are not iterable because loop operation is not possible on them. Let's consider this example. We are trying to perform a loop on an integer. If I were to run this program, you would see that Python will raise an error. Let's execute the program. Type error, int object is not iterable. This is because we tried to loop over an object which is not iterable. I hope you now understand the meaning of an iterable. On the other hand, any object that implements these two special methods is called an iterator. These methods allow the object to produce its items one at a time. You use the iter function to turn an object to an iterator. The next function returns the next value in the iterator. Let's take a look at the second example. We have a list data type which is an iterable, and we've used the iter function to turn it into an iterator. Remember I mentioned earlier that an iterator produces its item one at a time. So we can use the next function to get the next item in the iterator until there's no more item. Let's make use of next of iterator. We want to print the result, the returned value, to the terminal. Let's execute the program. Great, as you can see, the next function returns the next element in an iterator. 1 is returned because 1 is the first element. So now let's make use of it a couple of times. Let's execute the program again to see what happens. Great, the next function returns the next element in the iterator. If I use the next function, Python raises a stop iteration error if I try to retrieve the next element and there is no more element present in the iterator. Let's run the program again. Stop iteration error on line 10, which is this line of code. Now that you have an understanding of iterables and iterators, let's begin exploring generators. Generators are a special kind of function. Whenever a normal function is called, everything in the function body is executed, and when it gets to the return keyword, the value you specify in front of the return keyword is returned back to the caller of the function. In this case, the summation returned is set to a new variable named total. In short, the return keyword terminates a function, so anything you write after the return keyword within the function is ignored. But when a generator function is called, it returns an iterator, meaning that it generates values one at a time. The generator function will continue to generate values until there are no more values to generate. Unlike a regular function which uses the return keyword, a generator uses the yield keyword. Let's take a look at this example of a generator function. Whenever you tell a generator function to give you a value, the function body is executed, and as soon as it encounters the yield keyword, the value you put in front of the yield keyword is returned. The good part about a generator is that when next you tell it to give you another value, it is able to remember that it stops here. So the second time you tell it to give you a value, the execution is going to start on this line, and a new value is returned when the yield keyword is encountered again. This is why generators are said to remember state, which means that they are able to resume execution from where they left off. Now let's call this generator function generate data. We would like to know the type. Let's print the type to the screen. Print the type of generate data. Let's execute the program. As you can see, the type of what is returned is a generator. When I hover over the function, the code editor is showing that the return type is a generator. If you observe, you will agree with me that generators are iterators because they are able to produce or generate values one at a time. What that means is that we can use the next function to retrieve the next item generated by a generator. So now let's make use of the next function on a generator in order to get the next element or the next item in the generator. Let's say data, which is a new variable, equals generate data. Now we want to call the next function on the data. The first time you use the next function on the generator, the function body is executed, and as soon as it encounters the yield keyword,
the execution is paused and the value in front of the yield keyword is sent back to the caller. The expectation is that if we run this program, these two lines of code are printed to the screen. So now let's execute the program. I'm just going to drag up the terminal. Now let's run the program. Great. Don't be surprised that the returned value is not printed. For us to be able to access the return value, we can either set it to a new variable or print it directly on the terminal. So now if we run it again, we should see batch1 returned on the screen. Fantastic. So the second time you call next, the generator will resume its execution from where it stops. That means the execution will start from line 24. Immediately it encounters the yield keyword, the value is sent back to the caller. So now let's call the next function on the generator again to see the output. It works. Second set of data is ready, which is coming from this line, and the value that was sent back by the generator is batch2 returned from this line on line 25. This process continues until there is nothing left to yield from the generator. At that point, a stop iteration exception is raised. Now let's call the next function on the generator the third time. Let's run the program. If we call it again, a stop iteration error will be raised because there is nothing left in the generator. Let me drag up the code editor. As you can see, stop iteration. This is because nothing is left in the generator. Alright friends, let's take a look at this infinite sequence generator. When you call the next function on the generator for the first time, the function body starts its execution. Whenever you come across while true, the loop body is expected to run forever, except if you introduce a break statement in it. Remember that this loop body will always run because true will always evaluate to true. So this means the first time you try to generate a value from this generator, 0 is sent back to the caller. Let's run the program to see the output. The second time you tell this generator to give you another value, the execution starts from here, which is line 40, because a generator is able to remember where it stops. So at this point, number equals number plus 1. This line 40 is equivalent to saying number equals number plus 1. So the value of number is going to be number, which is 0 plus 1. So that means the value of number is now 1. The loop body again is executed. For the second iteration in the loop body, the value of number is now 1, which means at this point yield 1. 1 will be sent back to the caller. Now if we execute the program again, we should get a value of 1. With this approach, we can generate an infinite sequence. Remember that you can always use a for loop with a generator. The for loop will run as long as the generator is yielding values. So now let's try to use a for loop on this generator for each in sequence print each. This is an infinite loop because this generator will always return a value. Now let's execute the program. As you can see, this program keeps running except if you manually terminate the loop. I'm going to press Ctrl C. Alright, I hope you are beginning to visualize why generators are a good tool for operations involving large data processing. Generators improve the performance of an application because you don't have to process all the data at once. Instead, you can start delivering data to the users in small pieces as soon as they are available. Additionally, generators reduce memory usage because the computer does not have to load the entire dataset into memory at once. A common cause of application crash is outage memory usage. This happens when your program needs more memory than is physically available on the system. Alright friends, in addition to the yield keyword, yield from is another keyword commonly used in generators. If it turns out that your outer generator needs to generate value from another generator known as sub-generator, then you can make use of yield from. In such case, the value returned by the sub-generator is made available to the outer generator, and the value is returned to the caller of the outer generator. Let's try out this example. Gen for generator equals outer generator print next. Then we can pass the generator inside. Now, if you call the next function on this generator, this function body is executed, and as soon as it encounters yield form, it knows that the responsibility of generating a value has been transferred to another generator. So that means this generator is executed and the value returned by this inner generator is 1. This 1 is now returned to the outer generator, then returned back to the caller. The execution for the first time is going to return 1. If we call the next function on the outer generator again, the inner function is responsible for producing a value, which means that any line of code after the first yield is executed, then it encounters another yield, which is yielding the value of 2. The value of 2 is now sent to the outer generator, and the value is returned back to the caller. So the value now is going to be 2, 1, 2. Alright friends, let's begin the video streaming project. The first thing we want to do is to identify the packages needed to get the job done. We are going to use FastAPI, a Python web framework, to serve requests coming from clients, and the Jinja2 template to serve an HTML page when a user visits a page on the web application. Let's document those packages by writing them into a file. Let's create a file named requirement.txt. These are the packages needed and their versions. UVCon is used as the web server. Now the next thing we want to do is to create a virtual environment. Virtual environment is like a container to keep the dependencies of this project separate from another project. Let's make use of the Python 3 command to create a virtual environment in this directory, venv. As you can see, a new directory has been created, which is a virtual environment. Now we have the virtual environment created. Let's activate it by using this command source venv bin activate. Great, as you can see, the virtual environment has been activated. Now the next thing we want to do is to install all these packages in the created virtual environment. Let's do pip install -r requirements.txt. We are now installing all the libraries needed. Let's create a module which is going to be the entry point of our application, touch main.py. Alright. Let's import the relevant classes and modules from the FastAPI package. From FastAPI, import FastAPI. We also need to import request and status. From FastAPI.templating, import Jinja2 templates. We can now initialize the app by creating an instance of the imported FastAPI class. Let's say app equals an instance of the FastAPI. As you can see, when I move the mouse over the FastAPI class, it shows that it takes a couple of arguments. Let's just pass the title as video streaming. Title equals video streaming. Also, we are going to use the Jinja2 templates to specify the location of the HTML files to be used. We are going to say templates, a new variable, equals Jinja2 templates, which is an instance of Jinja2 templates. Jinja2 templates is also a class. So we can pass the directory of the template. The directory of the template is going to be templates. What that means is that we need to create a folder or a directory named templates. That is where our HTML files will be kept. Let's create a folder called templates. Alright, we have the folder created. Now let's start defining the URLs or the APIs. The first URL we want to serve is when a user sends a GET request to the root of a domain such as readonread.com. We are going to say at app.get, which means a GET request, and the path, which is the same as the URL, is going to be this. When you are on a local machine, the root URL will be served at localhost port 8000 on port 8000. Whenever a user visits the root, we need to define a function to handle the request. Let's name the function home async def, which is for creating a function home.
It takes the first parameter as request, and the type is request, which we have imported. Return, we want to return an HTML templates dot template response. We are going to pass the name of the HTML template. Let's call it index.html. We also need to pass the context, which is expected to be a dictionary. Contexts are extra information you want to send from a route, that is from a URL to the HTML template. So let's say context equals a dictionary, and the first item we want to pass is request, which is this request. Let's also pass the title. We are going to call the title Fast API Video Streaming. Fast API Video Streaming. Let me format this document. So whenever a user visits the home page, we want to return an HTML template to them. The name of the template is index.html. Let's go ahead to create the index.html template. I'm going to create a new file here called index.html. So for the content of this index.html, it is going to be a basic video tag. As you can see, this is a basic HTML page with some stylings. Yeah, so this is the video tag we want to use. Like I mentioned to you, you can send some information from the route to the HTML template. The title we are sending from the route can be captured as title here. We just need to use these double curly braces. Now what we want to do is to run a local development server. To start the local development server, I'm going to copy the command from the Fast API documentation. Alright, so this is the command uvcon main app reload. So let's go to our project. Let me open up a new terminal. As you can see, uvcon main app reload is the command to run the Fast API application. Main is pointing to this file, that is this main module. Then the app you pass to it is the app defined in the main module. Alright, so now let's go ahead to run this command to see what happens. So now let's copy this URL to visit the website. Great, as you can see, immediately we visit the home page, a 200 response code is sent back to the client, which means that everything is fine. Now let's try to play the video to see what happens. Another API call to stream video is detected, but a response code of 404. 404 means the URL is not found or it is not defined in this application. If you look at this HTML file, as you can see, the API call specified for the source of the video, which is stream video, is not defined in our application. Now this is a good time to define the API call to handle the video streaming. Let's go back to the main.py module. Now let's define another route to be handled in our application. We want to define a get request to stream video. Let's define the function to handle this route, async def, which is for defining a function. Let's call the function stream video, stream_video. We need to pass the first parameter as request, and the type is request. Since we intend to start sending chunks of data to the client as soon as they become available, we need to use a response called streaming response. So let's go ahead to import the response from fastapi.response import streaming response. Let's head over to the documentation to see how the streaming response works. For us to be able to use a streaming response, we need to pass a generator. Streaming response takes an async generator or a normal generator or iterator and streams the response body. Let's go back to our code to continue the implementation. So it means that we need to return a streaming response. The generator name content equals, the generator name is going to be generate video chunk, generate _video _chunks. Now let's go ahead to define these generate video chunks. def generate video chunks generator pass. Within this generator, we need to access the data source, which is the video file, and read a certain part from it. Let's scroll up to define the location of the data source. Video underscore file equals a string, let's call it video.mp4, and the chunk size we want to read at a time, chunk underscore size equals 1024. In this generate video chunks generator, we want to open the video file and read a certain part from it. Let's make use of context manager to open the file with open the video file. Let's specify the video file, and the mode of reading is going to be read binary as file object while true chunk equals the file object, and we want to read a certain part from the file object. Let's pass the chunk size, which specify the size of what we want to read from the file. If not chunk, that is when this chunk is an empty string, we want to break out of the loop. Otherwise, we want to yield the chunk, Essentially, you make use of this kind of loop when you don't know in advance the number of times a code block will run. This code block is going to run forever if you don't break out of the loop. If not chunks, this means when an empty string is returned, which marks the end of the file. Lastly, you want to send the chunk read to the caller of the generator. Suppose you have a file with this content A, B, C, D, E, F. If the first call using the read method stops here, the next call is going to start from here, which is letter D. So at some points, it will return an empty string, which is when there is no more content available. Now, the next thing we want to do is to specify the headers when returning the chunks. Let's say headers, which is a new variable, equals a dictionary. We need to specify a couple of information here. First, the content type, video/mp4, and also the accept ranges, bytes. We also want to specify the content encoding. The value is identity. And also we need to specify the content length, which is the size of the file. For us to get the size of the file, which is the video file, we can get it from the file object. To keep it simple, let's make use of the OS module. Let's say file size equals, we need the OS module. Let's import the OS module, import OS. So we can say os dot start, then the video file dot st size. This is going to return the file size as an integer. The return type is an integer. So we want to make use of the file size in the contents. File size, let's convert it to a string data type. Finally, we need to specify the content range. Content range equals content range f strings, which is starting from 0 to the file size -1 divided by the file size. All this information are needed by the browser to know how to handle the streamed content. Now let's pass the header. Let's say headers equals the headers we've defined up here. Also, we would like to pass the status code equals status. I believe we've imported status. Yeah, we've imported status dot http 206, which is a partial content. Now we need to specify the media type. The media type is video/mp4. Let me format this document. Before we move on, let me print a counter on the screen to keep track of how the chunks are generated. I'm going to initialize the counter here. Counter equals 0. Then before the yield, counter equals counter plus 1. Print chunk counter. Also, let's print something on the screen when the chunks end of chunk. The first time this generator function is called to produce value, it opens up the file. Since true is true, this block is expected to run. A chunk is then read on this line. If the chunk is empty, then we want to break out of the loop. Otherwise, yield chunk, which means a specific chunk is returned to the caller. The second time you call the generator to get data, it resumes the next line following yield, because generators are able to remember the state or the point where they left off while true. So this block of code is executed again, which means another iteration is performed. This process continues until the file content is empty. Let me look for a video file to put in this directory, video.mp4. So I'm just going to put the video in this directory. Alright, now let's go ahead and try out the app. 127 on this port. We have a new request to the home page. Now let's play the video. Great, as you can see, the chunks are being generated. This is the progress so far. So the chunk generation is still in progress. I can play the video right now. We want to be able to access the content of the product module and the helpers module. The first and the error module. With this approach, we don't need for the whole file or for the whole video to be downloaded at once before the user can start watching the video. As the chunks are being generated, they are streamed back to the clients. Alright friends, I believe by now you have a proper understanding of generators. Something you might want to consider is connecting to a cloud storage like AWS S3 buckets or Google Cloud Storage as the data source of the video. For now, the video is sitting on the local server. Also, HLS video format can be considered. HLS involves separating a single video into separate files, so contents are streamed to the front ends as they are being requested. I hope you enjoyed the video. Please like, comment and share. Thanks. What's going on friends? While explaining scope, we mentioned that when functions are nested, the inner function can access variables declared in the outer function. Calling the outer function will make everything in the outer function body to be executed. This means that this inner function will be called as a result of the outer function call. Let's run the program to see the output. As you can see, the inner function was able to access a variable declared in the outer function. Now let's do something interesting. Instead of executing the inner function here, what if we return it? Let's say return the inner function. At this point, calling the outer function will return a function. You are able to return and pass a function around because functions are first-class citizens in Python. Now let's set the outer function call to a new variable named inner, since we know that inner will be returned when the outer function is called. If I were to print the type of inner, you will see that it is a function inner. Now let's execute the program to see the output. Great, as you can see, the type of what is returned by this function is a function. One thing we can also do is to make the outer function to take an argument. Let's say x. Then we can get rid of this x. What that means is that we must pass an argument to the outer function when we are calling it. Let's pass the value of 50. Now let's execute the program again. Great, you can see that the type of the returned value is a function. So that means we can decide to call inner, which is a function returned by the outer function. So if we call the function now, that means we are calling this function. And when we call this function, this part of the code will be executed. Let's execute the program again to see the output. Great, as you can see, the inner function was called. Now is a good time to define what a closure is, since you have the needed understandings. A closure is a nested function which allows us to access the outer function's variables even when the outer function is closed. You will agree with me that we should not be able to access a variable used in a function once the function has been called and discarded.
but closures, which are the inner function, make that possible. So the outer function variable is 50. After the outer function call, we are still able to access the variable passed to the outer function. If you notice, the value of x is coming from the outer function. So on this line, we are still able to access the value of x after the outer function has been called. Remember that variable x belongs to the outer function. Let's take a look at some real use cases. First, you make use of closure to avoid unnecessary use of class. If it turns out that you have a class having just a few attributes or methods, then it is advisable to use a closure. Suppose in your application, you want to be able to generate users with different permissions. In this case, what you really care about a user is the permission. Let's do a class implementation for that. We are going to define a user class user, then the init method, which is the constructor method. It takes the first parameter as self, then we want permission to be passed. The permission is string type. Now we can say self.name equals read1array self.age equals 10, and finally self.permission to be the permission passed. Now let's define an instance method. Def get user info. We need to pass self as the first parameter since it is an instance method. So we want to return the user information as a dictionary. Let's say name is self.name, age is self.age, and the permission of the user is self.permission. So now let's go and create instances of this class. Read only user, read underscore only underscore user equals an instance of the class, and we need to pass the permission. Let's say read only. Now we can create another user. Let's say write only user equals an instance of the class, and the permission is write only. So on each of the instances, we can call get user info. We want to print this to the terminal. Print read only user dot get user info. Let's execute the program. As you can see, we have the user information. If you observe this implementation, the only attribute we care about is the permission. We have just a method present, which is this instance method, get user info. In that case, using a class is unnecessary. Let's go ahead to do a closure implementation. Let me comment out the previous code. Now let's make use of closure. We are going to say def user underscore factory. We want the permission to be passed whenever they are trying to create the user. The permission is of a string type. Then within this user factory, we want to define another function, def user. Let's declare some information about the user. User underscore info equals a dictionary. We are going to say the name is read1array and the age is 10, and finally the permission is the permission passed. Then we want this user info returned. Return user info. We can now say return the user. So this user is a closure. First, it is a nested function, that is a function living inside another function. The nested function is also able to access a variable defined in the outer function. And thirdly, the nested function is the returned value. This makes this user function to be a closure. Now let's make use of the closure. We are going to say read only user, read only underscore user equals user factory. When you are calling a user factory, you want to pass the permission read. When you call this user factory, the user inside is returned. Remember that the user inside is a function. So the function returned by user factory has been set to another variable. Since read-only user is a function, we can call it. When we call this user, it is going to return user info. Now let's print the returned value on the screen. Print. If I were to run this program, you will see that the output would be the same as the previous output. Now let's execute the program. Great, we have been able to access the relevant information without using a class. Another use case of closures is data hiding. It is obvious that data inside an inner function cannot be accessed or modified except by calling the outer function. And finally, Python decorators use the concept of closure. More will be discussed about decorators in the upcoming lesson. I hope you now have a better understanding of closure and its usage. If this is your first time here, please consider subscribing to the channel. Don't forget to like, comment and share. Thanks. What's going on, friends, and welcome back. In this lesson, I will be explaining decorators in Python. Understanding closures in Python is a prerequisite for this lesson. Make sure to check the link below for the previous lesson where we explained closures. These three properties make a function a closure. First, it is a nested function, which means a function inside another function. Second, it is able to access a variable in the outer function. Third, it is the returned value in the outer function. This user function sitting inside the user factory function is a closure. Now let's move on to explaining decorators. A decorator is a function which takes another function as an argument, with the sole aim of extending or decorating it. You can think of a decorator as a wrapper that provides additional functionality to an already existing function. Suppose we have a function named greet. The greet function does not know how to greet correctly. It only calls out the name of the other person. Let's define the greet function def greet. The docstrings greets a user incorrectly. That function returns a name. For now, let's make it a constant name, Ridwanray. Now let's define another function which takes a function as an argument with the aim of decorating that function. Let's name the function greeting decorator def greeting underscore decorator. It takes a function as an argument. Now within this function, we want to define a closure. Let's name the closure wrapper def wrapper. We are going to say name equals, we want to call the function that was passed to the decorator. And we cannot say decorated name, which is a new variable, equals f strings hi and the name returned by the called function. Now let's return the decorated name, return decorated name. Now we want to return the wrapper, which is a closure wrapper. Essentially, we are calling the passed function here. Remember that the greet function returns only a name. So we want to add extra text to what it normally returns. Now let's go ahead to make use of the greeting decorator. Remember that a decorator takes a function as an argument. So we want to pass a function to this decorator whenever we are calling it. Let's create a new variable. Let's call it decorated greeting. Equals, we want to call the greeting decorator. Now for us to call the greeting decorator, we are going to pass a function which is greet. When you call this greeting decorator, everything inside the function body is executed and the wrapper function is returned. The wrapper function returned is set to a new variable. So we can go ahead to call the function decorated greeting. We can call it because we know that a function is returned. So if we call this function now, it means that everything inside the wrapper function will be executed. Let's print the returned value on the screen. Print this. Now let's execute the program to see the progress. Great, we have been able to decorate the greet function, which only returns a constant name. If you take a closer look at this code, you will agree with me that we are calling this wrapper function. Greet decorator returns the wrapper. This is similar to how closure works. Based on this understanding, we can say that decorator wraps another function and adds extra functionalities to it. Another question we need to answer is, how can we pass arguments from a function so that the decorator can make use of it? The previous example uses a constant string, which is read1ray. What if we need to greet someone else? That means the greet function needs to take a parameter name, and the type is of a string data type, and the name will be the returned value. Now, should we pass the name here, let's say Ray? If we do that, Python will raise an error that greet decorator takes just a single argument. If you take a look at this greeting decorator, it only takes one parameter, but we are trying to pass two arguments. Let's execute the program to see what happens. As you can see, Python raised a type error. Greeting decorator takes one positional argument, but two were given. So this means this cannot work. A good place to pass the argument is here, which is in the decorated greeting. Remember that when you call this function, you are really calling the wrapper function. So we can pass the username here, let's say Ray. What that means is that the passed name can be accessed here. So we can say passed underscore name. So now we can call this function, which is the greet function, with the passed name. Let's say passed underscore name. Now let's execute the program again to see the output. Great, it works. Sometimes you may not know in advance the number of arguments that would be passed to the function we want to decorate. In such case, we can use *args and *kwargs. *args will capture the positional arguments as a tuple, while *kwargs will capture the keyword arguments as a dictionary. The above syntax of using a decorator works, but Python provides a better alternative. If you want to decorate a function, you can simply place the @ symbol on top of the function you want to decorate, followed by the name of the decorator, name of decorator. This is an easier approach to use the decorator. Now, let's go ahead to decorate the greet function. Let's comment this out. Then we can bring down the greet function. Now, we want to decorate the greet function. We just need to use the @ symbol, then the decorator, which is greeting decorator. Now, what you've written here is the same as this. This means that you want to decorate the greet function with another function. It is the same as passing the greet function as an argument to the decorator. Now let's go ahead to call the greet function greet. We want to print the returned value on the screen. Print this on the screen. Now let's execute the program to see the progress. Alright, I forgot to pass the argument, which is Ray. Now we can execute the program again. Great, it works. Alright friends, we've seen how to use a single decorator, that is, using a single decorator to decorate a function. It is possible to decorate a function with more than one decorator. If you take a look at this ordinary function, you can see that we have two decorators on top of it. The order of execution is from the base to the top. That means decorator 1 will be executed before decorator 2, as shown in this code snippet. Let's add another decorator to add a prefix to a name, such as Mr. Now, let's define a new decorator. Let's say def prefix decorator underscore decorator. It takes a function as an argument. Then within this function, we want to create the wrapper function, which is the inner function, also known as a closure. This wrapper function takes the name as an argument as defined here. In this wrapper function, we want to say name equals, we want to call the function with the passed argument. Then we want to say prefix underscore name equals f strings. We want to say Mr. Then the name returned from the function call. We want to return the prefix name. Return prefix name. We need to return the wrapper. Return wrapper. Now let's go ahead to make use of the greet function. First, we want to add a prefix to the name, prefix decorator, before greeting the name. Now let's call the greet function with the required argument, which is name. We can now print the returned value on the screen. Now let's execute the program again. Hi, Mr. Ray. Remember that the order of the decorator really matters. So if we were to do this, we are going to get another output, Mr. Hire, which is not desired output. What you've done here is similar to this. Let's make use of the previous syntax we were using. First, let's say decorated greeting. Then you want to first call the prefix decorator, and in the prefix decorator, you want to pass the function you want to decorate, which is greet. Then again, you want to make use of another decorator, which is greetings decorator. Now, you cannot make use of this. We want to pass the name, let's say Ray. We want to print the output to the screen, which is this print. Now let's execute the program to see the result. Oh, we should have removed this. Now let's execute the program again. Great, it works as expected. Before I move on to show you something, I want to add docstrings to the wrapper function. I'm going to say prefix decorator, and also for the previous decorator, which is greeting decorator, I want to add a docstring as well, which is greeting decorator doc. As we've seen from the previous example, a decorator wraps another function. Let's try to access the name and the documentation of this greet function. So we are going to say print the greet function and a special variable called name, which returns the name of the function. We also have another special variable called docs. Now let's execute the program to see what is returned. We are able to access the name of the greet from the function and the documentation of the greet function, which is greets a user incorrectly. Now, if we make use of a decorator, let's make use of a decorator. Let's see what is returned now. As you can see, this output shows that the decorator hides the greet function information. It only returns the information of the closure, which is the wrapper function. To fix this, we need to use the functools module provided by Python. We need to import functools, which is a built-in module. Now let's go ahead to make use of the functools. So on top of the wrapper function, we want to say functool at functool.wraps, then the function passed. Now if we were to run the program again, everything will work fine. Great. The decorated function is now returning its metadata. Some commonly used built-in decorators in Python include @property, @class method, @static method, and so on. These decorators are used with methods defined within a class. Alright friends, all the decorators we've used are functions. In this one, we are going to discuss how a class can be turned into a decorator. In Python, any object that you can call using a pair of parentheses is said to be a callable. We are able to use parentheses with greet decorator because greet decorator is callable, which means it can be called. If I were to set the value of greet decorator to be a string data type, you will see that Python will raise an error. Let's say ABC, which is a string. Now let's execute the program to see what happens. Python raised a type error. String object is not callable, which means you can't call a string object. In short, you can't use a pair of parentheses to call a string. The implication of this is that if we were to use a class as a decorator, then a class must be callable. By default, classes are callable because you can always create instances of a class by calling the class. The first question is that, can a class be called? The answer is yes. Classes are callable by default. Second, can we pass arguments to a class when we are calling it? Absolutely yes. By making use of the special init method, we can do that. And the third question is a class instance callable? Remember that we are going to call an instance here. We can make an instance callable by defining this special method. So now let's go ahead to turn a class to a decorator. Let's name the class greetDecorator. We need to define the constructor method def_init. It takes the first parameter as self, and when we are calling this class, that is when we are instantiating it, we need to pass a function. So let's say func
which is for a function. Now we can say self.func equals the passed function. Now let's define the special call method. It takes the first parameter as self, pass. When an instance of this class is called, the name needs to be passed. So let's say it takes a parameter name. Now let's call the function returned underscore value equals, we want to call the function self.func and we want to pass the name as an argument. F strings hi, the returned value from the function call. We can now try out this. Let's make use of this here. Decorated greeting equals the greet decorator, which is a class. When you instantiate this class, this special init method, which is the constructor method, is called. The greet function you passed here is this, and we are making instances of the class to be callable by defining this call method. When you call this instance, you are expected to pass a name. The name is captured here. Alright, now so let's go ahead to try out the program. Great, it works. Finally, we can make use of it using the @ symbol. Ctrl C, I'm going to comment out this. Now I want to decorate the greet function by using the greet decorator, which is a class. Now let's call the greet function again, and the output should be printed to the screen. Print. Let's execute the program again to see the outputs. We didn't pass the required argument. Alright, it works. Decorators are commonly used in logging. This might entail measuring the execution time of a program or inspecting arguments used in a function call. For example, if you wish to determine the duration it takes for a function to complete its execution, we can import the time module to achieve this. What that means is that before the function call and after the function call, we can note the time. Also, decorators are extensively used for authentication and permission checks within frameworks like FastAPI and Django. Within this function, we can do some checks before calling the actual function. For instance, we may want to restrict some certain names. I hope you now have a better understanding of decorators. Don't forget to subscribe to the channel. Like, comment and share. Thanks. What's going on, friends? Concurrency and parallelism are two ways you can speed up your program. In this lesson, I will explain these two concepts. I will also discuss some misconceptions about multithreading and multiprocessing. Without any delay, let's get started. Concurrency happens when multiple tasks are running at a time. This means we are dealing with a lot of things at once. For instance, you have 4 assignments to complete and you want to finish them as soon as possible. You start the first assignment, then stop at some point. You move to the second one. After working on the second assignment for a while, you stop and switch to the third. This process continues until all the 4 assignments are finished. If you notice, we are not simultaneously working on the assignments. We are only switching context from one task to another. Any system that works like this is said to be concurrent. In a single core CPU, the ability to switch between multiple tasks is known as concurrency. We can achieve concurrency by using threads and asynchronous programming. In threading, we can have multiple threads, and the operating system actually knows about each thread. The OS can interrupt a thread at any time to start running a different thread. Now that you understand the meaning of concurrency, let's explain parallelism. Parallelism means executing multiple tasks at exactly the same time. Parallelism is about doing a lot of things simultaneously. Going by the example we used before, we can have 4 different people, each assigned a single task. In this case, we are doing all the 4 assignments simultaneously. I hope you can now see the difference between parallelism and concurrency. Let's take a look at the differences. Multithreading and asynchronous programming can be achieved on a single core system. For multithreading, the OS decides when to switch between tasks. Multiprocessing is only possible in a multi-core system where tasks can run simultaneously on different processors. Each approach has its own advantages and disadvantages. The best choice for a particular application will depend on specific requirements. We will cover how to choose the right approach later. This code downloads the content of the websites in a given list. We are going to rewrite this code to use multithreading, multiprocessing, and async I/O.
Before we start the implementations, I would like to show you the syntax for each of the approaches. First, let's start with threading. To create a thread, we need an instance of the thread class. Let's import the thread class from the threading module. From threading, import thread. Now let's create an instance of a thread. Thread equals thread. There is a couple of arguments we can pass to the class. The target refers to the function we want this thread to execute. We can also send some arguments to the function. Let's create a function named task. Def task. The function takes x as a parameter. Then let's print something on the screen in the function body. Thread executed. Value to be x. Now we can pass the new function as the target, which is task, and also we can pass the arguments args. A tuple, let's say 9. Once a thread is created, we can run the thread, which will execute the function we passed to it. The start method is used to run a thread. Thread.start. One thing you should know about the start method is that it doesn't block, meaning it returns immediately. It doesn't wait for the function to complete. We can demonstrate this by using the time module to cause a delay in the thread. Import time. Now we can say time.sleep to sleep for 5 seconds. Let's put a print statement after the start method, waiting for the thread. Let's run the program to see what happens. As you can see, the line following the start method is immediately executed. It doesn't wait for the thread to be complete. We can wait for the task to finish by using the join method. Thread.join. The join method will wait for the thread to finish its execution. It also blocks the rest of the code until the thread finishes its execution. This print statement will be executed after the task is completed. Let's run the program again. Great, the line after the join method was executed when the thread terminates. An alive thread means that the run method of the thread instance is currently executing. We can check if a thread is alive by using the isAlive method. Thread.isAlive. Let's call the isAlive method after the thread has started. Let's also use it after the join method. Now let's execute the program. Before we start the thread is dead. Then after the start method, the status is true. And also after the join method, the status is false. So far, we've only created a single thread. Let's see how we can create multiple threads. I'm going to comment out this sleep. Let's make use of the range function for x in range of 5. T equals thread. The target is the task. We can also pass the arguments. Then we can say t.start to start the thread. Now let's run the program. So this is how we can create multiple threads. If we need to wait for all the threads to complete, then we can make use of a container to hold all the threads, which is for all the threads equals an empty list. Then we can say threads.append to add each of the threads to the threads. And finally, we can say for each in threads, each dot join to wait for each of the threads. A race condition is when two threads run the same code and access or update the same resource. You can use a lock to ensure that only one thread at a time executes a sensitive section of the code. We need to import lock and create an instance of the lock. Then we can create an instance of the lock before the thread. Lock equals lock. Now we can pass this lock as an argument to the task. Then we need to update the task to accept lock. We can then use a context manager for the lock. With lock, this lock ensures that only one thread can execute this part of the code at a time. The thread pool executor class was designed to be easy and straightforward to use. Let's import the class from concurrent.futures import thread pool executor. We can now make use of the class by using a context manager with thread pool executor class, max workers. The max workers refers to the number of threads, 2 threads, as executor. On the executor class, we can call the map method. The first argument we need to pass to the map method is the function, which is the function we intend to run in the thread. The second argument we need to pass is an iterable. Items equals 1, 2. For each element in the iterable, the task function will be called, and the element is passed as an argument to the function. The map method will return an iterable immediately. The iterable returned from the map method can be used to access the results from the function. So we can say results equals. We can then use a for loop to access the contents of results. For results in results, print results. Let's make the task function to return a value. Now let's execute the program. Great, as you can see, we are able to access the returned value. Let's comment out this part of the code. Now let's execute the program again. It works. That's how to use the map method on the executor. The second method we can use is the submit method. The submit method submits one task to the thread pool for execution. Let's try that out. With thread pool executor.submit. The first argument we need to pass to the submit method is the function to be executed by the thread. The function is task, and also all arguments to the function. Let's say 1. This method returns a future object immediately. So we can say future equals this, and the value returned by the future object is future.result. Let's print the result on the screen. Print results. Let's execute the program again. 1 is returned. To create a process, we need an instance of the process class. Let's import the process class from multiprocessing. From multiprocessing, import process. We can create a process by creating an instance of the process class. We can pass a couple of arguments, the target, the arguments, and so on. Let's pass the target to be the function. And also we can pass the arguments to be 1. We can then use the start method to start the process. We can also use the join method, process.join. The join method waits for the process to terminate. Let's execute the program. Great. This is how to create a single process. Now let's create multiple processes. Let's make use of the range function for x in range of 4. P equals process. Then the target to be the task. And also we can pass the arguments as x, which is the value in the range, process.start. So this is how we can start multiple processes. Python provides an easier way to create multiple processes. We can use the process pool executor to create multiple processes. Let's import the process pool executor. With process pool executor, then we need to mention the number of processes as max workers. Let's say 2. As executor, results equals executor.map. We need to pass the function and also an iterable 1 and 2. For results in results, print results. The map method will return an iterable immediately. This is similar to how we used the map method on the thread pool executor. We can also make use of the submit method. The submit method submits one task to the process pool for execution. A synchronous program is executed one step at a time. When each step is complete, the program moves on to the next one. An asynchronous program also takes one execution step at a time. It may not wait for an execution step to be completed before moving on to the next one. This means that the program will move on to future execution steps, even though a previous step hasn't yet finished. Asynchronous programming is implemented in Python using coroutines. Any function defined with the async keyword is a coroutine. When a coroutine is called, it returns a coroutine object. This is similar to the usage of the yield keyword in a generator. When a generator is called, it returns a generator object. The await keyword suspends the execution of read data coroutine until db.fetchData completes and returns the data. Let's call this read data coroutine read data. We can just comment out this part pass. Let's print the output on the screen. Print. Now let's execute the program. The function call returns a coroutine. We also get a runtime error because the coroutine was created but never executed. We can execute the coroutine by using the async.io package. Let's import the async.io package. Print coroutine was executed. Now let's execute the coroutine async.io.run. The run function executes the coroutine and returns the result. So we can pass the coroutine to the run function. Now let's execute the program to see the output. Great, coroutine was executed. Let's make the coroutine to return a value, return 5. So now we can say result equals this. Now let's print the result on the screen. Results. Let's run the program again. It works. Alright friends, this code downloads the content of the websites in the given list. This is the synchronous version. We also have the async version. The async version is making use of the async.io module. As you can see, we also have the multi-threading version. We are making use of the thread pool executor class to create multiple threads. Let's check the multiprocessing version. The multiprocessing version is also making use of the process pool executor class to create multiple processes. The synchronous version takes approximately 18 seconds. The asynchronous version takes 1 second. The multiprocessing version takes 4 seconds. And also the multi-threading version takes 4 seconds. So the question now is, when should we use asynchronous, multi-threading or multiprocessing? The first thing you need to figure out is if your program is input-output band or CPU band. CPU band programs push the CPU to its limit. This includes programs that do image processing, searching, data processing, and so on. Input-output band programs spend time waiting for results from an external device. This includes querying the database, making network calls, reading and writing to a file, and so on. Multiprocessing speeds up Python operations that are CPU intensive because they benefit from multiple cores and avoid the global interpreter lock. Threads are best for input-output operations involving external systems because threads can combine their work more efficiently. You also use asynchronous programming for input-output operations. Coroutines are more lightweight than threads. We may have thousands of threads in a Python program, but we could easily have hundreds of thousands of coroutines all in one thread. This is the summary of what we've learned in this lesson. Don't forget to subscribe, like, comment, and share. Thanks.